Good morning, everyone. Welcome to this 141st edition of the Zak World of Façades conference series. My name is Ahmed. Uh, I'll quickly introduce the Zak World of Façades conference series, and then we can take this event forward. So we've been organizing this event since 2012. Bangalore was the first city where we organized this event. 27th June, 27th July 2012. This is the Taj MG Road. It was a small networking event. We started, and now the conference has grown globally. We are organizing this event in 40 countries around the globe, from New Zealand up until Canada. Across different continents, across different language barriers. It's been a great experience. Facades are designed, engineered, installed very differently in different parts of the world. The requirements are completely different when it comes to looking at facades, and most of the developed world now, I think facade is now been highlighted as one of the most important part of a building, especially with respect to carbon leakage. So there's a lot of emphasis on operational carbon, on embodied carbon. It's not yet so in India, but because we are building new, we are building greenfield projects, I think we need to also start implementing the usage of less carbon in our projects. So I think this conference will give you an overview of designs by local architects, international architects, and also engineering consultants, and manufacturing their products and manufacturers of products, on how you can design, engineer, install sustainable, safe facades. So yes, this is our 2024 lineup. It's just the second event of the year. We had our first event 2 weeks ago in Brisbane in Australia, and then 29 more to go for the year. Like to start off by thanking our event partners. So our presenting partner is Shuko. Shuko is a world leader in aluminum door, window, curtain wall systems. They're present in the Indian market since 2008 and growing in popularity. Aluminum system solutions are now becoming popular in the facade also. They're already popular in the window door segment, but now also with the requirement of sustainable sustainable products. System companies like Shuko are leading the way in Europe, and they will be leading the way through here in this region and other developing countries. Our powered by partner is Aluplex. Aluplex is one of the leading facade engineering contracting companies here in India, based out of Mumbai and Hyderabad. And then our associate partner starts with Cotswold Architectural Products. They are a manufacturer of hardware solutions for doors, windows, and facades. Dow is formerly Dow Corning in the Indian market. Dow Sill is their brand. Global leaders in sealing and bonding solutions for doors, windows, and facades. EdgeTech is part of Quanex Group. They have an interesting product, which is basically a warm edge spacer, which is slightly different from the conventional aluminum spacers we have. So this product helps in better U values. So when you talk of sustainability going forward, products like this can help you reduce the U value. They are debuting with us for the first time here in India in this event. Any product you do, you need to test the facade system, and Eminent is a facade testing laboratory which does exactly this from Hyderabad. So any for performance mock-up and other stuff for structural air tightness and other stuff, they have set up a testing lab outside Hyderabad. Euramax, along with their partners, Diamond Engineering Corporation, are distributors of aluminum coil solutions for different colors, for different applications on cladding, on roofs, on envelopes. Future Architectural Glass, one of the leading value-added glass processors based out of Mumbai and servicing the Indian market. Fundamax, again, world leaders in high-pressure laminate products, been with us since the inception of this conference here in India. High-pressure laminate is very popular in the Indian market, and Fundamax are always innovating with different applications now in the louver and different finishes every year. Haston Extrusion is one of fast-growing aluminium extrusion companies based out of Gujarat, I believe, are here partnering with partnering with us for the first time in this event. Jotun, one of the leaders in powder coating solutions, so they've got a wide range of products, including super durable powder, which lasts longer. Kinlong, again, global Chinese company, a lot of products, glass hardware, tools, fittings, LED, mesh, name it, literally buying and adding products every year. Kurare is the mother company of the laminated glass, interlayers, centric glass, and Throsifol. So for safety, security, ballistic, and other protection on glass, their interlayers are well preferred around the globe. So Mikasa is debuting with us for the first time. They've got some nice aluminium cladding solutions. Panasonic KMEW, they are also debuting with us for the first time. They've got a nice ceramic cladding product which is used on facades, again sustainable, non-combustible. Which is the way to go forward. Siderize, again, leaders in passive fire protection products. They are distributed with they are here with their Indian distributor Allark. Again, innovators in their field, single-use passive fire protection product, easy to install, easy to understand, and easy to use. And of course, our next event is in a couple of weeks in Dublin, in Ireland. We follow that up with our 2 back-to-back events in the US, in Chicago and Los Angeles. And then, of course, we're trying something different this year. We are actually trying our first 2-day event in a very different format at the Coca-Cola Arena in Dubai. We're trying to organize something like an art show, something which I think never before done, and that too in a concert arena. With some global celebrities already having presented at that arena. So we're transforming the arena into a conference, exhibition, workshop, and awards venue. And then, of course, the Zak Awards for Excellence in Facade Design and Engineering will take place at the end of the event, as a black tie gala dinner, something which we will plan to restart again in India the following year. We also go to Pune. Pune, a lot of commercial activity happening. I think it's time we bring this event to Pune. So we go to Pune on the 3rd of May after Bangalore here in India. We've got Delhi in August. We've got Mumbai in October. And of course, I think the platform on which this event was actually formed on are the 3 exhibitions on which we started doing this industry, which is basically on glass processing, doors, windows, fenestration, and aluminium extrusion. Our shows at the end of the year in Pragati Madan in Delhi, 5, 6, 7 December. So yeah, so this is it from me. I'm sure you're going to like today's event. We've got a nice variety of speakers. We've kept it less engineering, more design oriented, more aesthetically pleasing to the eye. We've got some nice keynote presenters also, local architects, international architects. We've got Christoph Timm from New York who's come over. We've got Rafael from Singapore, from ADAS, who've come over to present at this event. They've done some very large scale infrastructure and iconic projects for the Indian market. So they would be talking on their experience in the Indian market, their ideas, how they've incorporated and all that stuff. So I'm sure you're going to love today's event. So my role ends here. I'd like to call upon today's event host and convener from our powered by partners Aluplex, Rohan Keswani. He's the director there. He'll be taking you through until the end of the day. So Rohan, are you here? Yes, and sorry, I forgot to mention. We've recorded today's event. Those who would like to watch the recording, you'll receive a YouTube link a week from now, along with a feedback form. You can watch all the presentations which we have been allowed to share with you in a YouTube link. Okay, so that's it from me, and Rohan, over to you.
Right. Thank you, Ahmed, for setting the tone for the day. So Bangalore obviously is a city which is, the skyline of Bangalore has been driven by IT and technology, and that has in turn driven the demand for sustainable, energy-efficient facades. With each investor and owner wanting each building to be iconic, and that's what's really driven Bangalore to be a hub for the facade and fenestration industry. So today we have a brilliant day with a lot of, with 2 keynote speakers, not 1 but 2 keynote speakers sitting in the front row. We have a few architects, we have international facade consultants, and a mix of different product specialists. So to start off the day, we have Ms. Neelima Ronanki, who is studio director of Gensler. And please call her upon the stage for her first presentation of the day, which is to do with climate action through design, transforming the built environment to a net zero future.
Good morning, everyone. talk about climate action through design. Another solution that we have partnered. So Gensler has a product development wing as well. So here we have partnered with Irvine company to develop flexible furniture solutions so that can be actually kind of remodeled and reused for your space. You know, addressing climate change is a moral and business imperative of our time. And what we mean by that is when we say it's a moral imperative because the built environment that we're looking at affects humanity and the human environment space. And a business imperative because every building that is unsustainable or not resilient will be considered uninsurable and uninhabitable and undesirable. So we all know the risks of posed by climate changes are enormous, but the risk that is greater is taking no action on it. And we understand the industry is shifting. We are aligning towards these climate action goals, and in doing so, we see that the cost of doing sustainable projects is coming down, while the action of taking no action on climate sustainability, the risks are increasing. ESG has become a corporate governance goals right now, and rightly so, because we are looking at when we look at ESG, equity is something should be right on top of our minds, and elevating these marginalized communities is something that we should all focus on. And how do we achieve a built environment that is positive climatic and economic outcomes is through holistic design approach. In the next slides, we'll talk through how we are, what are the actions that we as a design firm are taking. So if you look at, the basic strategies that we're looking at is pursuing efficient strategies from day one. So climate action and sustainable resilience goals should be part of your project from the day one, the get-go. Use low impact, low carbon materials, working with climatic conditions. I mean, discovering solutions which mitigate the risk of rising waters and managing extreme heat. Build only when you need to and only as much as you need to. On this topic, we are also going to talk about adaptive reuse in the slides that are coming through. Yes, when you're talking about net zero energy, we have certain points on how we go about, achieving this net zero energy. One is understanding your building's energy profile, creating an energy budget from get-go, orienting your buildings to its surroundings climate, use building energy modeling to select your envelope, introducing exterior shadings. I mean, these are all back to basics again. Designing for daylight, considering outdoor programming, boost natural ventilation, reduce plug-in loads if possible, and prioritize whole system over localized solutions. We'll run you through a couple of examples that we're doing across the globe and how we're trying to achieve, net zero. So this is the SFO Terminal 1 expansion San Francisco. And if you actually see, it has about 53 million passengers every year. And it's targeting LEED Platinum, carbon zero operations, and the energy efficient terminal modernizing design is expected to reduce the intensity of project's energy by over 70% from 2015 levels. This is another student sustainable center in California, first of its kind. It's got a 24 kilowatt photovoltaic array on the roof, which actually caters to both conditioned and unconditioned spaces. It is also daylight autonomous. What I mean is you don't need to switch on your lights during the daytime. And another key energy efficient strategy is use of solar, thermal, and hybrid hot water systems. This is still in exploration stage. We are partnered with Studio Door and with EV partners S2E Technologies. We are actually exploring how do we make residential development and make them towards a net zero process. Okay, so how do you achieve these goals? When you talk about the materials that we use, using the right material is the key. And this is a study that is done by Gensler Research Center. So every year, 19% of our annual profits go into our own research center. And through that research, we actually found, so this is over a span of 60 years. And if you actually see, which we all know, the structural materials is something which has the maximum impact. But if you look on the longer run, all your interior furnitures, your workstations, your carpets, and your aluminum extractions, which we do, which actually undergo a lot of recycle and change over a period, almost impact the same amount. This is our own Gensler Minneapolis office. So this here we've actually utilized low, VOC material, low fixtures. It has a cross ventilation for daylight, and it also is used by mass timber production. That is something that we see is going up. And compressed laminated timber is also what we have used here. So this is another solution that we have partnered. So Gensler has a product development smart city carpets for your regular everyday office use, which is free of toxins and which is socially responsible. This is another project that we partnered with First United Bank, and this building will be the first fully mass timbered construction project to be completed in Texas, and is the first one to use the CLT panels. Now, we do understand that the real estate industry is changing and adapting. And when you're talking about climate changes, we see a lot of risk about rising waters. How do you go about mitigating? We'll talk about, certain points that we are developing as a flagship with the Florida municipality. Creating sponge roofs and permeable pavements, collecting rainwater, use of grey water, creating green and blue views, and which ultimately leads into creating a pedestrian-friendly accessibility. How to manage the heat? I mean, this is something which is, I would say, a man-made problem with the urban sprawl that we have right now. So again, back to basics, adding sunshades, creating building envelopes, replacing concrete and asphalt with more pavers which are absorbable, using native landscaping and partnering with local communities to kind of this is what we are working with. Gensler partnered with Florida International University and with Miami 21 for the zoning code. Sorry, where is it? Okay. So this is a prototype that we developed in creating a resilient city zoning. This is another example in Arizona Center where by using perforated solar screens and landscaping, we're trying to mitigate the harsh desert climate. Again, this is in Meshiba, downtown Doha. This we'd like to talk about. It is about Gensler partnered with Turner International and a lot of other international designs and consultants in downtown Doha, representing one of the highest concentration of LEED certified buildings in the world, with 11 LEED Platinum and 6 LEED Gold certified buildings to date. So adaptive reuse is something that we see, like what we said, is something that we should all adapt to because it has a lot of benefits. Couple of high-level ideas as to how it can be, and adaptive reuse can be at multiple scale. It can be through products reuse and recycle, interiors by designing for flexibility and using low carbon materials, building repositioning, and cities examining the new meet community needs. This is one example. If you're familiar with Bengaluru, you would know this is the Opera House, Samsung Opera House. So this is an 80-year-old building, which was an opera house during the British era. So Samsung approached us to kind of create this into their experience center. So we had a lot of challenges, but it was fun, interesting working on it. And if you actually look at how this gives back to the community is, there was a boundary wall. It was very cornered off as a building, but since it's situated between MG Road and Brigade Road, the idea was to open up, the boundary wall and invite people in. It increases the footfall to the event space, and also these are areas that you can actually rent. Even during the execution of the project, there were a lot of challenges that we faced. If you actually see, this was how the existing building is when we took over, and that's how it is made. So the challenges that we had is retaining the form and the shape of the building, still incorporating your sustainable goals along with your air conditioning. This is one of our famous projects, Post Office Chicago. This is a repositioning of 2.5 million square feet of Chicago's office, which was existing from 1925, converting into a office space. So we've again conceptualized one more project in Paris where we've looked at opening the facades and creating these, bringing this nature in. This is another project in Houston Center of similar project. And London, this is the existing building, what you see towards your, what you see here and what's converted now. So here we explored, since we were renovating, repositioning the project, we explored at having openable windows. And this is actually, it's achieved BREEAM Excellence and WELL Platinum recognition, which is the top of the assessment there. A couple of points on how we're planning to take through this, as a Gensler office. So we look at every practice area. So people who are familiar with Gensler, we have 33 practice areas, and every practice areas we're looking at having a sustainability expert along with us. And currently our sustainability expert sits in Singapore, and we have our office champion sitting out of Bangalore office. And we have gone back to the basics. So every project before we start, we actually measure the sustainable goals as part of your project performance. We have our own in-house DT technologies teams, which are constantly developing softwares to analyze the climate actions. And as part of our Gensler Research Institute, we have started a vertical dedicated for climate action and change. So this quickly talks about, what our goals are. So we have committed by 2030, every building that we design will be net zero. And if you look at the graph, this is where we are currently. And, if you look at 20% of our, So 20% of our top projects are here, and this is a goal for 2030. So 2020, we are here. This is the order that we have to cover. And this is a performance for the interiors, and that's for the base building. What it actually means is when we have tied up to the entire scale, we have realized the energy savings of our 2019 building portfolio is actually equivalent to powering 1.9 million homes for a year. So that is all we have for you today. Thank you very much for your time.
Sustainability is extremely important, and thank you for your insight on using various passive shading systems to reduce the operational efficiency of a building. But not just that, that's something which, we have all been working towards for a long time, but also talking about using materials and making sure the construction has lower embodied carbon by using materials that have been reused and using and retrofitting spaces without having to use fresh materials to build them again. I thought it was very insightful. We will unfortunately not be taking any questions right now, but we can all find Neelima after the break in the break to ask her any further questions. Next up, we have three more speakers in the session. We have T.S. Aditya from Fundamax, who will be talking about the use of laminate products in high-rise applications, about its versatility, as well as its non-combustible properties. After that, we have Mr. Ritesh Jindal from Arup, who is an expert in terms of complex geometries and parametric equations, who is somebody who I've known for a very long time. With a previous international facade consultancy, he worked before that I had first met him. And his passion for complex geometries and sort of parametric models using rhinoceros and grasshopper is something that has been very inspiring. And after that, to close the session, we have Mr. Reji from Eminent, who's going to be talking about facade testing. So let's call upon stage Mr. T.S. Aditya, Aditya from Fundamax. A round of applause for him, please.
Change. Change is our constant. A journey over the last 130 years. We are rooted in change. Change is our way. And we are doing it again. We are changing. We think freely. We think ahead. We are Fundamax. We live perfection. We love design. We respect individuality. We complete what nature gives us. And we know where our journey is taking us. We are open for new ideas, for inspiration, for tomorrow. Open for you. And open for you to create. Fundamax.
So our topic for today is facade in high-rise buildings. We'll look at a few unique applications, and then we'll also look at certain energy-efficient facade systems as well. So let's look at the history. One of the early projects that was done, I'm talking about the skyscrapers, was done in 1908, the Singh building, which was slightly less than 200 meters. Over a period of time, we have evolved, and then one of the tallest towers that we have at the moment is Burj Khalifa, which is around 800 meters. These are few of the tall buildings in India. You can see here the Palais Royal in Mumbai, which is about 320 meters, and you have the Supernova in Noida for about 300 meters, and the 42 in Kolkata for about 268 meters. So let's look at the prerequisites of a high-rise building. When you talk about cladding, especially for a high-rise building, the first thing is aesthetics. Obviously, it should look appealing and it should be sustainable. And it should also give some kind of energy efficiency because you want to keep the building cool and reduce the load on air conditioning. You look at the wind load. When you talk about high-rise buildings, you can have a wind load of probably around 3.5 kPa, 4 kPa. And so you have to devise an efficient system which can sustain these kind of wind loads. Then fire. Obviously, this is a major this thing. Most of the facade materials use a concept of rear ventilated facade system, which creates a chimney effect and the fire can spread very fast. So how do we compartmentalize and then reduce the impact of fire? Then last but not the least, when you talk about high-rise projects, there should be an easier way to install it because erecting high scaffolding and then using the couple-lock system and trying to do it within the stipulated timeline is always a challenge. Last but not the least, every facade looks good once you install it, but the question is after 3 years down the line, 5 years down the line, 10 years down the line, how does the facade perform? That is also equally important. So we'll cover all these parameters. So when it comes to Fundamax, there are two parameters that we focus on. One thing is any facade material should sustain UV and weathering. So our product is tested as per EN ISO 4892 Part 2 and Part 3. Every decor that we launch is tested for 4,500 hours, which means in an accelerated chamber, you expose a 1 feet by 1 feet panel and you emit UV rays and you blow sand and dust particles. And after testing it for 6.5 months, 6.25 months to be more precise, we look at the grayscale, that is the degree of fading. Anything above 3 is permitted to be used for the exterior facade. So our product is between 4 to 5. Now, this is an accelerated test in a lab. What happens in reality? One of our oldest projects for facade was done in 1978. And after 33 years, it was tested for UV and weathering, the grayscale, the degree of fading. And even after 33 years, it was above 3. So our product is a time-tested product. And these are the basic physical properties, which I'll not go in depth. But the thing is, our product weighs probably roughly about 1.35 gram per centimeter cube in terms of density. So the weight is around 0.8 kilo per SFT. With the system, it is around 1.2 to 1.3 kilos per SFT, which is considered to be a reasonably lightweight material. So Fundamax HPL is typically a Class B product, which falls under the category of flame retardant product, which means that the fire does not spread. As long as the point of contact of flame is there, it will spread, but it will try to retard the flame by itself. However, understanding as you can see, as you would have seen in the video, we spoke about change. So we have to acclimatize based on the requirements of the industry, and we have realized that we also need to have an A-class material. So we have launched something called MLOOK, which has a fiber mineral core with a decor paper on top and bottom with 7 mm thickness. So this is completely A2 class material. So as we discussed about rear ventilated facade system, there are different systems. You have a rain screen facade and you have a rear ventilated facade. So rear ventilated facade system has a lot of advantages. It acts as a shield for your existing wall. It acts as bracing. It gives you kind of a system which can allow the hot air to enter through the cavity and emit out, which keeps the building energy efficient and gives you the right kind of thermal comfort towards the interior. And you have a lot of noise reduction, and you also can avoid diffusion of water vapor. So you don't get those ugly patches on the interior surface of the wall. Now, there are a lot of product manufacturers, but the important thing is how we install it. So Fundamax, we have very clear that every panel that we sell, we need to also sell the system. We design the system based on the wind load that is shared to us by the architects, and we prepared the complete shop drawing. We design the wind load, dead load brackets, and we give it as a system. So we do system selling. Of course, whatever design, the structural part, whatever we give has to be vetted by a structural consultant. However, we give you the complete unique solution. A lot of questions have come in terms of sealing applications. People do not want to see rivets because typically we use rivets as the fastening agents to fix the panel onto the profiles. But we have also developed a lap joint with a clipping system, especially for ceilings where you don't want to see those rivets. We also have an undercut system where this can be used for high-rise as well, where you have a facade maybe of height even up to 80 meters. You can use the system. Where we use this undercut screws to fix the clips behind the panel, and these clips are hung onto a horizontal profile which is supported with a bracket and a vertical profile. So this can be used. Now, as we all know that wind load plays a very important factor. As per IS 875, we can understand what's the wind load for a specific building. It depends on a lot of factors. It depends on the orientation of the building. It depends on the topography. It depends on the size of the panel. It depends on the height of the building. So we do the complete wind tunnel analysis, and we have done a lot of simulations. We have a lot of test reports as well. So depending on the wind load, we can decide whether it should be 6 mm or 8 mm or 10 mm panel. Sometimes maybe going with the 8 mm panel with a spacing of aluminum profiles little farther apart may be more cost effective than using a 6 mm panel. So we'll have to work out combinations which can give us the best stability as well as commercial viability. So we use softwares like eQuesta, which is again which is accepted by IGBC, Indian Green Building Council. So we try to understand what is the energy simulation, what kind of energy saving you can get by using this software. So I'll just brief you a little. This is a case study where you take a 10 meter by 10 meter facade. You can see the most of the heat comes on the south and the western side. So north and east side is glazed completely. And this is a 5-floor building. We try to see if it's cladded completely on the west and the southern side, what is the kind of energy saving you can get by using this product. So once we did this complete analysis, considering this area, what we could see is we could achieve a U value of 0.45 watts per square meter Kelvin. That is because of the temperature difference. You can get the U value as low as 0.45 watts per square meter Kelvin, which gives you a kind of thermal comfort. So now, what is this benefit that you get? If you, let us say, on the southern and the western side, had you painted the complete walls instead of using a cladding product, then instead of that, if you use Fundamax, then the break-even is happening at the 5th year. Considering that every year you need to erect a scaffolding and do a repainting, if you consider that as a factor, then the break-even happens somewhere in the 5th year. From 6th year, you can actually have savings because you're reducing your load on air conditioning, and then you'll save a lot on electricity bills. What are we improving? We are creating fire barriers. So we are trying to compartmentalize various portions of the facade so that if there's a fire breakage because of short circuiting, the fire does not spread from one compartment to the other compartment. Because of this concept, you can actually use an A-class material and then achieve 2-hour fire rating. Important part is whatever product you use, if you don't use the right system, it's a problem. Because aluminum, typically the facades use aluminum substructure and it melts at 600 to 660 degrees centigrade. When there's fire accident, it goes above 1300. So until and unless you devise the right system, entire system along with the right product, it doesn't help. So let us look at some high-rise projects that we have executed in India. This is Jain Heights in Bangalore, and this is HM Construction in Bangalore. All the cladding area is Fundamax. This is Mantri Lithios again in Bangalore, with the G+13 building. This is Mahindra Lumiere in Gurgaon with a wooden decor. This is the largest single owner residence. I think we all know what this project is. Obviously, I cannot name it. And we have done the complete ceiling applications here. So, and these are some more projects in Mumbai, high-rise buildings. This is in Chennai. Whatever you see apart from the glazing part, everything is done with Fundamax, the entire cladding area. This is a 83-meter building in Moscow. And again, complete facade apart from the windows is with Fundamax with white and gray shades. So this is the same complex, different blocks. Let us look at some unique projects. These are panels suspended on stainless steel ropes, 700 mm by 700 mm panels, perforated with plain colors of Fundamax. They keep moving with the wind, so it creates a kind of kinetic effect. What you see here, this is a project in Vizag. It's surrounded by hills. So the architect wanted to incorporate the same design on the facade as well. So you have the top and the bottommost curve projected at 1 feet. The second one and the last but one is with projected with 6 inches, and the in-between one is projected 3 inches. So creating a play for the facade and with rope lighting. This is one of a school building which is now converted into a cafe. So there you have this, you can also do curvatures with Fundamax and create an edge profile as well. You can integrate with semi-unitized system and then make your work really fast. You can integrate with unitized system. So you can, you need not do everything at site. You can also do it at a warehouse, and then you can directly install it, slab to slab. This is a M-look panel. It is a, as I mentioned, it's a completely fire-resistant panel, A2 class. It's used for a station in Zurich. So these are manually operatable louvers at different angles of 30, 45 and 60 degrees. It operates with a rack and pinion mechanism where you can operate from inside with a handle. So this is for Ahmedabad University. The bay of 7 louvers can move at the same time. This is done for ceiling application, directly done on MS using stainless steel rivets. So you can create any kind of parametric design. This is with the exposed concrete kind of finish for library block in Coimbatore. This is a school building in Cochin. It is a lot of perforations done with 8 mm panel. It also acts as a railing because you have parapet behind it, and kids, if they lean over the railing, they don't fall. So it serves 2 purposes. One thing is aesthetics and the functionality. You see a lot of these kind of designs where you use software like Rivet and you see it in MDF for interiors. So we can replicate the same thing for exteriors. You can create any kind of curved pattern and you can create a massive facade. This is again a parametric design, what you can see. So talking about the company, so our company was formed in 1890 in form of a sawmill. We have evolved over a period of time. The first exterior project was done in 1978. We are there in India from 2007. Our head office is located in Bangalore. So we are a 15-year-old company in India. And we have executed over 16,000 projects in the last 15 plus years. We do all kinds of projects ranging from commercial, residential, corporate, even government projects as well. We operate through our channel partners. As you can understand the importance of installation, we have about 44 channel partners all across India. And we have more than 132 decors. We have 5 different finishes, right from a complete matte finish to a complete undulated surface to a ultra matte finish. We have a lot of options. And our product is also FSC and PEFC certified, which means that because 65% of the product is made up of paper, FSC certification ensures that you take it from FSC source, which means that before you cut down one tree, you have to ensure that 2 trees are planted and they grow to a certain height. So we ensure all this, and our complete production facility is in Austria. We have 3 plants in Austria. We have a big warehouse, integrated warehouse in Bangalore. We store more than 50,000 square meters at any point of time. So if you're interested to know more about the product, we'll be very happy to engage you. We have a stall booth outside. Please connect with us. Thank you for your time.
Thank you very much, Aditya. So that was a very informative presentation in flat 15 minutes, which was, I think, very impressive. A lot of matter was covered over there. So next up, we have, as I introduced earlier, Mr. Ritesh Jindal from Arup, talking about parametric facades.
Thank you. Thank you. Good morning, Bangalore. Thank you for having me here again. Thank you, Zak. I'll quickly start since we have been allotted only 20 minutes for this slide deck, and there's lots of stuff that I want to show you guys today. But before that, quickly about Arup. So this was founded in 1946 by our founder, Sir O. Arup, who wrote the principle of total architecture back then. And we have finished 75 years in 2021 and still going on now. Quick overview about the firm. We are present in 94 offices, 34 countries, and we are a group of about 18,000 plus professionals within the team. In India, functions basically in 4 verticals. The first one is basically where we offer all the services from India office itself, whereas the second is a combination of India office and offshore office working together. The third is where only our offshore offices, where specialist disciplines come together. And again, there is fourth vertical where we offer very specialist services to our clients. Now, we have been present in India for the last 40 years, but our first office got established in 2008 in Mumbai. We are currently present in Mumbai, Delhi, Hyderabad, Bangalore, and soon opening an office in Pune. And proud to say that we have finished more than 200 plus projects in India. So, in terms of facade, we are about 300 people plus across the globe, and we have a small community within our teams where we keep sharing information with each other. We have a diverse team. We have architects, we have engineers, we have material specialists, we have geometry specialists, building physics specialists, all within this facade big group. And you know, we've been delivering projects. So this is Changi Jewel, which was my first project in Arab. And I had shown this project and how the geometry was resolved 2 years back in the same room in Bangalore, where the whole geometry was optimized, and it's a huge dome where all the glass panels were optimized to the exact sizes where they could be easily fabricated. A couple of projects. So yes, we have history with Bangalore as well. So we did Terminal 1 extension and also support in Terminal 2. So these are the various disciplines where we got together. In Terminal 1, we did support on facades, and in Terminal 2, we had a lot of disciplines, and we supported till the detailed design phase. The next project is Statue of Unity, tallest statue in the world, as we all know. And proud to say that we offered a lot of disciplines, which includes facade, SMEP, geotechniques, vertical transport. Again, another massive project, which is Geo World Center, recently opened last year in Mumbai. And again, we were part of the whole facade consultancy, and it has office spaces, commercials, retails, residential, huge convention centers. The next one is Geo World Drive, the first drive-in theater in Mumbai. Again, proud to be part of the facades of this project. People who have seen a very famous movie called Three Idiots, the school that you see last part of the movie, that's the school, Brook White Lotus. And proud to say that, you know, we have won a lot of awards. We still keep continuing to support this project. And again, we were part of the architecture of this building as well. So, coming to the topic of the presentation is split into 2 parts. One, we'll talk about some advanced tools and how we use them to actually optimize the geometry and, you know, make it more feasible into the projects. And the second part is about automation and how it has helped us actually in increasing our productivity and efficiency. So quickly jumping onto the tools that we use. So as rightly said, we mainly use Rhino Grasshopper, but there's also something called a Speckle that I'll show with a small demo later on. So this is a project where it's a classic example of why facade consultants should come early on board. Because in this project, the architect got us on board. There is 6 different pyramids and a tower at the end where all the office spaces and everything. And these 6 pyramids are basically museum spaces connected via sky bridges. Since we got early on the job, it was for us to define how the panels will actually be placed. The point about scripting is, it's very important what you actually put within the script, because if you put garbage in, you will get garbage out. So it was very important to define the parameters at the early stages. So we worked around 4 parameters. The first one is the available panel sizes within India. Second is how best we could utilize the sizing to actually come up with the geometry and reduce the wastage as much as possible. Next thing is about unique panels. We want to reduce unique panels as possible, so repetition could become easier for fabrication and installation. And of course, fabrication is again part of it. How easily can we fabricate? So we started looking at some of quadrilateral shapes. So we had rectangles, we had squares, we had diamonds. Again, we found out that, you know, okay, there is lots of unique panels coming in and out. Plus, because a square compared to a triangle was a little larger, so the frames were going a little thicker. So we said, why don't we explore triangles? And then we went into triangulations. And again, we started exploring the triangulations into different patterns. So rectangle, cut through. Then we took combinations of a hexagon, which is 6 triangles together. Then again, we took a larger rectangle and then split it into 4 parts. And to see how many different types of unique panels are we getting within one pyramid itself. And proud to say, we kind of plotted everything up and we came up with only 6 unique panels per pyramid. So, I mean, that's the kind of advantage you get when you have a proper script and a proper parameters defined at the early stages of the geometry studies. Again, for the tower, we could resolve the sloping areas. So the 3 facades are basically sloping and 2 are vertical. Again, the challenge was again with the sloping ones. We could resolve that 95% by just 3 panels, just 3 of them. And for the vertical ones, we resolved almost 90% using 2. So that's the kind of advantage you get, when you do parametric studies on these projects. The next one again is a huge heavy structure on a building. Again, something confidential, can't disclose much, but this is a rooftop and it has a lot of amenities. So when we got onto the project, this was the intent from the architect. And we started figuring out how are we going to make this possible. And it shows through the journey from where we started to started optimizing it and then the final result at the end. So I'm just going to explain a little more on how we actually do these studies. So initially when we started doing this, we started grouping them into parts where we could combine a few panels and make them as one unit. So this is just a study which is actually combining each of these unique panels and then breaking them into groups. And then we started, again, coming back to my triangulations again, because the shape is such unique. We had about 1620 total number of panels, of which 1400 were unique. So it was quite a challenge to again start resolving each one of them. And then finally we started studying all the triangulation panels. We started studying, how can we break them? What are the various widths? What are the various heights we can achieve so that we reduce the wastage and make maximum use of these panels as materials. We use Grasshopper script again, just to show that how many number of panels we were dealing with every now and then. And then that was the result. That was the final result. So again, just by using those parameters, we had different widths, different heights, different lengths. So we had given a couple of options to the client, and finally option 3 was selected, which was the most optimized in terms of the maximum size and the area you can get in a panel. Speckle is something we're using nowadays. So Speckle is basically just a tool. It's not a software. It's basically a tool which connects, which talks between different softwares. Now we have been facing a lot of challenges coming BIM and IFCs into the industry where transferring file from one to the other gets some data losses. Arab was involved in the development of Speckle in the early days. So I'm just going to try and show you an example where a Rhino Grasshopper file is actually pushed back through Speckle into GSA. So GSA is a structural engineering platform under the brand called OSS, which is owned by Arab. So Arab is also a software development company. And then this demo basically shows you the file. It's just a random twisted tower. So the file is basically done in Rhino. We've taken the center line from the Rhino, used a Grasshopper script to push it into Speckle. As soon as you tick the button, it takes you to a Speckle platform, which is a web-based platform. And from this platform itself, we are now going to actually push this model back into GSA, which is a structural engineering platform. And in GSA, we'll do the analysis and then throw back the same data back into the same Speckle platform. So now you have a Rhino model, which is structurally done in GSA, and they both are talking to each other through this medium called Speckle. So that's kind of end of the two combining together. We've used this extensively on HS2 interchange in UK. So coming to the second part, it's when we started, talking about digital as one of the verticals, one of the principles within Arab. So we started thinking, why don't we create automation tools which will help us increase our productivity, increase our efficiency in day-to-day work. So within the whole project life cycle, we identified where are these situations where we can actually develop something and help us internally to become a little better. Usually we get appointed in the design phase mainly till the completion. So you can see all the tools that we are working on internally. Some of them will be showing in the later slides. And then just completing the story where we are still trying to work around and develop some more tools within internally so that we can support our clients in future for a complete life cycle duration of a building. Before going into these automations, we are surrounded by data. Yeah. So let me talk about data a little more. Data is very, very discrete facts which are placed around us, and it's very important to organize this data so it becomes some kind of information. Yeah. And then once this information gets built up, when you organize this information, you become more knowledgeable. It could be within a field, it could be anywhere within your normal day-to-day works. And then applying this knowledge, make expert, that's where you apply your wisdom. So with that, I'm just going to show something. So this was, I think, 2 years back where I had presented again. There was a platform with an app where we share across all the digital tools that we have with each other. Now this is of all disciplines. There are about 2,200. So it was always difficult for us to find, how do we find the right tool which can support us? And then we said, why don't we make it digitalized? Why don't we structure this data? And in the next video, basically, we'll show you how we have structured the data. So in the first section, we have structured in terms of the discipline. The second one is the task that we do day in, day out. And the third column is actually all the tools. So no matter whether you need something from a tool that has been developed within Arab, you can basically just tick on the left, on the middle, wherever you need. It could be a Python script, it could be something electrical, something facade, something architectural. You can just tick on the few buttons and you can get all the tools that we have developed within internally that we share across with each other. Now, 2 years back, I had presented 5 tools in the 5 stages of the project, but this time I said, let's only show 4, but with actual project examples, how we have used these tools in our projects and how they have helped us. So the first one we had done in the concept design, which is called facade canvas. Canvas is basically just endless possibilities. You can draw anything in a canvas. That's why the name has come from. And again, this was something I had shown 2 years back. This is now outdated. We have made it much more advanced. And this is the advanced tool. So this is, again, we had used for a project in Mumbai, a residential tower. And what we've done in this whole script is, all the parameters you actually require to define a curtain wall are defined on the left in a Grasshopper script. And in these one, you can change any of the parameters you need. So you can change the mullion depth, you can change the set out, you can change vertically, you can basically increase the thickness, decrease the thickness, increase the gap between 2 panels. You can do anything possible with this. And the best part is, we actually added rotational angle to it. Now, once you have defined your geometry in just a concept, okay, you basically just apply all the loads and see how these panels are going to function when actually your slab starts to deflect. With this, you can actually identify whether the assumptions you've made are correct or not. If not, you go back to the script, you just change the parameters and you get your numbers. So this was quite helpful because in this meeting, there was structural engineer, there were architect, there was client and us sitting together, and we were trying to define what is that L by distance that we require on the project. So the structural engineer can start defining his structure based on the facade requirements. The second one is in the scheme design phase where we go a little more into depth. So there's a tool called Arab Solar. Again, I described this tool last time in the Bangalore session. So this time we'll use a project called Google Headquarters to explain how we have used this tool. The challenge in this project was the whole elevation were actually in the east and the west. So you have maximum glare throughout the day. And this tool basically tells you within what day of the month, which hour, what is the G value of your current facade, whether you need the shades up or down. So with that study, we kind of identified, okay, there is quite a lot of areas where there is direct glare coming and we need to do something about it. Yeah. And with that, we kind of came up with a shingle type of facade where each facade is actually shading the other one, reducing that glare or reducing that solar impact that is happening inside the building. And then with this, we created a couple options, how the facade should look like. And then this was shared with the architect, and there was this time where it was a point where which of these combinations to be used. So we said, why don't we use a combination of everything? Yeah, this is when we created all of these options and whether they are actually okay or not based on the G value and your base. So as soon as you keep changing the G values, your combinations will keep changing in the bigger spectrum, and it will tell you whether the three panel system, whether 4-panel system, whether 5-panel system, which is actually going to function better in the building. And then we gave it to the architect to play around with the elevation. Whichever elevation you like, based on the G value, you keep changing and come up with the whole elevation of the facade. So that's how the whole ambitions of the project was resolved through this whole scripting method into Arab Solar, which is again a tool based on Unity. And then we came up with the final output. This is the under construction photograph of the same. The next stage is detailed design. Again, this is a stage where we get into the really details of any particular aspect within the facade. And I'm going to show you something which is very important, which gets quite ignored in the Indian market, which is maintenance. So talking about maintenance, the traditional way of doing this thing was we get a lot of plans from the architect, we get sections from the architect, and then we try to place all the different systems that will actually clean your facade or probably use for the replacement. But the challenge with this was you had very limited information. There were only like a few plans. And anytime the architect changes something, you have to basically go back and do the same exercise. So we said we have Revit. Why don't we use Revit and create certain families to make it more efficient? And once we started working on this, we realized, okay, this can be used quite efficiently on very large scale project. So the project that we earlier showed, which is Jewel Center, again, you can see in just one image or one 3D model, which are the different systems which are used across the building to maintain the facades. So such a complex structure, which was resolved just by using some certain families and doing everything in Revit, where you can create also, all the clash detection and check every area whether it has been addressed or not. Not only that, once we had done all these families, we have basically created some automation tools internally. So this is something called as CAD tools, where we have created some of the tools, and just by clicking a few buttons, you can convert everything that you have in the Revit into sheets directly, or your standard sheets, whichever project is based on, and then everything gets converted. And then once this is done, again, a few more clicks, and then you can just basically go have a nice cup of coffee, and then you get all your data into a final PDF, which could be used as a deliverable into the detailed design. So that's the power of data. That's the power of digitalization that can help us efficiently, productively into our projects. Just again, talking about productivity increases a lot because you have your set families, you just have to implement them, run a clash detection, thing doesn't work out, do it again. Efficiency increases, yes, because you will be now addressing each of the corners of the building. Change is easy because next time architect just sends me a Revit model, I'll just change the link. I'll run the clash detection again, and I know which areas are not working. Of course, saves overall time, and your documentation can be immense. You tell me a section, cut a section here, I can give that to you in a few seconds. Yeah, and then we had this data, and we said, why don't we use this data now? We can use this further to actually extract information using Dynamo, and actually tell the client, okay, this much area has been addressed by this system. It takes this much time. Okay, this is the cost if I rent the machine. If I buy the machine, this is the cost. And then the client can make an informed decision whether they want to actually rent the machine or whether they want to actually buy the machine, whichever supports them, whichever helps them as per the budgets. The last part is during tender and construction. So traditional way of doing inspections is actually going onto a site with a drawing, starting to mark a few elements here and there, make notes, take photographs, come back, report that. But what if I tell you, you can do everything that using just one platform on your iPad? Yeah. So quick example of how this was done in one of the projects. So you go on site, you basically record all the information. You take a photograph. Again, whether it's safe, you can do assessment on the spot on the site. You can also bring back all your drawings within the same iPad, okay, in the same model basically, and you can actually assess whether this is happening correct or not. The best part about this is, since the data is very organized and filtered, you can actually see, okay, this is, for instance, if this is the most critical areas where it needs to be addressed immediately, you can just filter the assessment into the most critical areas, and you can find where these panels or where these repair work needs to be done within the whole model. Again, we have this information, but our clients request reports every now and then. So not everybody's tech friendly, especially on site. So we said, okay, never mind, we have data. How can we use this data and create reports for the client, which can be exported as quickly as possible? And then we use InDesign and a JavaScript to actually bring back all the data. And then just using a template within InDesign, you run a script and all the data gets populated immediately from that exercise back into this report, and then you can share this report with the client. So just populating that data in a few minutes, and again, your report is complete. So again, all the data, just using the data again and again, creating some tools to make things more efficient. And in the last part, I'm going to share a tool, which is, again, I spoke about earlier on Unity. It's based on Unity platform, which is used quite commonly in gaming and film industries as well for rendering purposes. So this is a tool called Arab Street, and it has immense possibilities. So this is just a short video to show how much you can do with data across in the digital world. So in just iPad, I have the 3D model. I have all the details plot in. So contractor, you can just go move around, tick on that detail, and the detail pops up. We have also used this in past projects where we have defined the demarcation of different facade types within the whole building. We've also put all these details, organized them into one platform. Again, you can search whichever detail you need. You can also visualize the data based on the assessment that you've done in the past. This is just an animation of showing, in case there is a bomb, how the whole wave will go through. Another animation just showing how the whole BMU system, the maintenance system, will work. Very critical installation sequences, especially for the contractors on site, in case of very complex geometries. We are now using it during the post-tender stage, where we are actually monitoring what's happening on site and also marking them up in the same 3D model. Again, you can use the data again to visualize the different animations. This is one classic example of how rainwater will actually travel through a very complex shape. Yeah, so that's all about Arab Street and digitalization from my end. Like our founder said, we try to shape a better world every day. And Arab follows sustainability. So we have stopped printing cards. If you need to contact us, you can actually drop an email on AFE, which is arabfasadeengineering.india.arab, or you can scan this barcode and get my contact details. Thank you, everyone. Thank you for the day.
Thank you, Ritesh, for an absolutely wonderful presentation. And it's good to see that besides Arab's long legacy and history of engineering and technology, you're continuing to innovate, continuing to do research and development to sort of be the forefront in using digital technologies to further improve and make more efficient your engineering and use your capabilities to improve the construction of facades in India and globally. Okay, next up we have Reji, who is from Eminent Facade. Reji has had experience for more than a decade in testing. He's worked in Dubai and has recently set up a facade testing center in Hyderabad a couple of years ago. He's growing rapidly, doubling his capacity every year that I can see. So Reji, over to you.
Good morning, Bangalore. Namaste, salam. I'm Reji from Eminent International Testing Center. Eminent is one of the largest facade testing lab in India, located in Hyderabad. We are NABL accredited lab as per ISO 17025 standards, and we are accredited for ASTM standards, AMA standards, BSEN standards, CWCT standards. So basically, we wanted to talk about why the facade testing is important, why we need to do the facade testing. And the thing is, if you don't do the facade testing, you are putting yourself into a risk of 50-50 chance. It might work in terms of air infiltration or in terms of water penetration. There will be no leakage, air leakage, there will be no water leakage. Structurally, it will be fine. But what if the facade is not tested and it started to leak? So if the air leakage is started to the building, as you know that, the interior surface can be damaged, like your flooring, wooden flooring, and the gypsum board, the ceiling, and even your tiles can damage. And the cost of rectification compared to the testing will be much, much high. So when you do the testing, you'll be able to identify what are the actual problems in a facade. So you have a chance to rectify the facade system while we're doing the performance mock-up testing in our laboratory. And you'll get a chance that if the leakage is excessive leakage, the air leakage is excessive, the water leakage is there, structurally it is not adequate, and you have a chance to rectify. You can add gasket, you can change the gasket size, you can change the wool pile if it is a sliding door or windows, and so that you will be identify what is your actual problem in a design. So you will be able to rectify before we do the site installation, we can make sure the system is okay. Recently, we have done one of the projects in Hyderabad, system supplied by Shuko, and the client asked Shuko to reduce the size of profile. Why? Because their requirement, the wind load requirements was less than 2 kPa. So Shuko, as we know that their profiles are highly tested, like a high wind pressure and all. So the client asked them to reduce the size of the window, the size of the profile, and they did a good job, and they reduced the profile size, and it is tested. And again, the client could save huge amount of, they could cut down the cost and they could save huge amount. And the test was passed with more than 2 kPa. And the client requirements was only 1.5 kPa, the maximum. So similarly, when we do the testing in a laboratory, before we go for the installation, we will be able to identify the problem with the facade. We will be able to reduce the cost. It's like a good innovation done by Shuko. I would really appreciate Shuko and Navanami. So the benefits of testing is like you will be able to identify, as I told you, we will be able to identify the problem with the facade. We will be, we can give a good qualitative product to the client and the end users. And so the procedure for the testing, like when the design is completed and the sample is ready for testing, you will be sending us your requirements, and we will make our test rig ready for you to prepare your to do the installation. So once the sample is the rig is ready, you can bring your sample, and you will be installing the sample, and then we will cover the specimen with the plywood and wooden support, and then the sample is ready for testing. This is how we do the testing, and the tests that we are conducting in our laboratory. Air permeability testing we can conduct in the laboratory with different standards like ASTM, BSCN, and ASTM 283, 783, and BSCN 1026, BSCN 12153. And water penetration, we can do the testing with spraying the water externally, and we create the vacuum pressure, which is as per your project requirements, can be 300 pascals, 600 pascals, 1000 pascals. We create the pressure inside the chamber, and we spray the water from outside. And structural load testing, like a wind load testing, whatever is your wind load requirements for your projects. For example, it can be 2 kPa, 3 kPa, whatever it is, we can create in our laboratory with that test pressure, and we can get the deflection. Whatever is the deflection, we can get it, and then we can make sure the system is adequate, the system is strong enough to withstand the pressure. And dynamic water penetration, we do with the airplane engine or other wind generator. We can we can create a dynamic wind effect. At the same time, we will do the water, we will be spraying the water. So make sure in a dynamic condition, what is the the water penetration, it will penetrate the water through the facade system or not. So we have a testing like jacking and seismic testing. We call it, we create jacking system, and then we allow the samples to move left and right, and we can create a wind load, dead load, and we can create a seismic effect and make sure the system, even the seismic condition, even if there is a small earthquake, the system will withstand or not. And the next test is the thermal cycling testing. This is something like, it's not that common in India, but yes, it is. And the client is asking for the testing now. And this is like we create the temperature of minus 18 degree to 80 degree. So it's like a graph is like it's starting from the normal temperature to go up to 80 degree, plus 80 degree within 1 hour time, and then keep continue for 2 hours. That 80 degree we maintain the temperature and bring down to normal temperature. Then it will go down to minus 18 degree as per AMA 501.5 standard. That minus 18 degree will have to continue for 2 hours, then it bring back to normal condition. So this is also, we do it in our laboratory. Then the seal degradation testing as per AS, Australia New Zealand standard 4284. This is like it's another. The test is like, what if the after a long time, maybe 10, 15 years, if the silicon cracks, if the gasket is damaged, what will happen? So we creating that testing, like we cut the silicon and we spray the water. It will continue for another 20 minutes. It is like cyclic testing. 5 minutes we apply the pressure with the water, and then we keep it for water. Just without the pressure, we apply the water. So I'll tell you one thing, and we can discuss more about the testing in our booth. We have a booth set up here to know. If you wanted to know more about the testing, we can discuss one-on-one discussion. We can have it there. And we also do the railing testing, railing and balustrade testing in our laboratory, and we can do it on-site also. So BMU pull-out testing, like the cradle or BMU is installed on a building. We need to make sure if there is a wind or something, the cradle can move here and there. So there is a wrist and socket pin is installed on every facade. So we will make sure by conducting this testing, the pin is adequate and it is strong enough to carry the weight of the cradle and the people who is in the cradle. And impact testing, we can do the impact testing for facade. We can do impact testing for railing and balustrade. So water hose testing is the on-site testing we can do on-site, like according to AMA 501.2 standards. We also do site chamber testing on-site. If your facade is not tested in the laboratory and you really wanted to do the testing on-site, you wanted to make sure the facade is okay or not, whether there is any air leakage or water leakage, we can test on-site by constructing a chamber, and we can do air infiltration, water penetration, structural performance. And the next is the railing testing. Railing testing also, as I told you, we can do it on-site. We can conduct line load testing, impact testing, and we can also conduct wind load testing. Is like infill area. We can apply the load, and we can do that. Then these are the special testing we do. Building air tightness testing, whole building air leakage testing. It's as per BSE and ISO 9972. ADMA TSL1 and TSL2, ASTM E779 standards. Basically, these tests are very common in Middle East and the European countries, but we would like to perform this testing in the Indian market also. It's like the whole building, the whole hall, we can do the air leakage testing and make sure what is the air leakage through the doors and windows, the ceiling, floors, everything we can calculate and say that these are the leakage from the whole building. And thermography testing we are doing at present. And this is like you come to know what is the thermal conductivity, thermal transferring through the facade joints, gaskets and all. This can be identified with the thermography testing. And anchor pull-out testing, we do it on site. So our facility is in Hyderabad. We have a lab set up in Hyderabad, and it's about we are currently having 8 test rig and 1 test rig for the skylight and roofing, and we also have 3 numbers of windows and doors testing facility. The specialty of Eminent that we are experienced people in testing, and I was, as Rohan told, that I was working in a company in Dubai for more than 20 years, and my team is also experienced people. They have more than 10 years experience. And Eminent is like we only have a testing business, no other business. So we are not. We make sure client confidentiality and impartial approach. And our equipments are calibrated as per standard requirements. We make sure our equipment everything is purchased as per standard range requirements and also standard uncertainty requirements. And our equipment, we make sure it is within the range, and the calibration we have done with the outside calibration company, we make sure their equipment is within the range of calibrating our equipment. So we are 1 hour away from Hyderabad International Airport, and about 30-40 minutes away from the main city of Gachibowli in Hyderabad. That's it for now, and we have a stall outside. We would like to welcome you to one-on-one discussion. anything related to facade testing, anything related to railing and balustrade, and doors and windows, you please feel free to contact us. Our team is there. You can contact them. Thank you for.
Thank you very much, Reji, for that presentation. Right, ladies and gentlemen, it's time to get caffeinated now. Time for the coffee break. I think a lot of you, I see a few eyes dozing off in the back over there. So I think everyone can go take a 20-minute coffee break, and we can be back here by about 11:35 to restart. So welcome back, ladies and gentlemen. Please take your seats. I hope you're all caffeinated, but you don't need the caffeine now because we're here at the most interesting session of the day with both our keynote speakers today. First up, we have Mr. Christoph Timm from SOM. For those of you who don't know, SOM is a global leading, not just an architectural firm, but also an engineering company. That makes it most interesting. They combine the synergies of architecture and engineering to work together to bend the limits of what is possible, creating some of the most fantastic buildings and facades in the world, including the CS Towers in Chicago to the Burj Khalifa in Dubai, and several other projects. In Mumbai, they have built the longest, I think the world's longest cable facade, which is for the Mumbai International Airport, and also have recently worked on the Kempegowda International Airport Terminal 2. We have Christoph going to talk about that project, who's the principal for the enclosures and facade and enclosures group for SOM globally. Mr. Christoph Timm, everyone.
Rohan, thank you very much for the kind words. My name is Christoph Timm. I'm from the SOM office in New York City. We are a collective. We are a collective of architects, engineers, urban planners, designers, all working on a better future. And what you see here is just a few images about from our work from the last almost 9 decades, 90 years, as an interdisciplinary practice, SOM. And today, Rohan already mentioned, I'm here to talk about your project, Kempegowda Terminal 2, and we called it a terminal in a garden. A quick history of the project. It's not very long ago that somebody envisioned this new airport. Only 30 years ago, in the early 1990s, that the old HAL airport was beginning to get too small, and there was thoughts about a new airport further away from the city, an airport that can accommodate bigger planes, more passengers. And so the first planes in the new airport landed in 2008, and within no time, within 7 years, the first runway was already at saturation point, and a new runway had to be planned. So the new southern runway was planned and commissioned in 2019. Pretty much also the same time when work for this new Terminal T2 started in 2018, 2019. We got involved in 2015 with the planning. And as an architect, you always try to find something what's special about a place. You want to work with the local genius. You want to work with materials. You want to work with traditions. You want to work with culture of a local place. And of course, in the garden city, Bengaluru, that is landscaping, that is biophilia. We started working on the project, and we had a lot of conversations with people that remembered growing up in the city with beautiful old trees on the streets, and we started to think, well, this would be maybe a good topic for the airport, biophilia, to really push this landscaping idea a lot. Connecting with nature, maybe during times of a little bit more stress because you're traveling, we thought like, well, maybe this is a good idea to calm down people a little bit, to satisfy people's physical and emotional needs in an airport terminal, and maybe make this terminal a model for a humanistic approach for a terminal that incorporates a lot of landscaping. And of course, we have a lot of buildings that have landscaping somehow, and atriums and places in the building. But this terminal is trying to have like not just greenery inside the building, but be placed in a park, in a garden situation. So this is what makes this terminal, I think, very special. And the building is not really about the fancy detailing, about long spans in the check-in hall. This building is about the personal passenger experience. You can see the nice warmth of the interiors, a nice touch with the bamboo throughout. And the innovative ideas that we developed on the scheme all serve all the features, they all serve this bigger purpose of making the experience of traveling through this airport something really, really special. When you start planning an airport, there's a lot of decisions that you have to make. There's big ones, for example, the layout of the terminal. But there's also little decisions, like the faucet in the washrooms. This is things that people will start talking about online, and you can read the reviews about their travel experience. So this is what matters to us, not really the detailing and all the fancy stuff that you usually look for in buildings as an architect. No, this was all about experience. Airports have been in lockstep with airplane development. In the beginning of the 19th century, when the first planes took off, there was no passengers. And then as airplanes got bigger, there was more and more passengers on airplanes. In the 1960s, airplanes had about 100 people. And nowadays, we have the A380 with 8 times, almost 800 passengers. And that, of course, requires changes in the airports. And of course, airports have seen their fair share of evolution. And I have a few images here from revolutionary ideas during in the last 70, 80 years. For example, Gatwick here in the 1930s, the star-shaped terminal you can see where the planes were docked and there was a telescopic gangway that would come towards the plane and people could directly move from the terminal into the plane. Revolutionary idea at the in those days. 1939, we didn't have enough long runways, so planes were landing on water. So the airports were close to the water, like the Marine Terminal in 1939 here in New York City. In the 60s, the Dulles Airport in Washington, this idea, kind of crazy nowadays, thinking about that the bus would take you directly to the plane and dock onto the plane. No stair to climb up, or so just at the same height, you just go into the plane. Nowadays, we don't have this technology anymore, but a revolutionary idea at the time. The 1970s, at the very right, Atlanta, remote terminals and people movers on the ground, below ground, that moved the people from the head house to the terminals. Revolutionary idea in the 1970s. 1981, the Hajj terminal in the kingdom, all open terminal. 1990s, Stansted modular, beautiful skylight here in the UK. In 2000s, then big spans in San Francisco, big airy spaces for the check-in halls with lots of skylight. And then biophilia also starts to make an appearance here in the 2000s. But then in Singapore, of course, that biophilia idea is taken to a whole nother level in 2007. So the client charged us to take this airport, a new airport, and continue this evolution of revolutionary ideas, innovative and they wanted an innovative and sustainable airport, delivering the most memorable and meaningful garden experience in the world. So we were asked to deliver this in 2015 and started working on it. And so how do you start? Of course, besides this nice high-flying ideas, architectural ideas, when it comes to an airport, there's a lot of numbers that matter. There's a lot of schedule that matters. And so you have to really evaluate, like, what are the destinations? What is the projections for passengers in the next 10, 20, 30 years? And you start with that. We have a whole team of specialists who work on airports, laying out airports. So a variety of different typologies were developed and evaluated against, like, how useful this would work in this given context here in Bengaluru. And we narrowed it down to basically 2, and then in the very end, we ended up with this rectangular H typology in the beginning, and then we morphed it a little bit, and you can see here what it became, a very compact layout. And what are the reasons for this, for the choice of this? It was very, very efficient on the air side, rectilinear. You can see nicely the gates. It had a good retail opportunity here, which is very, very important these days. And it had a lot of short walking distance. We all know this. Lots of airports nowadays have these long, long walks that you have to take to come to the plane. So we tried to avoid this from the get-go, and that's why this scheme was chosen. We then expanded the airport a little. We took it apart and added biophilia into the zones that came out of this pushing out the gates here. A big criteria for the airport was also the ability to phase it, because for commercial reasons, the owner didn't want to build the entire airport at the same time, so we had to phase it. And the advantage of this scheme was also that phasing is easily possible, and the airport wouldn't look like it was cut in half, really, and it would operationally work with this phasing idea. Right now, we have finished phase number 1. It's about 255,000 square meter, and phase 2 is about to happen in the very near future. In terms of passengers, phase 1 can accommodate 25 million passengers per year, and then the second phase can probably accommodate around 20 million. So a total of 45 million passengers per year is planned. Here you see like a little more detailed axon, and I want to walk you through some of the components, the big components of this design. So you can see, first of all, the head house, quite some dimension, 418 meters by 154 meters, quite some size airport. Then we have the gates. You can see we have a total of 13 gates, new gates, and they can service 13 wide body airplanes or 20 narrow body airplanes. So a wide body airplane is basically one with 2 aisles, and a narrow body airplane is one with 1 aisle. Typically, the single aisle airplanes are used in domestic travel. And what's very special about India here in airport designing is that in India you have to accommodate 4 passenger streams. It's the international, it's the domestic, but it's also the incoming and the outgoing traffic. That's different than in other jurisdictions. So you have to really be careful that you cannot mix those 4 passenger streams. You try to stay as flexible in not mixing them, but accommodating various scenarios. For example, in India, a lot of the domestic peaks are in the daytime, and so you want to have gates available in the daytime for domestic planes, about 40% on this terminal, and the rest is still international. Come the night, you shift that, and you shift it to 100% international gates in the night. This, of course, allows you flexibility and to build the airport with less material. So that's a sustainability concept. Build less, but create more opportunities with this, whatever less you build. To us, that's like a fundamental thing, not to build more and more and more, but to really think about what is absolutely needed. So we reduce ourselves in any respects for the sustainability sake. In terms of like flexibility, this is you've been probably to the airport. This is simple glass partitions that can be just moved very, very quickly, and so it's we call this a swing gate system, and it's very, very efficient. And then the space that is left between the head house and the piers is, we call it the forest belt. It's 25,000 square meter of beautifully landscaped environment that creates this illusion that this head house is actually situated in a park. Nice thing, yeah, and here you can see like an axon or a rendering from the design phase, and you can see it a little bit more in detail. And this is how it looks now. This picture is taken from the pier, looking towards the head house, and you can see all this beautiful vegetation. You can see the 2 stories. This is the arrival, the luggage pickup area, and up here, this is the check-in. And you can see how this building is really taking a backseat to the landscaping. Biophilia. So this building is not about a formal architectural expression. Instead, it's the architecture is basically just space and light. This building is about getting in touch with nature. I've said this before. And the architecture, and this picture kind of shows it very well, takes backseat here to the landscaping. The plants that we use are all indigenous plants here on the outside, because of course of the climate. It's perfect. And these plants were, from the get-go, like way before this airport opened, were already like nurtured here in these nurseries, and like way before. And so it's quite interesting to see. There was trees that were like selected and planted in the airport way back in 2019. And so these trees, some of these trees are 600 to 800 years old and have a life expectancy said to be about 4,000 years. They are very, very well taken care of by this gentleman here, I think he's the head of landscaping, I think. So beautiful. On the inside, lots of biophilia as well, but this time it's mostly Mediterranean plants, and the reason for that is the temperature. Usually on the inside, it's much cooler temperature, so the indigenous plants mostly can't handle it, it's too cold, so the plants are mostly Mediterranean. We also introduced these hanging planters, you can see there, like bell-shaped or these woven basket-shaped. They are all, of course, inspired by traditional Southern Indian temple bells or some other baskets woven. Highly complicated structures, never been done before, and so we engineered them to a certain point, and then you just had to start testing, because you cannot simulate nature. You have to, at one point, just build it and do it. And so we did a lot of mock-up. You can see one of them here hanging. They weigh up to 6 tons and are composed of like 600 to 800 pieces of components for irrigation purposes. So note, this is not like artificial plastic flowers or anything. This is real plants, and they can be in the end controlled at the push of a button on a cell phone, how much water is being introduced into the system. So quite interesting. Here another one. So there was an evolution of detailing of how to provide water into the system. And there was a few mock-ups that had to be built to really understand how to make this work. And on the right, you can see these hanging planters beautifully here in the head house. And they are strategically placed in areas where people walk. Next time you're at the airport, have a look at the ceiling and you'll see that you walk a lot under them. And another thing that we do here in terms of guiding people to certain areas is putting strategically the skylights, as you can see, on top of these areas where you want people to walk. So wayfinding by light. You can see it on the floor, a lot of light where people walk, and then maybe darker areas, less people will walk. So this is deliberate. This is not like by chance. You can see how many skylights the roof actually has here. It's perforated with lots and lots of skylights. And why is this? Well, of course, daylight is the best light you can imagine. The daylight spectrum is best for people, but also for plants. And you have to, and of course, also for the electricity bill, because we're really daylighting this airport for the most part of the day. There's no electric light in many, many areas. And this, of course, is a sustainability story. We reduce the loads, the electric loads, but also the thermal loads. And so this, of course, had to be simulated many, many times with real models, but also with computer models. And in the very end, the skylights were dimensioned, but also like the glass in the skylight was selected based on these data points that were generated out of these models. Plants also have like different criteria for illumination. So wherever we had plants in the head house areas, we simulated the skylights above and simulated what the light levels would be coming from the skylights to make sure that the plants don't get too much light and not too little light. Let's talk about the architectural materials a little bit. So generally, I've mentioned it before, we try to reduce material for carbon reasons, for sustainability reasons, build more with less. We also wanted to really stay with natural materials, materials that, first of all, like you find everywhere in India, like bamboo, stone, or brick, or rattan, materials you like to touch that are pleasing to the eye, natural in the color, sustainable materials, for the bamboo that are regrowing very fast. This is what we specifically desire to use on this building extensively. In lots of Asian cultures, you have these beautifully bamboo sculptures or assemblies, beautiful natural bamboo. Unfortunately, we couldn't use this for various technical reasons, so we went with an engineered bamboo that controls daylight in the ceiling, but also gives it a rich sensory touch to the structure that it's cladding, but also to the ceiling where it's installed. Again, lots of mock-ups to come up with a system that can easily be upscaled, because remember, this is a 400 by 150 meter big roof full of bamboo. So we had to come up with a system that can be easily put together with very simple components and then suspended up in the ceiling. So lots of mock-ups again for all these materials. We want to talk about the structural design. Same story here. Make the building as light as possible. That's the sustainability story here. In terms of efficiency, be modular, be very repetitive. So this building, again, this is not about customization. This is about building lots and lots of components over and over and over again to really focus on what you want to achieve, which is this experience of an airport. And you don't really care about the high tech on this building. Very simple. You see in blue the concrete of the arrival floor, and then above in orange the steel structure of the head house and of the piers. Head house and piers. The building is rectilinear. That helps again with prefabrication, being efficient and cost efficient, of course. We've learned the hard way. In the past, our structural engineers have worked with the Bible here, the steel book, a lot. And then when it came to buying the steel, the steel wasn't available. It was a custom steel out of the UK or out of America, whatever. So this time on this project, we looked at really the brochures from the domestic steel fabricators and made sure that these components that we were using were widely available. Of course, that helps you with the schedule, helps you with cost. So we've learned this to really, really work with material that's domestic. And so the steel on this building is completely sourced in India, and it's fabricated in India, and for the obvious reasons, cost and schedule. All the welding is in the shop, and all the jointing in the field is, you can see, with nuts and bolts. A few words about the actual structure. At the head house, the grid is 18 meters by 18 meters. Relatively small for an airport these days. Airports oftentimes have these huge spans, but I said it before, it's about sustainability. You can also begin to see these nice columns. I'm going to talk about this next. Nice columns that are basically, it's a moment frame system. There's no cross bracing. And what does that do? Well, it gives you freedom to move whatever you have on the ground everywhere, because there's no cross bracing. So you have flexibility, you future-proof your building. And here's, in summary, the steel weight is so little compared to some of these other airports that you see going up elsewhere in the world. So this is the sustainability story, build more with less. Build intelligent, repetitive, I mentioned it. So each column here at the head house is composed of 4 I-beams, and then you have these knuckles every 10 feet, every 3 meters, go up, and up to the 4th one up there, this column is exactly the same, dozens of times, hundreds of times. And then the only difference is at the node at the very, very top, different height because of the sloping of the roof and structural requirements. You can see here now in this picture, the beauty of what this does to you. You dematerialize that column, and then when you clad it with bamboo, you can still see through this column. What an amazing thing that it's not just one big fat column, but it's a column that kind of dissolves and keeps that roof up, kind of almost floating magically. And here's the different nodes, a node catalog for all the different types of nodes that were, of course, analyzed by the structural engineers and beautifully detailed, simple. Each column fits on the truck, They weigh about 7 tons each and can be installed. Here you can see typical grid, 18 meters by 18 meters. No cross bracing everywhere, anywhere. Some words about the piers, same thing here. No cross bracing. You have all the vistas in the world. You can see down and you can put whatever you want on the inside wherever you want it. Very simple concrete columns, moment frame system, and then a steel truss at the top. Super simple, and you slope to one side. Super simple construction. And this is how it looks in the end. And in the future, somebody may want to put some other things somewhere. They can do it, no problem. And you have these clear vistas, so easy wayfinding. Same thing applies for the concrete on the lower floor. It's a kit of parts, basically. Wherever you need bigger spans, 18 meters, you take this system. When you, for example, at the luggage carousels, next time you're there, look at this. There, the spacing is much bigger. So there we have the 18 by 18 meters. In other areas, we just go smaller depending on the size. Of course, smaller is better, it's more efficient. All the columns are round in the public areas, rectilinear in the back of house area, so also very efficient. And here you see the exits, very cost-efficient finishes, I have to say. Just simple concrete, plastered, painted, and then with these bamboo inlays. Looks pretty simple, is pretty simple, but it's somewhat very decent, I think. We have these cutouts, bringing down the light. You can see no lights turned on, so it's very sustainable. A long building like this, of course, has a few expansion joints for seismic or also for thermal expansion contraction. And a detail that I wanted to point out is, you can see it here on the right. No, let me go back. You can see here one part, and here's the other part, so it had to be separated. And that key detail up here isolates the two structures, and you can see only one row of columns. Oftentimes when you have a situation like this, you have to have two columns. But our structural engineers worked this out that the left side of the building basically rests on the right side, making it very, very efficient. And what does that mean for the occupants? They don't see any expansion joint. So it's, again, all about the experience on the building. A few words about the enclosure design. Same story, very simple, very repetitive, over and over the same thing. We tested in the wind tunnel here just to confirm the low pressures, and it's just 1 kPa here for the roofs most of the time. So very simple. And at the head house, spacing is 3 meters. We have a vertical backup steel. In front, we have a unitized curtain wall system, 3 meters wide, typically 3 meters tall. So large glasses on the bottom and then smaller glasses on the top. We have huge overhangs for solar shading, of course. Sustainability, very basic, very simple, passive ideas. When we come to the piers, the concept is a little bit different. No overhangs, but reduced window to wall ratio. Lots of aluminum shingled panels that you can see here. So straightforward. And this is how it looks. A detail that I wanted to point out that we really worked on is the connecting part between the aluminum curtain wall system that you can see here and this connector piece connecting to the vertical steel that is actually not an I-beam, looks like an I-beam, but it's a tube with 2 extra plates against torsion. So there's no horizontal steel, it's just only vertical steel. Very simple and elegant. And if you look at this close-up, I wanted to show how simple this detail is. That's a detail that, if you go next time to an airport, oftentimes gets really, really nasty, lots of bolts and fasteners. So we worked with the facade contractor, Geotrix, and made this component look really, really nice. You can see all the different components that go in there to make it so simple. And this detail is all over the building in all kinds of walls. So again, we built more with less. The glass is straightforward, low iron glass. We have a blast criteria at the head house, so it's laminated. At the piers, it's clear glass. Depending on the wind load, it's a little bit thicker or thinner, depending. An interesting thing to talk about is the rainwater management. Kind of the same story again, simple. The client told us they don't want any drains inside the building. They want to shed all the water to the side and then down. That was one criteria. The other criteria was use a standing seam roof. That's the two criteria they gave us. So we came up with this concept to just slope from the high point down with 1% with a gutter, and then down outside the building. And how does this look in reality? Is you can see here the gutter that's coming down 150 meters long gutter at 1%, and then you can see the green, the standing seam roof feeding into the gutter. And what does that do? It makes the roof much shallower, less sloping because of this 1 degree angle that is possible with a gutter, but not with standing seam roof that requires a 5% slope. Highly integrated, the roof drain leaders, you can see here, the steel snake around it, or the plumbing snakes around the steel, either way. And you can see the vertical leaders coming down here. And this, the water all feeds into the lagoon areas for recycling. Because with all this irrigation needs on the inside, all this water is being recycled. The ambition is to be net zero in terms of water. Looking back, I wanted to show you a few images, and that's the nice thing about being at a conference like this. When I put this together, I really dug up some old stuff and some nice images, some sketches from Grant Associates, our landscape designer. And I want to show what was originally envisioned almost 10 years ago and what was built. It's kind of nice to see the two and how similar what we built now is to what the sketches were in the beginning. Same thing here at the arrivals. You walk in these corridors. You walk in the corridors here, very similar. Oops. And then you have this experience here. Nice to see how this was executed. Same thing with the bridges crisscrossing here. So it's nice to see these beautiful rendered spaces now become a reality. And at the luggage pickup, you're always connected with the greenery outside. Beautiful. So looking forward, and I know I'm over time, I'm going to speed up a little bit. Bial, who runs the airport, is constantly updating the master plan. Phase 2 is coming soon. There's a potential for phase 3, for a third terminal, depending on passenger development. We shall see. You probably all know the quad, which is the space in front of Terminal 1 that was planned as a temporary event space, food and beverages place, and now it's become a constant staple because people go there, mingle, have a drink, have a beer, and it's really, really successful. And people realize that the airport needs these kind of spaces outside the terminal. And so we are planning, or we have planned, hold on. This is, of course, being documented by people like on social media, going there. It's a big thing. And we have planned the multimodal hub here in front of the head house. You can see at top left, you can see Terminal 1, and you can see this design from us. This is under construction. It's coming. The metro is coming. The fast rail is coming. And you can see at the top and bottom, you can see the lagoons where the water is being stored for treating it and reusing the water. And I wanted to close here with just some thoughts about this specific airport. In the very end, of course, an airport is like a machine. It has to move a lot of people. And imagine for a second, if an airport could talk, the airport would probably say something like to a passenger, like, "Don't worry, I'm going to get you out of here as quickly as possible." I think the T2 terminal wouldn't say that to a guest. It would probably say something to the degree like, "Relax, take a deep breath, go into the park, and when your plane is ready, have a good trip." Thank you very much.
Hi, sorry, I'm just, this is unplanned, it's not part of your agenda, but just hearing Chris talk about the airport and being a Bangalorean and an Indian, I just felt it was, my duty to come up and say a big thank you to him on behalf of all of us for what he's done. And I'd like to just request the audience to give him a standing ovation for what he's built for India, right? I mean, It's an absolute marvel and a gem. And, I was going to say something which you just said, that, go relax, go a couple of hours earlier. And those of you who have not flown out of Terminal 2 or flown in to Terminal 2 and who are going to go back, I'd urge you to actually cancel your ticket if it's on Terminal 1 and go to Terminal 2, right? It's an experience you're going to really appreciate and love. And, and now that he's shown you what is done there, you can actually go and see those finer points into more detail. Yeah, so it's beautiful, it's amazing. Like he said, go a couple of hours earlier and your time won't be wasted. It'll be well used. Thank you, that's all.
I just want to add on to what Mr. Pankaj said. So, those who don't know, Christoph is a Damad of India, or Aliya, as they say in Kannada, or Maple. He is married to an Indian who lives in America. He spends most of his time here in India when he's here. So if you want to use him, his resources, his knowledge, his experience, you can always reach out to him. Very humble person, very down to earth. And I would like to say that we are right now doing these conferences globally. So this is a Make in India brand, I would like to say. And in New York City, if there is anyone who helped us become the top-notch facade conference in New York City, Christoph is behind it. He's helped us a lot. So thank you, Christoph. Thank you so much for being here.
Thank you very much.
For a wonderful presentation, and I think you've had, thank you very much. Next up, we have with us the head of engineering from the presenting sponsor, Shuko, Mr. Kushagra Awasti, who's going to talk about sustainability. Kushagra.
Thank you, Christoph, for introducing us to our Nama Bengaluru airport. And definitely next time when we are traveling, we will focus on all the small details which we overlooked previously. But it was really interesting to see how things were planned, the entire airport planning. So I would divert a little you all to facade planning, not just the building as such, the building in total, but looking from a facade perspective. So we had really good time listening to all the speakers in the morning, and the story for me, as usual, is already built because, I joined in the middle of the conference. So we had a good presentation from Neelima, who spoke about the sustainability and how different buildings they have created. And then very interesting presentation from my friend Ritesh from Arup, where we saw how buildings can be optimized. I would like to draw your attention into a little on the optimization part, but from a facade perspective. So just to build up the story, buildings are responsible for up to 40% of the energy and the material requirements globally, okay? So entire building is consuming 40% of the energy globally from energy and materials requirement. Now, right, sorry for the glitch. Yeah. Out of the 40% of the energy that goes into the building, facade is responsible for 20% of it. So roughly around 8% of the material and the energy requirement globally. Again, cutting down to the element of facade, we primarily have a lot of material going into it, like aluminum profile, sheets, glass, mineral wool insulation, polyamide, and EPDM, out of which, interestingly, 37% of the embodied carbon comes from aluminum profile itself. So this is somewhere we have to really focus on. This is the whole life carbon cycle for a building, which is basically divided into different classes. So A1 to A5 is basically the product fabrication and the construction. Then we get into the operational phase, which is phase B1 to B7. And then into the demolition, which is C1 to C4. And then the last, which is the credit, which is where you need to think about disposal or recycling. So the 4 gates, cradle to gate, cradle to practical completion, cradle to grave, and then cradle to cradle. So cradle to cradle is basically the complete life cycle of the product. So not everyone is thinking in this perspective, like what the materials, how we have to handle the material by the end of its life. So Shuko has taken this responsibility to think over this topic and provide solution right from A1 till the last gate, which is D. And how do we do it? We have different approaches to cater to this problem of both embodied carbon and the operational carbon. So we focus at the design stage, we focus at the planning stage, we focus at the building stage, we focus at the construction stage, we focus at the recycling stage. So all these things is planned, but today, since this is a very vast topic, I would drill down to only one area, which is primarily from A1 to A5, which is increasingly gaining importance these days. Of course, the operational embodied carbon remains, operational carbon remains really important, but we'll be focusing only on the low carbon materials and the design associated to it. So what we are doing at Shuko. So we have prepared a toolkit kind, which is primarily minimizing the CO2 in construction, and it's helping to make the buildings greener. These are the 4 quadrants that we really look into, where we are focusing on the carbon control toolbox. The first one is design to decarb, where we are helping our customers to set the right foundation at designing and planning stage. The second step is to build to decarb, where we are helping. Then we also focus, the third quadrant is operate to decarb, where we are helping the customers to run the building in a proper way, so that we are highly efficient from a carbon minimization and emissions perspective. The last quadrant is the recycle to decarb, where we are enabling our customers to recycle the materials. Okay. So there were quite interesting takes from Christoph's presentation. I would say he mentioned 3 critical things. He mentioned build with less, but create more opportunities. Christoph also mentioned build more with less and build intelligently. So I see all the 3 things are somehow getting connected to the 3 right important topics that we have to focus from a facades perspective, from the design perspective. So the most important topic that we have to really focus on is the U value. If we have to be sustainable, so first thing that we have to target is a good U value. Then the second important topic is airtightness. The third is the material consumption itself. Let us see how we can optimize all the 3 parameters with the same design principle. So I'm just taking an example of our project, which is in Ahmedabad. It's Adani Energy House. Architect is the Arch Group. Facade consultant is Fencon. There was a big challenge posed to us from the U value perspective, where the client and the consultant wanted to reduce the operational carbon. They wanted a good reduced space cooling demand. It had to be balanced daylighting and overheating. And of course, they wanted to reduce the running cost of the building. So what should be the target value for the U value? So in general, the industry standard is at 2.5. The industry stretch is basically 2.1. The demand in this particular project was at 1.9. So this was the challenge to us. We had to overcome the issues that we already have in the current designing principle, and we had to mitigate this using the same optimization tools that we had. So we went back to the board and we started with the sketch of, again with the geometry, how it should be, then the material selection. So this is the basic framework of designing a profile system when we are designing for a U value. So the functional area is the key area there we have to focus on. So when we developed the geometries, we were able to develop 5 and even more options, which is readily available both in stick and unitized system. And then we have different materials also available for each geometry type. And this is how we were able to achieve 1.87, whereas the target value was 1.9. Recently, we did a project where we were able to achieve 1.47 in the unitized system. And we also have designs for stick construction where we are able to achieve 1.3 U value. So what we need the industry to specify best-in-class U value intenders. So this is what we want. And why do we want this? Because we want to have a sustainable future. And this is the first step towards it. The second topic, air tightness. So why is this required? Of course, I mean, air tightness, as the word says, it reduces the air exchange. What benefit are we getting? The benefit is the heat load is getting reduced. So this is again a project called ATS Pragya in Ahmedabad. Architect is Hafiz Contractor and facade consultant is FES. Here the challenge again was the same. They asked us to reduce the operational carbon. The space cooling demand has to be reduced. We had improved acoustic requirement there, and of course reduced HVAC malfunctioning. So here also, if you see from the code's perspective, the code also says, or basically classifies, where the industry standard stands at 27 meter cube per hour per meter square. Industry stretch is at 9 meter cube hour per meter square, and the best in class is obviously less than 3. So this we can correlate to what and how we did. So on the right side, if you see the classification, this is already given in the code, EN classification. These are the 4 classes. So the EN class 1 is basically allowable is 50 meter cube per hour per meter square. Class 2 is 27. Class 3 is again at 600 Pascal, but allowable permeability is 9 meter cube per meter square. Class 4 is again at 600 Pascal, but allowable is 3. You can see a vast difference. Even when you are testing at 600 Pascal, there is a huge difference between class 3 and class 4. And this is what we have to capture, going forward, because it's mostly in the tenders we see that only the Pascal is mentioned for the test as a test parameter, but it's really important to specify the class also, because there is a huge difference within the class itself. You can see on in the same 600 Pascal series. So again, we had to redesign this entire thing. There was parallel pop-out, there were top hung, there were other elements also in this facade typical unit. So we had to go back to the interface area design, where we had to think about the geometry, how many layers it should be, because air tightness is directly dependent on the number of layers that you have. Okay, so we have multiple barrier systems. So we have 2 barrier, 3 barrier, 5 barrier, and so on. And then what material has to be used? Is it typically the EPDM gasket that we are talking about, or is there a possibility of using any foam in such situation? So we were able to achieve class 4, which is less than 3. I mean, more precisely, it was 20% of 3 for this when we did the testing. So we specifically need that it's not just the Pascal value that has to be defined, but we need to have the class also mentioned in the tenders, so that we are able to capture the right values and do justice to building by being more sustainable in that aspect. The third is the material optimization. This is the project in Hyderabad, Eon Navnami. This was, Reji was mentioning about this project where we did testing, and we were able to design for something and able to achieve more. So this is one of the material optimization, good material optimization we were able to do with a new approach, I would say, because it was kind of a mix of a manual and automated system that we used there. So here the biggest challenge was, as Reji also mentioned, that client was emphasizing on having a reduced weight, but the wind load was pretty high. So that was the challenge to us, and we were able to do so. For that particular 1.8 kPa, usually the industry standard is at 8 kilogram per meter square. The industry can stretch to 7.5. We were able to go well below 7.5 in this situation. How we were able to do it? Again, we had to go back to the geometry. It was really interesting to do a number of iterations in this situation. I will show you what kind of iteration we did, and we applied the right principles, from the standards also, and we applied the right principles, structural principles, and selected the right topology for this optimization. There is one more important topic, which is usually when it comes to profile optimization, none of the customers, they give credit to the designers for optimizing. It's always a
kind of a cost saving to them. So the money saved is basically that's what the customer wants. But I think we should give some credit to the designers in this case for saving a lot of aluminum, because this is something which is eventually helping in the embodied carbon. So here we were able to achieve 25%, in fact, little more than 25%. So this is just an example to show you how we optimized. So here the question was not just the depth and the face width, it was about the primarily static value that we wanted to achieve, because the specification and the wind load was frozen. How do we do it? So we have a tool called a Shuko VCL, where we are able to optimize the profile sections and with a lesser weight. So you can eventually end up with a higher original strength, more than 100%, but less than 100% of the weight. So this is what we were able to, this is how we were able to achieve in this particular project. So as I said, three important things which is really, really will drive the sustainability aspects in the facade design is the U value, the air tightness, and the material consumption. We also saw what are the target values that we can go for, and we are really prepared for it. And for any given situation, we can, design for all these parameters or, mix of all these three. Other than this, I mean, there are other aspects also where we have to focus on. We have already seen a couple of presentations before, where we have seen the form factor, how the building design actually affects the facade optimization, the elements optimization. This also is really helpful in, as a starting point of the facade design. Choose the right systems with the right materials, and then of course optimize the material where you can go with a really low carbon or ultra low carbon aluminiums. Okay, so that's all from my side today. Thank you.
Thank you very much. Thank you for a very informative presentation. A lot of things put in together in a short period of time. Okay, so next up we have our next keynote speaker for the day. We have Mr. Rafael Acosta, who's principal and country head for ADAS. Mr. Rafael.
Okay, thanks everybody. Thank you, Zak World of Façades, for having us here today. I think it has been a very interesting session. Lots of technical information, fantastic presentation about the airport. I think Christoph raised the bar really, really high. Let's see what can we do. So I wanted to introduce starting by myself, but basically tell you who is ADAS. ADAS, SOM needs no introduction. We feel that ADAS still need a little bit of introduction. However, some of you know that we're part of the World Architects top 10 or top 12 for the last 18, 90 years. And we pride ourselves to be a design-led firm. Many of our designs have won international awards. Prati Maidan, for example, which is going to be one of the projects I'm going to showcase here today. And we're very proud of this. And how do we work? I'll show you in a minute how do we work. Wait. So ADAS is a large design firm. We do any discipline that you can imagine as a design firm. We don't do any engineering. So we have one team that does all these different market sectors. And then we're located in 12 cities. We have around 1,200 people located in all these offices. Singapore is our second largest city. And from Singapore, we manage the Southeast Asia and the Indian subcontinent. So I handle this. I manage our work in India, all the portfolio. And these are all the other offices in the world. You can imagine that green or yellow dot there. That's where I am from. In case you were wondering, this strange accent that I have, that's where I am from. Our footprint in India has been mostly Delhi and Mumbai for the last years. Hyderabad got very strong very recently. So we have 3 large projects under construction in Hyderabad. But we have been in India since 2004. So this is going to be our 20-year anniversary. And we're very proud of that. We have a strong presence here in India, even though we don't have a local office. Some of the clients that we have work here in the local context. And how do we design? So we strive ourselves to understand the local characteristics and the culture. It's not just understanding the sun and the wind like pretty much every architect does, but we want to create something more. So what we usually do is to create metaphors, to create stories that people can relate to and build on that so people take ownership of the design and they relate regardless of where they are in the world. So for example, a few cases, inspiration, we have an inspiration that becomes the concept, that becomes the realization of the building. Another project in China, for example, this is an area of China where they have these natural formations of rock with openings that became the concept of the building, and the realization of the building is just an extrapolation of that. We do that all the time. This is a very interesting university. In India, we did this project for Shapurji. Shapurji Palonji was the entering a competition that we did for a master plan done by Norman Foster. There were two towers, two signature towers at the end. And we did that part of the competition. As you can see, the inspiration was the Kuchipudi dance. And the towers were full of technology, wind turbines, solar panels, green roofs, etc., etc., etc. Then Pragati Maidan, I'm going to go a little more in detail on this, the inspiration, the concept, and the realization. This had 3 layers. One was obviously the lines from Lutyens in Delhi, then the Yamuna River, and then the window to Delhi. Significant international projects that we have worked. This is an interesting shopping mall with an office tower integrated. This is the light north of the tower, light of the north tower, apologies. People are calling this the most twisted tower in the world, not because of the amount of twists that it does, but how fast it turns 90 degrees. Very challenging double curvature glass, where all these facade engineers come in play and make the realization of these dreams. Large shopping mall in Dalian in China. Ocean Heights in Dubai. West Kowloon Terminus Station in Hong Kong. Very interesting building, very dynamic, full of energy. People love it, as you can see, has been very, very active. It was absolutely dead for 3 years during COVID. A sad story, but the building is back and is up living. Marina Bay Sands in Singapore. I'm very close to this project. I work with Moshe Safdie, and I was part of the design team, and that's why I ended up in Singapore. And we recently, as ADAS, developed the renovation of 2 of the hotel towers and the casino. Large master plan across Singapore in Johor Bahru. The Star Vista in Singapore. This is a mixed use, large shopping mall at the bottom, naturally ventilated. And on top, there is a multi-auditorium that serves as a church. The church is the main client of this building. And then it's a multi-purpose hall that allows you to have concerts and to have other activities. The Sandcrawler, this was another analogy. Sandcrawler is because it was the Lucasfilm's headquarters where they did part of the CGI for all the Star Wars and all these movies. Obviously not Star Wars 1, but that was based in Singapore, and this was a very beautiful building that we did for them. Sinar Masdar headquarters in Jakarta. And now let's go really quickly into a few projects in India. As you know, Pragati Maidan, that now is called Bharat Mandapam. This is going to be one of the case studies. Rajiv Gandhi Airport, the extension, we did this, and that opened the door for us to do a little bit of competition to SOM. Obviously, trying to get there a little bit. We did, after this, a few projects, Doha, the expansion of the Doha airport as well, Hamad International Airport, and we have a few more things here in India. This is under construction in Hyderabad, SAS Tower, the Crown, high-end residential, 1 unit to a core, 16 to 17,000 square feet units, very large, under construction. The Kuchipudi towers that I mentioned before. Another project in Hyderabad under construction. This is the I Tower, massive building, 8 million square feet total of built-up area, 5 million of office. This is going to be one of the case studies, large residential in Gurugram. Has 2 plots. So this is what we call the plot A, and then the plot B, which is a high-end tower, a standalone tower. And then the train stations that we're going to talk about here in the presentation. So case study number 1, Bharat Mandapam. It was a competition that we won. ARCOP was our local architect and JV. So we did this with them. We started with, like everybody, the RFP. ITPO issues the RFP. This is the site, very interesting site. There's a lot of information on the RFP, and we start developing the thing. We get the original plans, and all of a sudden somebody says, wait a minute, we have this. And I feel we cannot talk about Pragati Maidan without addressing this. We received a lot of criticism because this is a project that is very close to the heart and to the minds of many people. I've heard a lot of stories. People tell me, oh, that's where I proposed to my girlfriend. That's where I did this. I went there. And there's a lot of passion and a lot of social interaction with this building. Unfortunately, we had nothing to do with the decision. There was a political decision, and we were told everything is going to be demolished. You design a new building. But we did a few things, and I'll show you in a minute what we did to pay homage to this building. So we went through the process of designing, go to the basics, study the landmarks, study the information. The Yamuna River used to be in that area at some point. The old Fort Lake now that is next to the Purana Kila used to be part of the Yamuna, and that's how the building worked. Then the road was built, and then the Yamuna River was confined to that area. But you guys know this is area prone to flooding, and this project is next to it. Then the Lutyens design, the geometry, the lines that come from the Delhi, the network of rail and infrastructure. And then we start designing. Again, the lines from Lutyen. Vastu. Vastu is a very important thing for us in India. In our office, we have people that know very well Vastu. The Hyderabad projects are fully Vastu compliant. The Gurgaon projects have some interaction with Vastu. So this was very important. Then, of course, wind, sun. We decided to orientate the buildings in certain direction. That created the design grid. And then the Yamuna River, we decided to bring that as an analogy as well, and that became the pedestrian circulation of part of the building. Then we analyze where are the entrances, where can you put certain things, where can you put not certain things, and then you start defining the zones where things should go. And then when you combine everything, that is what created the project. So this was the master plan that won the competition. This is the what happened at that time. And as you can see, the building, the tessellation, that was intentional. That was an homage to the Hall of Nations. So this is what the competition, the end of the competition, and then the client says, all good, but now can you provide options? That's the story of my life. So you will see a lot of options today. So we had the original design. Then somebody said, okay, let's create this window to Delhi. So that was an intention to elevate the building and to create that concept that I'm going to go into a little more detail later. The other flavor was the smart city, smart park, and then the contemporary classic approach. So we presented all this to the client. There was debate, and eventually somebody said, okay, let's go to the window to Delhi. Everybody loved the idea. Let's talk about the window to Delhi. However, can you change the shape? So we went back to the drawing board, and then we started talking about, okay, the window to Delhi, how is this going to work? So we decided, as I said, axis, continuation from the India Gate, the views next to the Purana Kila. Then raise the building to be seen from the outside, you know, the ring road and all these trees around Delhi block all the view. So if you raise the building can be seen. And from the same time, when you're at the building, you can see all your surroundings. And that became the window to Delhi. We studied very carefully what are the elements, the important elements that we need to see, at what height are they visible. And based on that, we start defining, you can see up here, where is the window to Delhi, which is that balcony, indoor and outdoor, that allows you to envision the city, or visualize the city, should I say. Then in terms of shape and inspiration for the design, we start looking at the steps, the ceremonial approach, all these levels that are very traditional Indian architecture, very common. Then we start looking at the round shapes, the circle, the domes. Those are very used in Indian traditional architecture for buildings that has importance in terms of civic or otherwise. Then we start looking at the colonnades, and that is also a recurring theme. And one of the important things that has not been disclosed very much, and is that we did a very conscious approach to change the order of the building. You see, especially on the top, on the parliament, the stone The dark stone is at the bottom and the light stone is at the top. We inverted that on purpose, just to signify a change. The new Delhi, the new Pragati Maidan was the new stage, and that we did that on purpose. We talk about the water, the manicured water that creates these mirrors, and then natural water in natural stage. The two largest rivers, the Ganga and the Yamuna, become this massive flow of water. And that was a painting that we found that was the representation of the two rivers as a metaphor. That quickly became the design inspiration for what we have today, some of the sketches that was that, and then this was presented to the client. Everybody started to like this. Okay, yeah, this is looking what we love it. We start creating, again, steps, water, colonnades, stone, colors. And that became very quickly the evolution of this building. And the program is a very ambitious program. It is a mix of circulation. You have public circulation, you have private circulation, you have VIP circulation, a lot of security, how you move people from the huge basement with a lot of buses interchange, and you bring them up to the plaza. The convention center, it has halls that are subdividable, so you can have 5,000 to 10,000 to 20,000 square meters of footprint. Then you have the service access on one side, the visitor access on the other side. Then you have this on the second floor. And then on the third floor, you have the food court and the F&B. You bring people through circulation, all the vertical. Then you go into the convention center. Then at the lowest level, you have the arrival and the plaza and the open-to-air amphitheater. Then you have here some of the convention rooms. And then here you have the multipurpose hall and the plenary hall. Then you start going up. This is the pre-function and the lounges. And finally, the window to Delhi there in the front, in the curved area. Here you can see, let me go back. That was the vision, that you could see Delhi from here, the reflection on the windows. And then we start construction, very massive building, a lot of challenges to design the structural part, tall trusses to have these very large spans without columns. Evolution of the concept of the colonnade, the amphitheater, the circulation. This was an amazing picture that happened during COVID. Singapore was still locked down because COVID, and this was happening in the meantime here in India. Everybody doing construction. Singapore couldn't believe that. It was an amazing moment. The technical details, I'm not going to go into that. I'm going to talk more about design, or general design, architectural design should I say. The detailing of this originally was planned as a stone, obviously for cost and for value engineering the weight. So it became really quickly GFRC, pictures during construction, the staircases that symbolizes the fishes, the Yamuna and the Ganga, the multipurpose hall, all the structure, the colonnade, again, the staircases. As you can see, detailing the GFRC presents some very interesting challenges that obviously that is something that has to be taken into account, lessons learned, what to not do next time, follow what Mr. Christoph does, simple, it's a good idea. More relationship images about the Hall of Nations, the huge multipurpose halls, the auditorium, and the window to Delhi. So here, building shape, colonnade, use of colors, use of materials, those were the summary elements in terms of the design of the facade. And this building was, as you all know, inaugurated last year by Prime Minister Modi and was a key element of the G20, which was one of the reasons the ITPO started calling for this competition. We're very proud of this building, has won many international awards so far. So again, we're very proud. Case study number 2, the train stations. They are in an undisclosed location in India. Probably most of you know where they are, so I'm not going to mention much about it. So again, we start with a brief from the client. Somebody calls us and say, hey, we have these train stations. Can you do a kinetic design? That's the first thing they ask us. What are we supposed to do here? Okay. So they want something kinetic. So we start getting information. These are the existing, because the building was already tendered. It was under construction, and somebody asked us to change the design of the facades. So we get the drawings and we say, okay, this is very interesting. And then we ask, okay, what can we change? Bottom line, nothing. You cannot change anything. However, we want a different building. That is one of the challenges we face all the time. So we start throwing ideas, going into what can be done in terms of shape, in terms of kinetic. So we have kinetic in different ways. We have kinetic that opens and closes, like these buildings that we designed in our office long time ago. Then the kinetic that doesn't really move, doesn't have motors or engines. This is Marina Bay Sands, the shingles that relate to the wind, and they create these amazing patterns, and it's totally passive, nothing to take care of there. And then the interactive lighting that creates the movement by use of light, but nothing really moves. So all of those became eventually part of the design. Talking about the shapes, talking about the climatic consideration, environment, how to shade the east sun, the west sun, how to bring natural light into the concourse, but at the same time keeping the solar gain and the heat gain under control. All these are examples from other projects that we have done in different places. Dubai Metro is ours, the MRT station in Singapore. So we started designing Station A. Station A, the inspiration was the diversity of the state, in addition to the rich modern architecture, and then the local vibrant culture. And it became the kaleidoscope of dreams, chasing rainbows on kite wings. 5 principles that were used to design the facade: the kite, kinetic, to fragment the mass, it's a massive building, to introduce color, and to introduce greenery, of course. So we start designing, okay, so what are we trying to do? To create the kites, apologies. Then we start to break the mass and to create some louvers on the sides. And then we start adding the shell for the main platform. And then start to add colors and add layers of greenery. This is what it's become after part of the design process. So again, the kites, the kinetic, the breaking the mass, the colors, and the greenery. The colors were inspired by local references, of course, and the fins have colors on both sides is different. So when you walk in one direction, you see something. When you walk in the opposite direction, you see something different. That's part of the kinetic effect that we wanted to create. Use of aluminum, ETFE, aluminum fins. And then we start looking a little bit about the fins and the kites. The entrance, the jali with the tree of life concept, and then you start seeing the kites there that move and create a little bit of movement. We added this additional roof to create a different experience in the station entrance building. That is the unpaid concourse before you go up to the platform. So all this is additional with these trees that created the opportunity to span a new area in a place that a building was being built, but didn't have these kind of things. The platform, the colors, the tessellation. In this case, this is not a homage to Pragati Maidan. Start detailing the facade. So we have the panels, we have the aluminum fins, then we have the grid shell, and then we have the kites, the rotating, the pivoting panels that will move. The jali pattern for the tree of life, and this is basically what is going to be built. The station B, similar, is very close to the other one, but here is a tribute to the river. So there is no kite concept on this one. The kinetic is more calm down, is more serene. We still want to fragment the mass, bring color, and bring greenery and planting. In this case, the analogy was embracing the river, flowing harmony. So the facade is totally different approach where we start creating these curved lines that relate to the river and then create these opportunities for lighting. The kinetic, the facade movement is represented by LED lights that move. I need to speed up. I'm going to run out of time really quickly. So the exterior view, partial elevations, standing seam details, lighting concepts, nighttime, and then all good, but you can provide options. What else? Then you go start providing options, and we're still debating on the options. Last week, we got another email for more options. We talk about the structural resolution of the building. We model everything so it can be understood properly. In summary on this one, fluidity, river, breaking the mask, kinetic lighting, use of colors, and the green. Now let's go into this one really quickly. This is in Gurugram. This is for Signature Global. I can't disclose this one because it has already been launched. They opened for plot A. They had an expression of interest. There's 1,000 units. They got 5,000 expression of interest, so it's basically sold out. We're very proud and happy about it. But the design process was as painful as you can imagine. We start getting asked questions. What is this? What is that? And then we start the design process and let the options begin. So we have plot A and plot B. We start debating what are the options that we have: traditional planning, resort living, and gateway, and terrace and fluid and edge for the other one. So those were the principles, how the space is used, how the retail and commercial in plot A is envisioned. There is no retail in plot B. The urban approach, some are more pedestrian friendly, some are more central opening. So they have pros and cons. Some have multiple towers, one have single tower. We talk about the density, 12 towers with 3 units to a core versus 6 towers with 6 units to a core, and 9 towers with 4 units to a core versus the other one that is a single tower. And then the approach of how you lay out the units in a building like this. So we start traditional planning, resort living, the ridge. Traditional planning is basically a single space, central space. Resort living is multiple spaces with different activities, and the ridge was dual spaces. So we started on the single space. We plan the buildings around it. We rotate them to make sure that they have the correct orientation and to improve the views. Then we place all the activities in the commercial and the clubhouses. And then we extrude the buildings, voila. Multiple spaces, this creates a network of smaller spaces, each one of them related to the tower, each one of them with different activities and facilities, and then this is the resultant. Dual spaces was to consolidate the thing in 2 major spaces, create the buildings in the center, create activities on each one of them, and extrude the buildings, and bring the green on top. 3 options. And then the client comes and say, hey, wait a minute, did I tell you that plot A has roads going through? So all this idea didn't really work. Now you have to split everything. You have a small plot that doesn't work, and two plots that are part of the design. So we go back to square one. Traditional planning, resort living, and the gateway. So we start redesigning. Traditional planning has now 2 parts. We design the master plan. We talk about the views, the pros and cons of each one of the designs. The resort living, again, fragmented spaces that create identity. Each one of them have a different identity and different purpose, sightlines, massing. And then the gateway, which was part of what created originally the ridge. This was creating this opening, and both of them had green spaces on both sides. This was eventually the scheme that was selected and the one that we have developing. Then we go through schematic design. The design is mature enough to go for sanction drawings. We look about the facade modulation and the design principles. So we have modules. Each one of those modules have subdivisible modules. And then they have this repetition. And then when you start making them in the tower, you start mixing and matching all the colors. And then you end up with this design principle, which is the facade modulation that we use. Then the design is mature enough for launch. These were the drawings that the developer used for the launch and got the expression of interest, the clubhouse, and the gateway. And this is basically what is our design right now. And now plot B really quickly, options, terrace, urban, and landmark. So the terrace that was trying to lift the building and the car park, create this space on top of it, having the clubhouse and the public activities at the front, the tower at the back, the green inside with all the activities and the pool and the greenery. Option number 2 was to create a park a little more in the front, place the building closer to the edge, more urban approach. And then on this one, you have the tall tower and try to bring some of the activities on top. And then the landmark was a mix of both, basically the Masala option, where you have the clubhouse at the front, the parking at the back, and then you put the tower here with a very interesting shape and a signature element. So final concept options. Then we start designing the thing in a little more detail. Let me go back here. The clove, the detail of the fluid became eventually the one that the clients accepted. So all these were design options, part of the process. This is the one that eventually is getting built. And this was the 2 blades trying to interact with each other. Final schematic. Then we ended up here, and the reason we ended up there is we went through the analysis, the climate, the sun, the wind, and then we go through all this analysis of CFDs, try to understand what is the prevailing wind, where do we want the wind, and what part of the year do we want to take advantage of the wind. Same thing with the facade, trying to understand which is the facade that needs the most care in terms of solar gain and protect from the sun. So we start placing the louvers that are around that. So we have heat studies where it's heat and sun, and we know that all these areas are getting a lot of sun exposure. But by the time we introduce the louvers, we minimize the sun exposure in those areas, and that is what basically created the fluidity of this scheme. And all the curves on the facade, we had level by level, and we established which ones were working well. And then this is the design that is getting built. These are the renderings of the project that was launched. The entrance is through the car park, so we have to create this mini version of the airport here. And this is basically the final product. Thank you very much.
Right. So that was an amazing presentation, and we next have a panel discussion. The panel discussion is going to be chaired by our moderator, Aparna Narasimhan. Aparna, if you can please come up on stage. Right. So if you can come up on stage, and if you can have a quickly introduce the other panelists that are going to be joining you.
Panelists covering all the fields, all the stakeholders in this whole profession of ours. So we have 2 architects, Meghna Srivastava, from managing partner from MAP Architects. Hi, Meghna. And then we have Yogesh Tantia, Director Architecture, DSP Design Associates. And then we have, from the client's perspective, we need information too. So we have Mandar Yadkikar, Assistant Vice President, Design Brigade Group. Hi, Mandar. And we were to have Mr. Jatin Shah. I wonder if he's still here. He was from the PMC side. Unfortunately, he had to leave quickly, and because of the schedule of the events today, he couldn't join us. Lucky for him, but not for us. So let's begin. Sorry, oh yeah, Dr. Prashantari, I'm so sorry. You're the reason why we are having this whole event today. So, Managing Director of Fundamax. I think I was introduced earlier today. Aparna Narasimhan from Venkatraman Associates. So actually there's much more to it than what one thinks of when you just hear the word facade. Let's see what there is behind this. There was, this reminded me of an anecdote in that there was this huge hurricane in Florida, and one of the news items, the footage that I saw was this hotel owner was asked, like, what are the losses that you suffered because of this hurricane? And he said, he was in tears, and he said, my architecture blew off. So that's what people think of a facade, you know, that's where the architecture lies, but there's much more to it than just that. So let's find out from our able panelists here. I would like to begin with the architects here. When we, Mr. Shah or Meghna, whoever would like to, I think actually
Yogesh.
So I'd like to pose this question to either of you. How do you conceive of a facade when you start working on a project? When you conceptualize your master plan, when you work out all the blocks, when you orient your building, when you work out the layout plans of the building and the furniture inside, does facade come into play right then? Is it on top of your list of priorities, or that happens along the way sometime? Honest answer.
So, to be very honest, facade comes in a little later. What we principally start with is the principles of climatology to make sure that the buildings are first oriented in the right directions, to allow everything that we need to make the building function, the light, the wind to flow through. While we are doing this, as an example, there are projects where you would want the building to be north-south oriented, but you can't because the site is more elongated towards the east-west direction. That's where you start thinking that while you will do a east-west oriented building, what will you do to ensure that the heat intake is much lesser? And that's when you start thinking that, okay, the facade is going to play a very important role in terms of how you do it. Even in that, we try to first put the play of massing, so that if the building itself could be designed to reduce the heat load, we do that. And then we engineer the facade to ensure that that could play its role to reduce the heat intake to be
So you're saying the orientation of the building and then the massing of the building itself, so the shadows within the
self-shading spaces could be the solution, and then you add that layer of facade to further enhance the performance of the built mass and of the open spaces which people are going to inhabit.
So, Meghna, do you think now with the introduction of, you know, really a specialized glass and such high-performing materials that we have in glass and all that, and shading devices that we have, do you think now it's easier and more flexible to work with the facade right in the beginning, because then you don't really have to focus so much on the orientation and all the factors that Yogesh just spoke about?
I would say the starting point is absolutely perfect when we try to understand the orientation of the building. But with the current technology and software help that we all get while we are doing initial ideation, it is very well possible to understand what the look and feel of the building will be. What kind of facade, what kind of shading. Sometimes these elements will actually become the element of your built form, which you may have turned around and made it twist in a certain way. A classic example is Al Bahar in Abu Dhabi. This particular building has a certain mesh which is dynamic in its own ways, and it creates an opening and closing on the facade, and it actually allows you to avoid the heat gain. And this particular element, which is dynamic in nature, allows you to perceive the building in a very different view from a different street. So it's quite an advantage in today's time to integrate both. What Yogesh said, that understanding the orientation and the impact of daylighting and other aspects on the building, at the same time using these elements to actually make the facade interesting early on.
It can work in your favor.
Yes.
So, but with the current materials and the improvement in technology, you really feel that the budget of the building, does it affect the building, or it's not necessary that higher specs necessarily means more expensive material?
Well, budgets, I also have understood that architects want to perceive their building early on, and they they feel that budgets can be managed. But I don't think we live in a world like that anymore. A lot of financial understanding, a lot of ROI understanding happens on the project very, very early on. And we are in an era where we are actually given budgets from the client side, and we need to work around them to make sure the project is viable, if I can say so. But that doesn't constrain your ideation space. For instance, what SOM was trying for Bangalore Airport, I think they did a fantastic job being within the budgets and at the same time keeping it extremely creative with the sunshades, the different elements which brought in natural light. They saved the budgets of even running the entire
It's
airport.
not necessary that the budget is controlled. I would like to ask you from the client's perspective, because that's the reason why we're all here. So how do you, because it seems to be very conflicting, on the one hand, you want to make a building which is economically viable. On the other hand, you have to worry with maintenance, quality, the long-term gains, because it's not immediately that, energy savings will be visible. So, and then clients' requirements, the users, the value of the building. So when you have all these on one side and you have budget on the other side, and then you have how you want the building to look like and what the architect's vision is, and there's so many parameters. How do you really, what's your decision-making process?
So when we say budget, that's very, very interesting that everyone blames clients or the developer that they never gave us budget and they chop our dreams and they don't let us do our creative things. What I think that we need to understand the budget in principle, it's a multi-pronged term. It's not a single term. So budget can be one broken down into the cost, second value of your proposition, and third is what's the impact of that particular value onto the project. So cost is where most of the time people focus on. But what I am as a developer interested in what value proposition you bring in by proposing certain facade element or any interesting ideas you are been developing with interesting material.
When you say value, what exactly do you mean?
So value to the customers which I am serving.
Sure.
That is a very, very important thing for me. My end user can be the company itself who is the end user having its own office, or the residential buyer or the office tenant. That customer need to get the exact amount of the value what as a developer we are trying to involve as a budget. So that value proposition need to start from the concept level, from the architects, what they are developing, to the more practical aspects of the cost and budgeting exercise and execution of that, and more on that. My design and construction phase may last for a few years.
So
but
one is the value. And
Yeah.
any other parameters?
Sustainability is a very important parameter we are looking at, because we are nowadays targeting most of our projects with at least gold or trying to achieve to the platinum ratings. So sustainability, lesser maintenance, these are the important things which we have to pass on to our customers. So less maintenance is a less AMC to my clients. So this is something which we have a very, very keen eye on. So when we look at the number, we look at the capex as well as opex both, and then we make our decisions accordingly.
I think he makes a good point. We had a case where we were designing a headquarter for a client who is a developer, and the end occupant was already fixed. So we knew that this organization is going to be the end occupant. And that's where the change in thought process came, where the client said that if the end occupant is ready to understand that there is a better solution and there is a buy-in, we can do that. So it was a complete glass facade building, but the typology of glass was changed purely because there was a buy-in from the end customer, and the end customer was ready to pitch in and say that let's do it as a collaborative process. And we changed the glass from a normal glass to a glass which was a intuitive glass, which means it works with the climate outside, changes the tint based on what is the temperature outside, showed the case of bringing the sustainability quotient
And
too much high
probably
level.
the client also felt a bit more confident since he's already had the
Yes.
end
So
user there, and so it's a closed loop. Then
it
there
gives
is
them
no
the
speculation.
push. So we realize that it is not the client does not want to do, in this case being a developer, but a balance between what is the value proposition to how that proposition that you're bringing is future proof, which means it being relevant.
And what the client, what final user wants to project.
Yes, and he has to match the aspirations of the actual user.
So finally, from this, I mean, clearly the success of a building lies in, common goals and this collaborative sort of relationship between the end user, the client, and the architect.
Yes.
You're missing the crucial person here, the project manager. So I wish he was here. There would be many more controversial questions raised at that point. But let's move on to Mr. Reddy. I'd like to know from you, are you typically involved from the beginning of a project when it's conceived, when the elevation is conceived, as a consultant also? Would you offer that value also to the architect, like as a facade consultant and not just a vendor?
Good question. Yes, the role today is definitely more than just being a product company, especially when you have this kind of experience working in tropical countries here and our own history of dealing with different applications and our own. We engage at a very preliminary stage the moment the architect sound us out. It's not only the design there, the consultancy part in our case would be more in terms of the product compatibility to the design. What kind of thicknesses would be required? What if it's just a cladding, or is it a balcony cladding, or based on the wind load conditions, or if it's a fire safety requirement, do you really need to clad everywhere with the fire rated product, or is it also okay to have flame retardant? So this comes in, and we bring in that knowledge, what we should be offering, and that engagement is quite beneficial because this will all go into the specification.
So you have this discussion with the architect or also with the client?
Preliminary engagement is architect, but then we have regularly today we have builders who also have in-house architects, and where we have recurring business. So we also engage them. For them, they are always interested to know what is new, because as the markets get more and more global and we all get to know more and more products, the developers' interest is that what's new, and of course the costs are definitely an issue, timelines. And most importantly, here is an industry where the installation methodology is not so much standardized. So there we come in also to provide the necessary specification text so that the installation.
So you provide the skills that are required at least initially, because it may be a new set of skills which may not be a legacy.
Yes, you also need to. In our case, some of Fundamax has been there for last 16 years. So largely the industry knows how to deal with compact materials, but still the labor part of installation is still quite challenging. We do not have enough SOPs there. But with a lot of new materials coming in, we see fiber cement board, we see a lot of metal cladding. So each of these product companies need to bring those expertise of installation.
Or the material itself should be robust enough where any skilled person should be able to handle it and know how to deal with it.
That would be an ideal case, but some of our national building code and the way we handle our construction, unlike in many part of Western world, where the accountability is largely on the contractors. So it's a different ball game there and here. The best thing is, product companies today, especially with so much of new products coming in, a lot of products have also been cleaned out. What doesn't fit in with so many fire incidents and so on. And today is kind of...
But through tough examples, I mean, it's already run past the people, and then the failure comes at a cost, right?
They come at a cost, but we continue to keep still exploring, and somehow in India we tend to forget these incidents as some bad accidents, and we somehow continue with those practices.
One is the
if I can just add to this, I think the recent COP28 which happened and the green credit initiatives that the government has taken, This is just recent last year, right? And I'm seeing a lot of work that will happen from the material industry and the material providers, because everything will have a certain analysis going in. The entire product life cycle will be understood more clearly. And I think we should all participate towards that journey. And not.
But the weakest link I've noticed is not the product, but the way it's finally fixed. And the skill is the interface between the product.
I'd like to comment on that. I think it is also because a lot of people are having the perception of seeing a product just as a product. We need to see them as knowledge partners. Whichever material you work with, whether it's a glass or it's a cladding, you start seeing them as a long-term knowledge partner, and then you innovate with them and don't isolate them from the process. What can you offer? Rather than we say that what can we jointly do? If that
exactly, so they have to enter the whole discussion right in the beginning.
Right in the beginning, walk the path alongside and see where could we jointly push the pedal.
Yeah.
So as professionals, we always have MEP consultants, structural consultant. We do a very early on deliberation in design development. But as soon as we touch facade as a topic, I think the material provider, the facade consultant who designs the facades in more detail with us, they all should come together. And more of these deliberations should start happening at the very early stage of the project.
It will take a lot of patience from the manufacturers because the timeline can vary from 3 to 4 years from your conception to the installation. But that's where the real journey starts in terms of taking them as knowledge partners and working across various challenges.
There is some progress to add to that. Maybe I wouldn't say for all the companies, but some companies like Shukla is a very good example where we are, even Fundamax for that matter, provides a complete substructure system.
Sure.
The only thing what we don't provide is the labor part of executing the project. Leaving that aside, everything else is provided. But even our engineers are out there on the site to ensure technical compliance by the installation teams as well.
So there is a onus that is taken at your end and labor is something that is outsourced.
That's the success mantra, that you have to be there on the site. Yes.
Get it.
So Yogesh, I just wanted to know, this is a rare chance you get to meet with the client and you have the, obviously PMC was there, of course, and then you have the materials person also. So I just wanted to know, what are with Fundamax, since we are, he's on the dais right now, what are the shortcomings that you find in the materials that this particular, the specials probably, I don't know, the shortcomings with this product, which you think could be refined and, make it a great success?
Sometimes what happens is a right material is sometimes very often not suggested for the right solution. So if you're looking for a seamless surface like surface that we had for the Mumbai airport, where you have a swinging column which is supposed to be looking like a seamless surface. Now, if you provide, if you put a spec of a material which is supposed to be a board, which has its limitation in terms of how much height and width it can carry, so you'll end up seeing those joints. And if you ask the vendor to give a solution, they will never be able to give that solution. So I think the real thing is suggest the right spec and the right material for the right design. And then you will start to understand that these gaps that we often talk about could be taken care of. Having said that, there is a continuous innovation that is required. We did one of the earliest clay facade going back 15 years. And that time nobody was ready to do a clay on a horizontal surface because they were all worried that the tile will fall off. So you had to innovate, put metal along with clay and see how to go about. But today the industry has evolved. They have understood that this is a challenge and there cannot be a middle way. So they have also innovated. So I believe that a continuous innovation process to anticipate what is the need of the future is where we could probably start.
I think that there should be more feedback sessions with the architect and the materials people, so that there is a continuous loop.
And hence I again stress, look at them as knowledge partners and not as pure product guys who are just.
Might be nice if in fact they have an in-house design team which could advise you and use this material for only these things. Don't take a chance here. or advise you?
Use case has to be understood, and then
might be a good idea, Mr. Reddy, to consider.
We do have an engineering team who actually
Also
work on the
design
drawings.
and architecture.
I agree. The challenge is, the people on the field are the sales. Their objective of reaching out and how
Exactly. That is why. I mean, their objectives are different. So if the salesperson is also having someone like an architect or any designer,
a technical firm,
team, along with the technical, so that the person has a aesthetic understanding of it and can relate to the other architects who are engaged with the project.
We fully agree there. So what we do is, when we are hiring our salespeople, we ensure they are coming from an engineering background, either civil or mechanical or even architecture background. So this is something we ensure that they have that basic understanding. One. Number two, platforms like this, thanks to Zak, that what they do, this World of Façades, is a fantastic knowledge platform where both the product companies are there and everyone who belongs to this ecosystem are here. So this is also...
That's why forums like these are very important. That's why, so that you have a feedback.
So the feedback to Zak is that they should have more of this.
I'd like to add a Parna to this. Taking this conversation for the other material providers, say for instance glass, we all want to use performance glass, but very conveniently people identify that one best performance glass, wrap it all around. And that's not the best way forward. We need to understand what heat gain is happening on the facade front. Even the way the material is aging. For Fundamax, how much sun it is going to take over the next 5-10 years and how a particular edge of the building will age versus the other is very important. And that is where this kind of a deep diving will help us have a certain, even while the material ages over time.
Yeah, so that an advisory person within the vendor's team would be really useful to, for us to take away
which
from.
is changing quite fast from the fact that a lot of knowledge partners are trying to walk that path, that when they come to discuss with architects, they are trying to make sure the sales team is there to support with numbers, but there should be somebody who is technically abled.
Sales, engineering, and design.
Yep.
Yes.
Yep.
That's a good
I
point.
would like to add a little bit more on this. So what is very important from a client point of view or end user point of view is the after sales service, because it's not about selling the product and just adding on
Maintenance
the
and
bill.
ops, yeah.
Maintenance and helping the team who is going to be newly into the project. They don't understand what goes in the background, and they make their own assumptions and they make mistakes while doing the first maintenance or even during the installation. So training and having the enough skill sets available in the market for complex installation, or after installation, how to take care of it so that the life it is designed for, it's really real for the end user, rather than we have seen a lot of issues with nicely installed facades, but they have been poorly maintained because people were not trained to do so. And maybe the construction time is only 5 years, but the building has to last for more than 50 years. So that's the bigger time we are looking at. And somehow we feel that sensitivity need to be grow a bit more into the product suppliers and even the rest of our construction community, where we have to train enough people to take care of these things during the its operating time of the building. And
I completely agree. It's not just the initial, in the initial stages, everyone's excited and they want a great looking building, but how does it stand the test of time?
Future
Yeah, that's a good point. So I'd like to also ask you to continue with your point. What are the blocks that you face in delivering a building of your dreams? I mean, in what area do you feel that it's still not smooth enough and could be bettered?
I think not only for the facade, but I think in general, if you see rest of the world,
As far as facades also are
right.
because
So
that's the topic of this.
correct.
Otherwise, there's a whole lot of other things.
Yeah. So where I'm coming from is a little bit background. The technology is evolving very fast, and construction industry is still catching its breath to keep up with the pace and etc. We are on the verge of a wave of disruption coming through AI and all that, but I think we are still holding to the old school of thought ideas, and which is somehow we feel that there is a disconnect between the concept in terms of innovation, in terms of good ideas, to its actual realization.
to make the concept relatable to the market, to make the concepts relatable to the product offering in the market. So there is a very big gap. That's where you
Would you
see.
like to address it to anybody here, like the architect's conception of the idea or the material?
No, not in a specific tool. It's our collaborative effort, because I think this is not an individual's job. I think we all need to come
Trying
together.
to be safe.
Well, I'm not trying to be safe, but generally what happens that architects get disappointed when the ideas doesn't get executed the way they are looking for, and client is not happy when project overgoes the budget.
Why does that happen?
Maybe we are not having enough data point to connect the dots during the design stages. Maybe there is some level of disconnect between when we are conceptualizing some great design in terms of facade or aesthetics, and when we try to convert it into more practical application. Maybe it's multi-D implementation of that, and during the procurement, construction, there is always seen a departmental or segregated approach where
It's not
different.
a holistic.
So it's not a holistic, or there is no one person taking it through. There is one that link is missing somehow. We are not collaborating enough. So I think the transparency, more data-driven decisions are more important to make sure that our designs can be executed the way they are
So
from
as
the
much
beginning.
as you have an idea or visualize an idea, you would suggest that it should be always backed with practicality and
Yeah, so
functionality, and that will only happen when it's collaborative.
yes, the collaboration is more needed than doing it as a departmental approach.
Not
You
the
know?
hard.
So
Yeah.
get out of the silos.
Yeah. You all love Jadu. So, so then, yeah, Mr. Reddy, would you like to say something about how when a building is conceptualized and then the client, also interfaces and figures out that this is the choice that he wants to make. Architects will have proposals and they will come up with ideas, but the decision is finally the client's, right? Would you like to say something here that you feel would make everybody in the team on the same page, would get them together?
Like any product company, they would like to be the architects or customers' preferred choice. But today, what really matters, which has already been mentioned earlier, is the sustainability, which is the most critical aspect. So it is not only from the product point of view that how green the material is. That is somehow largely being taken care. The industry is quite conscious about it, and it's making rapid steps towards that. But now comes the, other than the product, the rest is about finally the product is installed. Now comes the issues of maintenance, energy conservation, based on the sun path analysis, how much heat ingress is there, do you have enough insulation, what kind of installation has been done, is there a bridge between the wall and the panel. So these are things which comes in. And
does Fundamax move like as a shading device also? Do you have plans, or is it just a surface?
Basically, in India, somehow largely the facade here is still an aesthetics element, but universally it is supposed to be a fantastic insulation product and cladded with a nice surface. So my ask or take care would be that with so much of attrition, even which our industry is facing, the exposure for the young engineers, young architects is they do not have much exposure to the new products and new installation methods. So the group presentations have helped us. Firms which have helped us with group presentations for a larger audience have really come in handy, and there's been a lot of engagement there, a lot of right questions being asked. We're able to share that information. This has really come in handy, and this could be done much more better on a larger scale.
Mr. Yogesh, just wanted to know, when you specify for a building, does it necessarily mean that higher performance material means typically a bigger budget would mean it costs more? Is that the success, or is it that you need not necessarily have expensive materials, but you can have a combination? Is there any strategy that you have, like for example, a combination, or it could be anything else that could still perform really well, but that doesn't mean that you'd compromise on the budget or the aesthetics? In fact, it could be even better, like Meghna said, aesthetics?
Yes, again, the use case will define everything. I'm not a great believer that big budgets equal to good design. You could do a good design if the principles of designs are rightly catered to. So design for passive, that's the first important thing. And then
Design and budget are mutually exclusive sometimes.
mutually exclusive, yes. See, everybody would like to work with a bigger budget, but you got to put a practical hat. So if you're doing a school, an institute, there is a certain capex that you could expect. And if you're doing a corporate office, there's a certain budget that you can expect. Or if you're doing a housing which is located in a particular community or in a particular area, so all those budgets will vary. You need to do justice to all of them. So a common ground can definitely be achieved, and not necessarily bigger budgets mean better solutions. Right principles laid out in terms of core can lead to a common path where we could have a good
Some
design.
examples of any of your buildings where the budget wasn't too much, but still you were able to achieve.
So we had got into a competition where we were supposed to design an auditorium for government, which is just now getting handover in Bangalore in Beggars Colony. So it was a government funded project and a 2,000-seater auditorium. So it was very clear that the structure is something that is going to be permanent, and it is not. It is going to be ready to test the time. So we are very sure that all our engineering is where you cannot compromise. So your engineering is what took the bigger budget to ensure that everything is laid out in the right way. The structure is laid out the right way. Big spans are taken care, volumes are taken care, experiential quotient for people who are going to come are taken care.
What was this? What was the?
It's an auditorium and a training center mixed together. A training center because it will generate revenue when the auditorium is not working, and an auditorium because it's a public auditorium which the government wanted to make. Having said that, what took hit was the materiality. While you may want to put marble on the floor, you know that you cannot put marble, which means that you innovate there and you put your sensibilities of aesthetics, try and fetch local materials which have been applied, have tested the time, had stood the test of time, and then you make sure that you take your calls of my cap is this much, what cannot be compromised and what can be diluted. So we came to a common ground that okay, we made our, so you decide which battles to fight for.
Yeah.
So we said the structure cannot take this thing, the spatial expression cannot take a hit, materials can be innovated. While you want to put a very fancy material so that it looks good, we said, okay, let's get our ego down. Let's understand the need of the hour and then go accordingly.
Yeah. Yeah. I'd like to ask you, Mr. Mandar, that these facades are typically, if you look at the typology of the kind of projects that you do residential, you do commercial, you do corporate buildings. When you talk of facades, it seems unlikely that you use it for residential buildings, apartments. Where would you use a facade system for those? More common that you'd use it in a corporate building. Am I right? Or
Yes and no both, because depending on the type of segment for which this building or the project is for, the facade can be really dynamic.
for example, if it's a residential building, give us some idea about where you would think of using.
So something like a luxury developments, they will come with really innovations and maybe very wonderful architectural design which can be offered to the end user because the kind of pricing is been set up for those type of products.
Which kind of surfaces would you use it for?
So generally it can be a mix of your
weather
opaque
cladding
surfaces
or-
as well as the glass. So we are conscious about providing the we are conscious about providing acoustically performing glasses to the high-end users where the depending on the noise survey of surroundings and etc. The kind of experience we want to give it in those particular, we make sure that our acoustic properties of the glass which we are offering is
My question
taken care
really
of.
was that in a residential building,
Yes.
where would you think of using these facade solutions? In what kind of surfaces?
So it can be based on the design feature. So your balconies, your facade projections, your canopies, you have a lot of common areas where you see a lot of scope for innovation. It's not only about making a unit and stacking it up. There can be very dynamic projects where we have a lot of in and out.
Meghna, would you like to?
Yeah, I would like to add to what he's saying. Recently, I was in Mumbai and I was exploring some of the high rises in the city, the newer ones, and especially the ones which were on the 45th and the 50th floor, and the kind of wind pressures that you may have to deal with. Many such projects had a glazing system which was just allowing a tilt of a certain 30 degrees or 45 degrees for just the right amount of air to come in. And even for security reasons, they wouldn't have an open balcony, where people would step out. So this is where an entire glazing system.
To say that it was a
enclosed
glazing system for a residential.
Actually,
firstly, we got to begin with that.
Yes.
So that's happening.
That's happening.
High-rise buildings which are providing vistas to look out for. So Mumbai is a perfect example where the real estate cost is so much that, and the aspirations are so high where you get the sea view. So you are really looking at a situation where typically residential want to work with a little constructed glazing system, which means of the height, the whole height is not something that is exposed to glazing. But with sea facing being the charm of the city. In Mumbai, a lot of apartments are high rise now, and the whole facade is a complete glazing system, just like a commercial building, where you are trying to cater to the view system, which means that I have views and vistas to open up. My glazings are full height, number one. And number two, as you go higher, you are catering to the wind velocities, and you're trying to ensure that that is your real envelope. So all
I
the
think
challenges.
for more tropical weathers like in Bombay or
Bombay is
Singapore and all that,
really
you have an entire glazing system. Whereas for us in Bangalore, it doesn't.
Bangalore
it's
still
still a
to
bit
catch up on
remote
that.
for us.
If you go for high rise, I think at a height of 200, 250
Yeah,
meter,
you might have to
you
have,
have to have for this.
Yeah, where again Bombay is demands that you have to stack up your buildings. Singapore with its
not only
limited
that,
land.
for some very high-end luxury homes, we have Shuku as a partner over here. A lot of solutions are hardware-driven, which means the innovation is really in the hardware, which are able to provide a certain type of glazing systems and allowing you to really
Individual homes you're talking.
Yes, there are individual homes which are basically done in bigger plots, 10,000 square feet houses, which are the guest houses, and so all the HNIs, they have their houses where you need the house is on top of a hill. There are views and vistas to be explored, so you need very high end glazing in terms of sound, in terms of vistas to open up. You want bigger, you don't want smaller panels. You want bigger panels. You want the panels to open up, stack up.
You want the outside to come in, but at the same time you might not want it to come in
Absolutely.
either.
So
you should have those options.
That's a big use case, and from that point of view, facade needs real engineering, which is starting to happen with a cost element. And the appetite for cost is there. So there sometimes cost is not a constraint, but engineering is where we are challenging the facade there.
Yeah, this is just to add one more project which I visited, had actually French windows, which was at the 45th level again. There were French windows which actually opened up, and there was a glass railing in front of it, which became your space to look out from. So a glass railing and a French window in all glass lighting effects sitting together was another unique way of addressing this.
So I guess we got to wrap up because as it is, we are beyond schedule. So I'd like to thank all the panelists, and I hope you enjoyed the discussion and had something to learn from it, as I did. Thank you.
Thank you, Aparna. Thank you all the panelists for a wonderful session with all your insights. Especially the last topic was particularly endearing because me being somebody who lives in Bombay, and we worked on high-rise facades. I think more than 10 buildings we've done, which are more than 250 meters in height, all using unitized curtain walls, and including one project which was very interesting, where we've actually incorporated, as you said, a sliding door system within the stack joint itself. So within the head profile, we've incorporated a stack joint where we've had, your sliding shutters incorporated within that, your railing is incorporated within that, and you have a large panel, with the largest panel being 7 meters in width and 3.5 meters in height. I think you probably visited the Rustamji Ground project over there. But thank you very much. And ladies and gentlemen, I won't hold you back. It's time for lunch. I'm sure you're all very hungry, and we'll be back in 30 minutes post our lunch session. So we have our third session now, after 2 amazing sessions with a power-packed house. Our third session is about to start. To start off the session, we have Mr. Jayesh Ganesh, who is Regional Head, Edifice Consultants. He's going to be talking about facades as an expression of culture. Jayesh, the mic is yours.
Good afternoon. Session just after lunch. I'll try not to bore any of you. I'm going to talk about a very interesting project that Edifice worked on. This is from a few years ago. It's a small office, about 60,000 square feet in the outskirts of Ahmedabad. Well, it used to be the outskirts of Ahmedabad. Now it's very much a part of the city's growing story. This is a 12-story building. It's been designed and built for a construction company called Monte Carlo. And one of the exciting things about this project was that the client was very interested in making a mark on the emerging skyline of the city. And it gave us an opportunity to experiment with ideas that were only on paper until that time. So this is going to be a presentation primarily about the facade, but it's important to realize that the facade over here comes together along with thought processes on what the floor plate should look like, what the public response should, what the response to the public realm should be like, what the response to the climate should be, and in general, how you build the image of the client who commissions the project. So before we start, I'm primarily looking at the facade as an expression of culture. It's a lens through which we viewed our contribution to this project. And the history of kite flying in India is pretty obscure, but the records, especially in art, start from about 1500. And this particular painting from, I think this is from 1780. Yeah, that's right. 1780 shows women in a palace flying kites, and they're on the lawns, and then there are people on top of the pavilion looking at it. And it's a very evocative image because it talks about leisure, it talks about hobby, but it also talks about engagement and sport. And this is not just, this is one of the early examples of a simple sport in which you can participate as a player, but also as a viewer and derive equal pleasure. The city where we were doing this project, the city of Ahmedabad, has a fantastic, beautiful history of many hundreds of years. The old city of Ahmedabad is one of the most beautiful medieval Indian towns that you can visit today. And the growth story of Ahmedabad has, kept lock stock with the growth of the country. Ahmedabad was a very significant part of India's freedom movement. Post that, it has been a significant part of the industrial movement, and today it is emerging as one of the new centers for the growth of the service industry as well as high commerce. So Ahmedabad has the east side of the Sabarmati River and the west side, and our site is located on what is called the SG Highway, the Sarkej-Gandhinagar Highway, which used to be the outermost limit of Ahmedabad city about 10 years ago when I was a student at CEPT. But now, as you can look at this map, it's very much a part of the city's fabric. And when you think of Ahmedabad, what stands out to an architect or a designer is, of course, all these beautiful landmarks which tell the story of the past few centuries. But also, it's not just the image of the large buildings. It is also the fineness and the intricacies within each of these buildings. So the filigree work in the stone in Siddhi Sayed Mosque, which is actually the emblem of the Indian Institute of Management, Ahmedabad, is one of the most iconic sort of architectural images of the city of Ahmedabad. So we had to bear in mind this sort of a tremendous cultural, art and architectural heritage that this city had to offer. One of the most enduring experiences of living in Ahmedabad is to be able to visit the old city during Makar Sankranti, to stand on the roof and fly a kite, and the entire sky, wherever you are, but especially in the old city, is filled with kites. And when you start looking at this image, you realize that there are two stories. There's the stories of the kites in the sky, and then there's the story of the people who are in the neighborhood. And what you can see over here is life unfolding in so many different ways, but against the backdrop of the kites that are flying. So we were very captivated by experiences and images like this, which really allowed for a variety of activities to take place under the shadow of the kites. But now, of course, the city is growing, and a lot of times one does feel in many of the Indian metropolitan cities that you could be anywhere else in India. And our task was to some extent pretty mundane, because we were tasked with building an office building in the new part of the city for a construction company, and they had certain aspirations for what a modern office building should look like. So our challenge was to bring an element of the culture of that place and infuse it into what the modern sensibilities of a cutting edge workplace should be. So just for context, on the rightmost part of this screen, you see the SG highway, which is the Sarkhej Gandhinagar highway. And then we're about a kilometer away from that. What you see over here is a thin sliver, is the footprint of the building. This is now quickly, rapidly developing into one of the latest commercial hubs or the business districts of Ahmedabad. And the other thing that I would like for you to see is just to the north of the building, you have these large empty grounds. This is something pretty interesting about Ahmedabad is when the weather is good, they have a lot of functions in the lawns outside the city. So when you travel on SG highway, you will come across a huge number of party lawns. So it's interesting because a lot of these buildings then get their own foreground because of the presence of these lawns. So when we started looking at the context, this immediately reminded us of this experience of people being in a pavilion or in a garden and then flying kites, and that being part of the urban tapestry, the elevation that you see on the road. So we had a pretty regular site. The setback over here was about 6 meters or so, if I remember correctly. And what that meant was the buildings on the neighboring sides also had a pretty small, I think it was 9 meters. So if you went ahead and built your building on that standard footprint, you had about 18 meters between two buildings. But then what would happen is a significant part of your building would be overlooking the neighboring block. What we really wanted was to improve the engagement of the building with the public realm, the city, while minimizing the exposure or without compromising the privacy for the people on the long face. So we cut a slice across the diagonal. We increased the height of the building, and we created this expansive sort of landscaped public plaza in the front in response to the city, which meant that when you're driving along the road, you do not see the corner of the building, you see the entire face of the building looking at you. And this, on that particular road, is a very unique experience because all other buildings look directly onto the face of the road perpendicularly, which means that if you're driving, you miss the experience of the facade. And of course, we developed the facade, topped it off with a crown to give it a distinctive sort of presence on that road. So this is the Monte Carlo building as it stands today. And you can see again over here in the foreground, this large party lawns, and then you have the main road beyond that, and then you have the building standing, and then beyond that on the back you have the residential neighborhoods. And you will see from the building right next to it that it has a facade which looks out in the front. Now, when you look at this building immediately, you do get a sense that there is something interesting happening on the facade. You do get a sense that there's some sort of a tessellated facade which is trying to tell a story. And that's what I'm going to share with you now. This image over here again talks about how by slicing the building, how it has a little bit more frontage. It's also interesting because at certain times of the day, the entire facade of a building can get shaded by the neighboring block. So this image is trying to tell you a story of how the form, the function, and the facade come together over here. The building primarily has two sides to it. The block that you see over here is the reception and the atrium area, and then you have the tower itself. While we pushed the building behind, we had the opportunity to create a significant gesture with the reception, a truly welcoming, large, hospitality-like space which would welcome people who came into this building. And what we did achieve by slicing the building in half is that we had very small floor plates, which meant that each floor plate could be lit purely by daylight during working hours, which also helped us reduce the energy consumption in the building over here. The other thing that we did over here, which will become more relevant down the line, is we went ahead for radiant cooling, which is a system of air conditioning which relies on metal baffles, which cools through convection rather than convention. So through a combination of a narrow floor plate, which was completely daylit, by leveraging the other slice of the block, which allowed us to create a grand gesture of an atrium, we were able to bring together the functionality of the space with an interesting form and accentuate that experience through the facade. So here you can see in these two sections, so you have the cross section, which is showing a very narrow floor plate, and then we have all our services, our fire staircases, everything on the south and the southwest side of the building, completely protecting the rest of the workplaces from the heat gain from those two quadrants. And then on the transverse section, you can see that it's actually a thin but a wide floor plate, which means that a variety of activities can then take place along a single facade of the building. And this is the plan. So this is if you look at the size of a workstation for scale, then you can see that the reception is actually a significant architectural gesture, and it is facing this large open space that has been created abutting the main road. The facade of the building over here is showing the largest surface area to the road along the direction of the movement of the traffic. And what we have over here architecturally is two significant sort of messages being conveyed by the sharp point that kind of draw the attention of the people who are on this road. Also, and crucially, the south and the southwest face of the building is completely shielding the rest of the building from the heat gain that is happening from the south-southwest quadrant. So this is an aerial image. Again, that was the plan, and then this is an image of that. So we refer to it as the tail of the two facades. We do have the east wall over here, and then the roof of the reception, which also has an interesting story. So we worked with Terra Viridis, one of the best practices in the field of sustainability, and they helped us model and engineer the facades of this building from a heat gain perspective. So this is an analysis for the east wall, and the other significant analysis that was done was for the roof of the reception. Now, the east wall gets a significant glare from the rising sun, especially between 9 a.m. and 12 noon. And then the reception roof gets a significant amount of incident heat and light throughout the day, but most particularly around the noon time. And it was very important for us to address these two in the facade design. So talking about coming back to the cultural impact, the image of the kite, of course, is very iconic. It has a role to play in the lives of the people in the city because it has a strong image, and it also has a strong sense of participation for the community. We tried to, when we looked at the kite, it's of course a sort of a two-dimensional image. So we looked at extruding that in 3 dimensions to give depth to that form. That's where there was a little bit of study about how, you know, the plan of the diamond has so many facets, but it's actually the elevation. It shows how the lattice lifts up. So that's the kind of study that was done. And we arrived at this module of 3.5 meters by 1.8 meters on the basis of which the sort of the kite as a unit of the facade was developed. So this is again a construction of the facade. So you have the eastern wall where you do have aluminum framework on which we have the glass facade. It's a simple DGU with a argon air gap. On the western side is where we have the sage glass. I'm sure the technology has changed now, but back then it was controlled by BMS and it could change the VLT in 4 stages. That was the technology we were using. And also significant effort in engineering the facade for the reception, which is also sage glass. So we were able to change the VLT between 1% and 66% through BMS, and that was controlling the amount of incident light and heat from the west as well as from the top. So this is the entire thing is a unitized glazing system. And one of the design challenges for us was what should be the module of the unit which goes onto the facade. Would anyone be able to just hazard a guess out of the 4 of these, which was the module that we went with? Any guesses? You're saying the one on top? Anyone else? The second one? Why? It's a kite shape, okay. And any other guesses? So why did you think it was the first one? Right. So what we wanted was we wanted the geometry to look like this, but you know the facade system gets laid horizontally, and if we did this, we'll have to move in a zigzag pattern. So what we actually came up with was the unit looking like this, but the expression of that unit being a diamond or a kite. And when we did that, what happened? The other interesting thing over here, and we realized this as we were working on the design process, is that now the dimension of the kite is 3.5 meters by 1.8 meters, but the dimension of the panel is 3.5 meters by 2.7 meters. And the reason we had to restrict it to that is because that was dependent on the size of the shipping container that would bring the panels. So there's a very interesting give and take between what the design decision was and what the logistical issues around transporting the facade were. So here you can actually see this is the rhomboid panel, and it was laid in course like this. But once the panel started getting laid, the predominant geometric expression was the kite. And that's the entire thing done all the way to the crown. Zooming in further, just on the east facade, you will see that the kite has 2 sides. We have facet 1 and facet 2. And they were both pointing in different directions. So obviously facet 1 is exposed to sunlight very differently than facet 2. And the heat gain was much larger on facet 1. As you can see over here, 850 kilowatt hours per meter square. So what we did was we went through an exercise of proposing various different solutions to that. But in the end, what emerged was that to some extent, we are letting the sunlight dictate or pushing us to over-engineer what could be a simple and elegant solution. So rather than engineering the facade, we started engineering the air conditioning. And while a conventional air conditioning system would require 1 BTU for about 180 to 200 square feet of area, we're working with radiant cooling over here, and we're cooling about 450 square feet per BTU. So we're already looking at about 60-65% better efficiency. So the light that comes from the east for about 2 hours from 9 a.m. to about 12 noon, we are trying to offset that in terms of heat by having a much better, more efficient sort of an air conditioning system on the inside. And these are all some details of the same study, difference between facet 1 and facet 2. So I'm just going to end this presentation by leaving you with a few images. This is the double height reception space. So the entire roof is sage glass. You're probably looking at this image at some point in the afternoon. If you were to look at it during the day, it would be a lot more clearer because the VLT will be closer to 1%. The facade is not just something that is on on the skin of the building. It has a role to play in the design and experience of the inside space. So if you could see the way the PET panels have been designed inside the meeting rooms, they are all sort of conveying a coherent message throughout the experience of the space. So these are again the narrow floor plates which are largely day-lit. There is very little need to have artificial lighting during the day within these workplaces. And this is how the facade ends in the crown all the way on the top. So this is again an aerial image. So just coming back to what we were talking about earlier, that is the SG highway. We're about 1 kilometer away from that. These are all the party lawns that are in the front. So when people are going to be in the lawn or even on the road, on the public realm, the building is going to be a significant backdrop to that. And it's coming back to that image of people looking at the kites as the kite being sort of an interesting and culturally relevant sort of a motif in the skyline of Ahmedabad. Thank you so much.
Thank you very much, Jayesh. That was a very informative presentation. That case study where you went through right from the concept stage of how you actually came up with the concept of the building to actually getting into the detailed design and to the final execution. I thought it was very informative and very extremely interesting for all of us to watch. Thank you very much. Right, next we have somebody who I've known for a long time, who's been in the powder coating industry for more than a decade, and he is Deepak Parameswaran from Jotun Coatings.
A very good afternoon to all. Thank you very much for the kind introduction, and it's a privilege to be here amongst you all on this forum. Durability, aesthetics, and sustainability. I believe this is an integral part of each and every architectural masterpiece that you all create. Jotun is very proud to be associated with you on this journey through our product solutions and offering. We would briefly, in a glimpse, if we can show you some of them, we'll be very happy to do that. We will be doing that today. Before that, we would like to just give a brief about what Jotun is all about. Jotun, with its roots in Norway, has been in the paints and coatings business since 1926. We have been nearly for about a century now in the paints and coatings business. We started our journey with marine coatings and gradually then developed world-class solutions in decoratives, protective and powder coatings. We are truly a global company with presence in more than 100 countries and with 40 production units and most importantly the 7 regional development labs. We focus a lot on innovations and the constant improvements that needs to be made in our products and solutions offerings. Our Jotun facility in India is located in Ranjangaon, which is about 60 kilometers away from Pune. As I said, you all create masterpieces and we are a part of it. This is the list of top 20 skyscrapers that dot the globe. And we are very proud to be associated with our paints and coating solutions in 14 of them. Today, our main focus will be on powder coatings. And we will be mainly focusing on the architectural segment, but we also are present in the other segments like the appliances, furniture, general industries, and pipelines. Regarding the architectural powder coatings, with iconic projects globally like the Burj Khalifa and local iconic projects like the Mumbai Terminal 2, we understand how important it is for you to create spaces and environments that are most importantly beautiful, durable, functional, and sustainable. So let's get to the durability part of it first. Powder coatings on architectural aluminum is primarily driven through three major specifications, which includes AMA 2603, AMA 2604, and AMA 2605. We correspondingly have Jotun Facade against AMA 2603, Super Durable against 2604, and Durasol, which is the best in the class, against AMA 2605. We correspondingly offer 15, 25, and 30 years guarantees respectively. Fire is a lot in the news nowadays, and we are very glad to inform that our products are also certified for fire combustibility, and they are certified A2 and A1, A1 being the highest. So first we will focus on the we understand that there is a lot of, we understand there is a lot of inputs on quality now, and the market is also getting matured, and we are seeing a lot of usage of Jotun super durable products in the market. And if we compare them on, say for example, the performance, if we look at the performance, it is a high quality super polyester product where we are in compliance with AMA 2604, and we offer 25 years of guarantee for the product. In terms of aesthetics, we offer a range of shades, and more importantly, it is available in a lot of texture finishes, metallics finishes, metallic textures, and other shades as well. When you include a cool pigment in it, we can offer it in cool shades as well, and that adds to the environment friendliness of the product as well. So there is a theory and the practicality of it. There are many consultants, architects who basically ask, how does the product basically perform on the project? We have been measuring a couple of projects in the Middle East, primarily to understand how the products has been performing, and we would like to showcase a couple of them here. The first of the project is Atlantis, the Palm. On this project, basically, we have used RAL 6033. It's a super durable 2003. And we have measured the project on 3 aspects, which is the gloss, the color difference, and the film integrity. The film integrity, as you can see from the picture on the right, it is basically, the film is very close to the master panel. Each and every project where a guarantee is offered, we ensure that we have a master panel which is retained, and we basically compare it against the master panel, and the film integrity is intact. There is no problem in the film integrity at all. After 15 years, we also see the gloss and the color difference is also well within the specifications and the limits that are laid down by various standards. Second is the shoreline apartments, which is also on the sea coast, on the ocean. In this case, we had used RAL 1014, a lighter shade, and after 17 years, the results are on the screen. The gloss and the color difference are well within the limits, and more importantly, the film integrity is also well there, where the window profile and the master panel can be compared. So this is the actual performance of these powder coatings. They are very well tested powder coatings, as you can see. The next one, which is catching a lot of traction in the market, is Jotun Durasol. This is basically, as the tagline suggests, it is for timeless protection. This uses a fluoropolymer resin, and it is in compliance with AMA 2605, and we offer 30 years guarantee for this product. Aesthetics wise, it can be offered in a range of shades and finishes, and sustainability wise, since this is a powder coating and it has no solvent, as like any other powder coating, it is a very highly environment friendly product. It is low VOC and lead free product as well. So environment friendly wise, sustainability wise also, it is quite a performing product. There is a lot of, since it is an AMA 2605 compliant product, a lot of comparisons gets drawn against the 3-coat liquid systems which are there in the market currently. And we thought that it would be good to just give you some pointers highlighting the benefits of these products. First and foremost, it is a single coat system, which is in the range of 50 to 70 microns. As we said, it is a fluoropolymer resin, which it uses, which is in equivalence with any PVDF system that you have. It has got extreme durability, AMA 2605 compliant, low VOC as against for PVDF, which has a solvent, and thereby it is not a green product as such. Efficient application. It is a single coat application. The application is much faster, and thereby it helps in the project completions and schedules in a much efficient way. And more importantly, we offer a 30 years guarantee against the guarantees offered by PVDF, which are lesser. Now, when we talk about guarantees, what do the guarantees basically cover? As I said in my previous slides, the guarantees mainly cover the color retention, which is the delta E difference that we talk about. The gloss retentions, what is the difference between the gloss between the master panel and the panels which are down the line, and the film integrity. So these are the 3 major parameters which are covered in the guarantee document throughout the duration of the guarantee period. How do we assure that the guarantees which are offered or the qualities offered is assured? We basically have an approved applicator program. There are n number of applicators in the market, but we need to ensure that we are segregating the best from the rest. So we have a very well designed Jotun approved applicator program where we audit the processes which are conducted by the applicator, the chemicals that they are using, basically the pre-treatment process, the spray booth, the spray guns, and the curing oven in general. So apart from that, there is also an accelerated testing that we do, and based on the results that we get, we basically ensure that they are given the approved applicator certification. Globally, for Durasol, we have 87 approved applicators, including 4 in India, 182 approved applicators for super durable, including 26 in India. This ensures that you have the peace of mind in terms of both guarantee as well as the product which is applied on the building. Coming to the aesthetics part, we covered the durability part. Now looking at the aesthetics part, aesthetics is mainly in terms of the kind of shades that is getting offered or the finishes that are getting offered. So basically you get them in a n number of finishes in powder coatings. Some of them listed here are the metallics finishes, Sahara, which is a fine texture finish, cool shades, which is a finish which can give you additional lead points and ensures in heat isolation and reducing the heat island effect. And wood spiration, which is now I believe is getting quite common, which gives you a wood-alike effect on the aluminium. One by one, if we consider metallics, I mean, as the tagline suggests, let your designs glare. It basically represents a premium elegance and luxury. It gives depth to your projects. More importantly, it also gives you dimension and emphasis. Today, there is a lot of projects which uses metallics, and they basically stand out quite distinctly as compared to what you see in terms of the solid shades which are getting used. The right content of metallic needs to be used. On the application line also, how the entire, how the metallics work is also important to ensure that you get the right finish. We ensure that we have a technical sales service team to guide you on that and ensure that you get the right finish at the end of the day. The Sahara collection, it is a unique fine textured finish that we have. Sahara finish, by the courtesy of the fine texture, helps in basically hiding the imperfections of the substrate and the dye lines and the welds. It also helps in improving the mar and the scratch resistance. And finally, as compared to solid shades, it improves the dirt pickup resistance as well. This is a product which is also getting quite widely used. I mean, there are a lot of common shades now being promoted by the system supplier companies as well. And in general, a lot of other projects are also using these kinds of texture finishes. Wood spiration collection, as I mentioned before, it gives you a wood-alike effect on the aluminium. Generally, world over, there are two basic processes by which you can do wood effects. One is the sublimation technology and the other is the powder on powder technology. In India, the powder and powder technology is not available. So you have the sublimation technology, where basically what you're doing is that you have a base coat of powder and you have a film which is impressed upon it through a sublimation process. The combination, the permutations and combinations of basically the powder and the film gives you a range of finishes. Some of the finishes are basically shown on the screen. These can be used in interiors as well as exterior environments, and they offer a distinct finish to the aluminium, nearly imitating the wood effect. The cool shades collections. I mean, this particular product is actually is gaining a lot of interest in the market. This particular product uses a special pigment which ensures that you can measure the SRI value, the solar reflective index of the product. The solar reflective index, basically higher the solar reflective index of the product, better is the product in terms of it reducing the heat island effect, and more importantly also ensuring that the heat the isolation is done. The heat isolation is done between the external and the internal environment. So these are used in products. They are also used on the roofing shades and roofing solutions as well. So this is another product which is gaining a lot of traction. This also helps you in getting 2 additional lead points. So cool shades, there are not many projects which are done in India, but it is getting a lot of traction, as I said right now. Green building solutions. Now coming to the sustainability part of it, if I can just highlight the kind of points that we basically get through the paints and solutions, we get about 7 points through the paints and solutions that Jotun offers on various parameters according to LEED V4. So these include sustainable sites, material resources, and indoor environment quality. If you consider the powder alone, in terms of the kind of points that we can get, we can go up to say 4 points in terms of heat isolation, in terms of reach compliance, and in terms of cool shades as well. So I believe the lead is under some amount of revisions, and EPD is getting more and more importance and significance in the entire process. They are going to increase the weightage to 5 points. In that case, the 7 points can move to 11 points through paints and solutions coatings. Since we are on the topic of EPD, it gives us great pleasure to inform you that Jotun is in fact has the highest number of extensive lists of products list with EPDs, whether it is liquid paints or powder paints. And all these, we invest a lot in this, and these have to be renewed every year. And we are basically certified by third parties, and all these are available on a website which any one of you can go and access and have a look at. Architectural steel coatings, generally the liquid coatings are used, but powder is also gaining traction in this area as well. If you see, this is a 2-coat system where you have a zinc-rich primer, and on top of that, you can use either the facade or the super durable product. And we offer 5 years guarantee for anti-corrosion for architectural steel coatings. This goes up to say CX environments. We have solutions which we can provide up to CX environments as well. And we are getting a lot of requests for these kinds of coatings as well on architectural steel. Quickly taking you through the project references. This is one of the best projects that we have done. Burj Khalifa, Jotun Durasol projects. We have been executing Jotun Durasol since 2007. It is now in India that we are gaining traction, but this is a tried and tested product globally, and we are very happy to offer you this product through our India unit. Khalifa International Stadium, Jotun Durasol in Saudi Arabia, Qatar, and more importantly, locally, if we have to come, then we are working on 2 particular projects, which I would like to highlight. One is the project which we did in 2015. This is Olympia Park, India, which used Jotun Durasol. And the current project under execution is Noida International Airport, which is a classic case of PVDF to powder conversion, where we are using Durasol. Super durable projects also, this is a time and tested product, as we saw in the now and then section. And these are also quite used quite widely. The quality parameters have improved in the projects that we are looking at today. And some of the India projects that we have done include which are still under execution, include the Common Central Secretariat, the DLF Downtown 4, SCB Cuttack, which is under execution right now, and the Phoenix Market City. Thank you very much.
I think you covered the whole spectrum of powder coating from beginning to end, to those who didn't get it, to those who don't know, and it was very informative and technical. I think everybody enjoyed that. Next, we have somebody who I've known for a long time. I've interacted with him at the tendering stage of a project, doing a mock-up together, and had various challenges together. I grew very close to him at the time. That is Mr. Nandakumar from Evermark Facades, who's been a facade consultant for the past 4 years, but been in the industry for almost 20 years now, working with the fabricator first, then with the PMC, and now he has his own facade consultancy. Nandakumar.
Good afternoon to everyone. So, I'm very privileged to talk in this forum. So my topic today is the right cladding for an elegant facade. So it is more of an architectural basic presentation which I wanted to present in front of you. So I'll be taking you through the various facades which normally are done across the world, and some of the new ones which is being thought of. So the first one is the rain screen facade. So these are typically 2 wall facades. There is a ventilation cavity between the main structure and the outer facade. So the outer facade is called as a rain screen facade. It's generally used against a concrete wall or a solid block work, and it helps to manage the moisture or direct rain hitting the main facade, and it improves insulation because there is a cavity in between, and it also offers freedom to select various materials. So on the exterior facade, so here you can see you can start from brick cladding, brick slips, perforated panels, tiles, stones, the HPL panels, etc. So the principle of this facade is mainly there is a ventilated cavity, as I told before, and there's a gap at the bottom and the top of the facade. So wherein the air enters through the bottom of the facade and it comes through the top, so that the entire cavity gets ventilated. So we can have different sizes and different type of joints in this type of facades. So as you can see here, you can go from a small piece of brick type of size to like a very big panels, depending upon the weight of the panels and the size of the available size of the panels in the market. So you can choose from different types of joints between the claddings, right from a basic open joint to a tongue and groove joint. So the tongue and groove joint is mostly done for the tile claddings, or the ceramic tile claddings or clay tile claddings, which is getting popular nowadays. So on the size of the joints has to be designed based on the fabrication and installation tolerances and the available the panel sizes in the market. Normally the manufacturers have standard sizes available which they market, and the building movement and thermal expansions. So the most important point to note in the rain screen facade is the fire separation, so which many of the times it is omitted in the design when we design a rain screen facade. So as per the codes, you will have to isolate the fire and make a compartment. Normally it is about 20 meters compartment horizontally and 6 meters vertically. However, if you have a window or a balcony attached to the facade, so you will have to separate it at the balcony or window corners, so that the fire which is occurring at one point doesn't spread through the ventilated cavity and get through the windows into the building or through the balconies. So the next facade which I'll be talking about is the masonry facade. So these are actually the oldest facades which have been used, and normally there is the concrete or a main structure which is built, and in front of that a masonry wall is built. The masonry wall acts as a external facade, and the external facade can be made up of bricks or the standard bricks what you get, or the blockwork or stones which is stacked above each other. And the external facade is, the internal facade should be a load-bearing facade, and external facade can be a lightweight one and can take a minimum loads. So these masonry facades are very popular for shorter buildings. It can't be advised for taller buildings because it is more or less similar to your wet cladding. So this has to be broken at every 2 floors. So after every 2 floors, the dead load has to be transferred to the main structure. So you will have to have a horizontal support at every 2 floors so that the load gets transferred. The next one is the precast facades. The precast facades are used in the projects, high-rise projects, which where speed of the project is very high and the quality of the facade, the expectation is very high. And these kind of facades are advised for buildings which are taller and has a repetitive design, so that one design can be frozen and it can be multiplied, and the mass production can be taken up at the site, at the factory level, and it can be transported to site and installed. So similar to, so even the columns and beams also can be integrated with this, and the external finishes can be, so the external finishes can be either a brick or any other material which you can think of. And normally it comes as a panel, like somewhat similar to the unitized panel, and you will have to design the grooves between the two panels. So this is lifted with the help of cranes, so that you don't need any external access, and you can choose from various. It's not going back, sorry. So you can choose from various external finishes such as stone, ceramic tiles, or brick slips, etc. And the important point to note is that similar to your unitized facade, you will have to have a drainage at every panel on the top, so that it drains out the water whichever gets in, and the joints has to be designed for the drainage cavities. So the next is the curtain wall facades, which are the most popular ones which are being done. And this curtain wall is defined as a non-structural wall exterior to the building, which acts as a weather defense to the building. It is done with the horizontal and vertical mullions and transoms. Normally aluminum mullions and transoms attached with the glass. And the external facade, the curtain walls has to be designed for the wind load and dead load. And it has to consider the structural loads, which structural deflections, which are transferred onto the curtain walls. So these curtain walls can be integrated with the doors, windows, and different elements such as fins, etc. So for low-rise projects or a very short buildings, so you can go with the stick glazing or semi-unitized glazing, wherein some of the so most of the things happens at the site level, and a few things are done at the factory level. For high-rise projects, it's recommended to go with the fully unitized facades, where the fabrication, around 80 to 90% of the work happens at the factory. It is transported as panels and installed at the site with the help of the crane, so that you don't need an external access for installing these panels. Similar to this, you can make it as one panel integrated with various materials, and it can be installed as each panels. So the next popular facade is a sandwich panel facade. So the advantages with these facades, so initially they were using only for the industrial projects. Nowadays the commercial buildings and malls are adopting these kind of facades. And the advantage of these sandwich panels is it gives a better thermal insulation to the building. It is sandwiched with 3 or 4 materials, and it forms as a composite panel. And it is joined with the help of a male and female joint, so that you get a seamless finish on the facade. So these facades can be done without joints up to 14 to 15 meters, and you will get a more seamless kind of look, something like this. And generally it is used for industrial buildings. Nowadays it is being used for commercial projects as well. So you can install it vertically, horizontally, and you can get a seamless finish, and it can be integrated with your other elements such as roofings, etc. So sandwich panels also help in attaching your architectural elements to the facades, such as perforated sheets, expanded mesh, which are being specified nowadays by many architects. So the next facade is the living green wall. So this is a special type of facade which are adopted for few projects, especially for the residential buildings. So the main thing in this facade is when we are choosing these kind of facades, we'll have to keep in mind about the access for maintenance, the availability of the manpower to do these kind of facades on the building, and also the climatic condition of the surroundings where the project is being executed, so that in a very harsh climate the plants will not survive. So the next facade which is getting popular nowadays, and few projects are also executed in India, is with the ETFE facades, which are mainly done as a decorative facade for entrance canopies, convention centers, cafeterias, etc. So the biggest challenge in this facade is the maintenance of this the panels. It is actually inflated balloons which has to be automated with the kind of sensor, so that the pressure remains throughout the time. So maintenance becomes a challenge in this kind of facade. So, and if the balloon gets deflated, so especially if you are using it on the roofs, so in case of rain, so the rain may get stagnated, the water may get stagnated, and the load also might increase. So the structure has to be designed accordingly. So if you are recommending these kind of facades. So the next one is the GFRC panels, which are increasingly getting popular nowadays. So it's glass fiber reinforced concrete. So the advantage with this is you can mold it into any shape, and you can give a architecturally better look for the buildings. And also it is lightweight, and you can make it as a repeat. So one mold can be done and it can be repeated with different kind of different type of designs can be integrated. And the next one is the 3D printed facades. So these facades are relatively very new. So the entire facade can be printed with the help of 3D printing technologies. Few projects have been started with this kind of facades. So normally it is done with the concrete printing, and I think in future other materials also will be added to this. So you can see there are two projects which are the first one on the left is the demo project which was done few years back, and the right one is a post office which is done in Bangalore with the 3D printing technology. The entire building was done with the 3D printing technology. So the next one is the profiled glass. So this is something which is getting introduced to the market. So these are thin slats of glass which can be installed vertically or horizontally, and you can go up to 6 or 7 meters height. So this can be used for double light areas. For the areas where you need lesser light. So the transparency is normally less in these kind of facades. So you don't need an aluminum structure. So you can join the glass profiles itself can be joined together to form the facade. The next one is the double leaf facade. So it is similar to the rain screen facade. The only difference is you will have a much larger gap, and this also helps in improving the efficiency of the building. So you will have to keep the maintenance, how you are going to do the maintenance, maintaining these cavities when you are designing these kind of facades. So next is the closed cavity facade. So this is similar to the double leaf facades. The only difference is you will have a kind of a screen or something in between, which can be automated or manual. So you can, if you don't want the light to come in or the heat to come in, you can close it with the help of louvers or Venetian blinds, etc. So this improves the thermal performance of the building. So coming to the major materials which are used on these type of facades, what we spoke now, the main one is the glass, which is most commonly used, which can be used for the vision panels, skylights, spandrels, balustrades, etc. And also special applications such as staircase railings, spider glazings, etc. And the next material is the stone. Stone is becoming popular nowadays, and it is used on with the help of rain screen principle, and also nowadays it can be done with unitized glazing as well. It can be integrated. So you can have different types of joints in the stone, right from the rivet joints, which are visible. The rivets are visible to the external, to the undercut anchors, which you can use so that the anchoring is not visible and it gives a seamless finish. And the main thing you will have to keep in mind is you should have a safety mesh to protect the stone in case of any breakage or any damages, so that it doesn't fall off on someone from a height of the building. So bricks is more commonly used nowadays for the, it can be used as a masonry structure or also as a rain screen tiles. So brick tiles are available nowadays as small as a brick size to the clay tile shape. So it can be used for taller buildings as well. It can be integrated with precast panels or unitized panels and GFRC materials. So it can give you a variety of shapes, and it can be as thin as 12 mm thick, and it can be used where the structural load can be reduced. And ceramics or clay tiles, which are popularly being used. You can get in different colors, different shapes, which can be used for the buildings, either vertically or horizontally. It can be installed, and there is a provision of even removing the clay tiles in between if there is any breakage and reinstalling it. It can be integrated with the panels as well, the unitized panels along with the glass, and you can install these clay tiles or ceramics, and can be also used as for louvers or architectural finishes as well. And metals, of course, can be used, the perforated sheets, expanded mesh. So these kind of facades can also be used on the building. So this is one of the choice of materials available. And the last one is the, nowadays it's getting popular, is the corroded effect on the facade, wherein you can install it like aluminum sheet cladding with various different options are available in the system. And these facades over a period of time changes its color. So initially 2-3 years it will retain its color. After that it gradually changes and you get a different look on the facade. So to summarize the entire presentation, so the key points to take away in selecting the right facade is, so first choose the right system for the project. If it is low rise, go with the, you can choose masonry structures, semi-unitized glazing. So ETFE, GFRC, all these systems are for the low rise. Mid-rise or high rise, you just prefer to go with the unitized facade so that your access can be done from inside and it can be installed, and the installation speed is also faster and the quality also can be improved. And whenever we choose the system, it is important to keep the fire requirements in mind, especially for the high-rise facades. So when we are choosing the different materials, we will have to look at availability of the materials within the surroundings and the skilled manpower available to fabricate and install these kind of facades. The cost, of course, and the maintenance of this facades. Then the performance, that is, we'll have to look at structural performance, acoustic, and thermal performance. So because of lead is also one of the factor nowadays. Thank you very much.
Thank you, Nandakumar. That was very informative. You had this, you went through every single type of facade system with a very detailed mindset, structured approach. I thought, complete basics to advanced level, completely covering every aspect and different type of facade typology. We have now a structural engineer, Mr. Malvinder Rooprai. I have worked with him, also co-hosted a presentation with him in the time of COVID, if I remember correctly. Very advanced analysis Malvinder does in terms of shell theory, plate theory, non-linear structural analysis of bending of glass and other sort of in-plane, understands glass very, very well, understands lamination really, really well. Malvinder.
Thanks. My name is Malvinder, and today I'm here to talk about high performance, durable, and environmental friendly laminated glass. And I think the picture here tells you all. My friend Sumit has a broad smile on his face because he's sitting on a high performance laminated glass flooring, of course made with Century Glass. So let's start with the basics. I think everyone in the room knows what's laminated glass. But every laminated glass is not the same. So here we have a cross-sectional view of a laminated glass, and what goes in between the two layers of the glass is not always PVB. And what goes in between the two layers of the glass can decide the functionality of the glass to a great extent. And when we see the cross-sectional view of the glass, what comes to our mind? It's always safety glass, you know. But let's go beyond safety and let's see what the interlayers can provide you beyond the basic functionality of the glass, which is safety. So here we have different applications of laminated glass, and you can choose a different interlayer for each application. So always using the PVB for all the applications is not going to give you the optimum performance of the glass. So selection of the right interlayer for the right application is very, very important. And we at Kurare, we can offer you the best interlayer matching to the needs of your application. So here we have done the categorization of the different applications of laminated glass, starting with safety. So when you want to ensure that there are no injuries to the people, you can use the standard clear PVB. And of course, we have structural applications where like people are imposing a live load onto the glass surface. Then we have structural applications. So we recommend to use Century Glass for those. Then we have security applications. When someone is trying to intrude into the building, then Century Glass is recommended. Then we have open edge applications of the glass where water can actually ingress into the edges of the glass. So then Century Glass is recommended. Then we have colors, and also you can do noise control with PVB interlayers as well. So here we have some of the mega projects, starting with the World One in Mumbai to the Apple Steve Jobs Theater in Apple headquarters, Cupertino, US. We have Shanghai Tower in China. So you can see these are some of the mega projects where our high performance interlayers are in action. So let's go a little bit deeper into the subject. How does the selection of the right interlayer in different applications can enhance the value of the glass? So I have a couple of movies which are displaying that, if you choose a right interlayer for different applications, starting with the balustrade application here we see, and then we have a bullet resistant glass making use of different interlayers and a spall shield interlayer on the protected side. And then we have anti-intrusion glass made with Century Glass. So all these applications highlight, that we can go definitely beyond safety, and what type of interlayer you have chosen for for different application can really make a big difference here. So the first video is playing in loops. You can see how this glass is being impacted by this swing back, which is simulating the accidental impact of let's say a teenager who is like full of energy and he's unable to see the glass. So still it is providing the enough post residual breakage strength, so that the person is not actually falling off accidentally off the balcony. Yeah. So when we talk about laminated glass, people have some inhibitions in their mind when it comes to laminated glass because they are not really sure if the product is going to be durable enough for the project. So I think this is a typical thought which comes into the mind of a facade consultant. So definitely there are some concerns which are very obvious because we have seen so many projects, and these are very typical images you can find in any project. Yeah. So how we can avoid these issues with the laminated glass? So let's go by one. So there are certain reasons why this happens. First is the poor adhesion between the glass and the interlayer. And this can get impacted by a number of reasons. Firstly, the interlayer may have very high moisture content because of the wrong storage conditions. And this graph tells you that how the interlayer can pick up the moisture if it is not stored properly. How you can check the adhesion? So you can just break the glass and look at the breakage pattern of the glass. So one is, so here we have a reference sample. If the breakage pattern is somewhat looking like this, it is called like very poor adhesion. We give this rating as 1, and 8 is the typical breakage pattern when we have got the highest adhesion because the glass is still sticking to the interlayer. And on the left-hand side, we have the image number 1, where is very few portion of the glass that is sticking to the interlayer. Number 2, the processing of the glass. So the tempering quality of the glass plays a big role into the delaminations. So when you do any kind of heat treatment on the glass surface, it has a tendency to develop this kind of waviness. So this waviness can be controlled. So you have to make sure of the plies are, the pairing of the glasses has to be done properly. And then when the tempering quality is not up to the mark, then these clamps are used, which is the obvious reason for the delamination of the glasses. And then third is the bad degaring. So if you have ever been to the processing facility of a laminator, this is the view from the nip rolling process. So the air need to be squeezed out properly, and this is the typical image of a glass which has been done properly. The air has been squeezed out with proper edge seal, and this is an example of a bad edge seal done on the glass. Okay, and then we talk about the poor designs. So there can be cases when the edges of the glass are not capped. It is recommended to do that for PVB. And then we have incompatibility with the sealants. This picture tells you that the sealant is not really compatible. And then overstressing of the bolts. And creep can also come into picture when there is no dead load support to the provided to either of the two glass layers. And then there can be water ponding when there is no provision for the water to get drained out. Then we move on to ensuring the sustainability of the glasses. So we at Kurare take sustainability very seriously. So we have committed that by 2030 we will be reducing our carbon emissions by 30%, and by 2050 we will be going carbon neutral. Yeah. So we are proactively providing the LCAs for our product, like how much carbon footprint we are making when we are manufacturing our different interlayers. So we have 4 manufacturing facilities all over the globe, and we are proud to say that our carbon footprint impact is the minimal in the industry. And then we do a comparison between the different interlayers, like how much carbon footprint we are making with the PVB. It's like around 4.45 kgs for every kg of PVB that we produce. So Century Glass is definitely more environmental friendly because it's 3.92, and we are working on a new generation of PVB which is going to be much more green per se. So its carbon footprint is going to be just 0.187 kgs per kg of PVB produced. Yeah. And then I mentioned earlier that Century Glass is more sustainable. And Century Glass has been used in the industry for a very long time now, almost 20 years. But this is now another key selling point of the interlayer. And we can see here we have a comparison. It is 8+8 glass 1.52 PVB, so which is having a total carbon footprint of 55 kgs of carbon dioxide, versus if you replace the interlayer with 1.52 Century Glass, this will have 41.8. Yeah. So this is a 24% reduction in carbon footprints. Yeah. Then we make a comparison here that if you also choose to, nowadays companies like Saint-Gobain, AGC, of course, NSG and Guardian, so they have also started promoting their low carbon glass. So here, the low carbon glass is depicted in green color, and the normal glass is blue here. So if you change both glass and PVB to be carbon neutral, so there is a considerable saving here from 27.5 kgs of carbon dioxide in the normal case versus 17.5 kgs of carbon dioxide with the green glass and the green PVB. Yeah. Then we talk about buying the original Century Glass. I think this is very important in the context that nowadays some Chinese companies are trying to pitch their product and by claiming that it is SGP or Century Glass, but you should be aware, and this is the right forum to create this kind of awareness, that Kurare is the only company who is the genuine supplier of Century Glass. So, and it's a humble request for the architects and the facade consultants also that they shouldn't refer to the product in their specifications at SGP. It is, the correct name should always be Sentry Glass. And why it is important to that? Because if you choose to go with SGP, there is a high chance that you may get a fake product in your specifications. And why it is fake? So the performance of these products is quite obvious from these two videos. So it just collapses like a standard PVB. Yeah. And this test is done, the video on the left-hand side says the test was done at 20 degrees centigrade. So it just couldn't withstand the impact from the swing back. And Sentry Glass is known to withstand this test even at elevated temperatures of 50 degrees centigrade. So it just collapses at this temperature range. Yeah. So moving to the conclusions. So PVB is not the only interlayer that you have in the market. So you can definitely enhance the functionality of the glass if you choose the right interlayer. Selection of the right interlayer is absolutely important to ensure that you get the highest performance. And structural interlayers like Sentry Glass, as we have seen, and other interlayers, which is Trossifolies, they help in not only down gauging the glass thickness, but also reducing the carbon footprints. Yeah. And last but not the least, Kurare is the sole manufacturer of original Sentry Glass. So please be aware of the knockoffs or similar products available in the market. Yeah. So let's continue the dialogue. I'm available outside my booth and with my colleagues. If you have any questions, please, I'm happy to discuss. That's all from my side. Thank you very much.
Thank you, Malvinder. As usual, delivering a presentation covering all the aspects of lamination from A to Z. It's very informative and very covering the entire technical subject. Next, we have the last presentation before the end of this session, where we have a coffee break, is Avinash from Kinlong is delivering a presentation. Avinash Kinlong is obviously a company, a China-based company that is covering all aspects of facade and window hardware, right from openable window hardware to spiders to LED meshes and many other things. So we'll have Avinash deliver his presentation.
Thanks for that. A very good afternoon to every one of you all. So I'm Avinash. So before I start, I still remember the day when we started. I'm with Kinlong for the past 6 years. I joined as a sales engineer, moved up to a product engineer, worked as a specification manager. Now I'm heading a team as a zonal manager. So before I start, welcome again to World of Facade. So moving on, since the main topic is about facade is what we talk. So before I start about it, I want to tell what is Kinlong about? I was really surprised when I was starting the presentation, even starting the seminar in the beginning, when people come to me like, oh, you guys have this product, but I only knew this particular one. It was not only this seminar, there was past 4 to 5 years whenever we spoke about it, people were surprised and astonished seeing that Kinlong has a variety of products. Since it's a very good platform where we're going to talk about especially facade, let's see what are the best that we have about it. And majorly we're going to talk about integrated solution, relatable to facade, and some unique features of whatever that we can provide over here. So if you start, we are available all over the world with plus 90 countries. So moving on, in Kinlong overseas actually started in the year 2003. So in India, we started at 2013. So we have inclusive growth, especially when it comes to all interiors, door and windows, facade industries, glass related, cabinet, toilet partitions, you keep it keeps on going. And we have, in India alone, we have 5 warehouses, each varying from 10,000 square feet. And we have 300 plus Indian employees. So moving on, in India, all Tier 1 cities will be having every regional office in the state. So currently right now, we are trying to aim to 28 offices all throughout the world, whereas Bangalore serves as a head office. So moving on, the first topic is what we talk about is since Chinese-based company, everyone portrays in a different platform. Like why should we prefer Chinese? You know, every consultants when we meet up, oh, you're Chinese. Okay, we'll see to it. We'll get back to you the earliest. See, there are certain platforms when you want to compare about Chinese brands with Chinese products, with what are the hardwares they procure, how is the manufacturing process in these parameters. Since the name is of Chinese, I don't want to prefer there was a clash between me and a fabricator. He was saying like he was anti-Chinese. Whenever we talk about it, he's like, oh, China, please don't come into office. I said, sir, the phone we are communicating is from China. What do? You're going to throw it away? A simple logic, right? Even though Samsung is making phones, even Apple is manufacturing phones, it's in a place of origin where it is designed and manufactured. In that way also, we have to portray, like, even though it's manufactured in China, what are the parameters? Are we, in strength-wise, are we good? Is the raw materials procured in a good way? So in those ways. So talking about parameters and technical qualification and certification from third party to the in-house, to the authorized party, to the government authorities, we are still liable and we are still applicable with all the parameters. So all the things, in India, we talk about it. Even in CBRE and all the government sectors, we have been approved, where we have certification to supply all the hardware for all the government projects and big infrastructures. And we have our in-house, where we use CNAS, Chinese standards, obviously. And the top priority is of ILAC, where the certification plays a very important major role for that. And the third party. In India, majorly everyone prefers third party. Even then, we are still applicable to apply and we can submit to you before your procurement. So moving on, as I said you, the first topic, when Kinlong said like, you guys do only cables and spider glazings. No one said in a way that we have door and window, top-on, shower partitions, bathroom, clamps, cast-in channel, anchor bolts, screws and fasteners, dynamic facade. It still keeps going. Kinlong, overseas Kinlong has more than 40,000 categories of hardwares, not the products, 40,000 categories of product. In India, I'm only selling around 4,000 to 5,000 products, not categories. Where my brand awareness is majorly into glass, facade, interiors, patch fittings, few cabinet inches, few shower partitions, and railings is my major scope of work where everyone procures, you know. So just want to highlight it. We have more than everything. Not everyone knows this, but our tagline is actually one-stop solution. Apart from aluminum profile, apart from glass, apart from civil structures, I can actually supply everything for infrastructure. So moving on, let's not talk as a consultant or as a fabricator or as a vendor me supplying. Let's assume that we own a building. It's a big mall. What do I think? Like in a way, like, okay, I own this house. How good it has to be. I want this particular window. I want this window to be adjusted to this level. I want the glass to be more than 20 meters. In aesthetic way, when we talk about it, what are the fundamental characters that we prefer? Not on technical parameters, not on like, okay, this is a big mall. Everyone should know that this is the best out of the best. No. Whenever a building shows up, what are the basic needs that we have to start with? One, a tensile element. A tensioning element. This is a primary factor where we use because all the glass, all the dead load has been carried out by an hardware. Either it is of clamp, either it is of spiders, either it is of patch, whatever it is, tensioning element is very important and a key factor for us to propose for an hardware. Next is support structure. Even though whenever we talk about cables, right, once the civil work is done, only the architect and the consultant come to us, please give us a solution. Whereas if I see the building, it's more than 30 meters and the width is span of more than 40 meters. We don't discuss actually in the initial stage of the civil structure whenever it has been introduced. So with all due respect, please, let's work together before the structure actually comes up is one major point. And load distribution. This plays a very vital role. Even though all the cables and all the facade, when we talk about the live load, lateral forces, this has to be evenly distributed when we talk about this. Next is architectural aesthetics. No matter whatever I buy, it has to be appealing. Even though everyone prefers a good phone or a good building, whatever you see, is it like very good? Everyone said, okay, this building is more beautiful than the other one. That is what the name we are trying to seek about. Next is maintain and accessibility. Whenever you're trying to procure, like, okay, the building is done, always think in a future point after 1 or 2 years or even after 10 years, what am I going to do? How am I going to take care of it? Next is material durability. As you know, most of the hardware has been exposed in an exterior. We have to think in the futuristic way, like, how am I going to keep it? Is it going to sustain for a longer time? Can I at least keep it for 10 years? Can I at least keep it for 100 years? In those ways. So let's just go back. What do we actually do whenever we come to facade, you know? Let's talk back like some 5-10 years before. Any building comes up, we talk about basic MS. We talk about cantilever, maximum 4.2 meters. Okay, let's go to suspended, maximum I can go is 12 meter. And the other thing is basic ACP. After a few years ago, it'll just change the shapes and colors. Next is the basic curtain wall. You know, this is kind of very older way, where in a traditional way, like people have been followed. And this is the right moment for us to step it up in the next upcoming years. For the next 10 years, infrastructure in southern region has to be growing very rapidly. So I want to talk about what I have today. I have almost around 6 to 7 products, which is very appealing, very aesthetic wise, and very which can improve all our industry building. So first is, let's talk about facade mesh. As you can see this image, right? This acts as a suck-in skin. So once either it is of glass, either it is of concrete, there'll be a suck-in skin appeal. Either this will be of SS, perforated sheets, or ACP. And there is no certain limitation of height, width, of what density, what thickness, nothing. There's no lateral force happening. There's only dead load passing through it. This particular piece of sample has been available in our stall. If you want, just go and have a touch and feel on it. Next, this is sunshade louvers. This particular one is actually a Kia headquarters in Korea. So we have done this actually almost, I would say, approx a year. We worked, a lot of R&D has been done. Everything, whatever you see, is completely made non-standard. Nothing in particular what we have is a standard product. So this one you can see, the main purpose of this is the end client wanted complete transparency, where they can have a very good wind as well as a very good sunshade towards them. So this is fixed actually. Few sunshade louvers actually can be automated also. This is kind of either vertically or horizontally or any lateral areas wherever you want it. Moving on, this is a designed ACP panel. See, in India, we would see a lot of ACP panel suppliers, okay? Comparing to them, we are quite different. Not because of the material what I have. It's because we give you as a complete package. You as a fabricator, me as a vendor, I don't supply you as just the panel. I give you whatever shapes and sizes that you wanted. Your work is to just go mount on the floor. That's it. So in these ways, not only this, even in perforated sheets, we design as per as an intent. Any shape, any sizes, they start from 3 mm and aluminum composition start from 5053 grades. And next, this is one of the most, everyone keeps talking. For the past 6 to 7 months when we approach this, in North market, this has been moving very good. Everyone's, the buildings have been taken up. Now Southern market in Chennai, we're working with Chennai Trade Center. That's around some 1,500 square meter. It's almost going to get executed. We are going to place the order very shortly or soon. This particular is called as Next Nova. We supply this in this category. These are applicable for facade, for manual sliding door, for automated sliding door, for glass railings, everything you name it, within the glass, we provide it. So let me show you the video of it, how it looks actually. This is the testing what we were in Shanghai when we were discussing in particular, where we can approach in a different parameters to India. Even though when you talk about LED, even this particular one is LED, but how it is competitive in Indian market when we talk about it. See, you know how difficult this is to assemble, you know how big and heavy it is. Whatever we have is quite very different. It's very easy to fix, very easy to dismantle. You can access, you don't need laptop or any configuration data to input and add on everything. You just need a basic phone and application where you can add on all the data, just send it, it'll automatically start playing it. This is one of a project where we are done in Beijing. This is around 2,800 square meter. So this has come out very good. This particular one is around 7,500 nits. The display frequency actually is more appealing during at night time. So moving on, even this particular one is available in display. You can have a touch and feel, and we'll discuss in detail about this. Moving on, this is one of the most important, and everyone, all the architects when I approach, I'm very much interested in this. We call them as dynamic facade. See, this particular one, I think the video is playing. Yes. Whenever the wind blows, it creates a wavy motion. Either it is of vertical, of horizontal, any variance, any shapes and sizes. Even the ACP panel, the main material would be of 304, 316. Everyone prefers 316. Even ACP can be adjusted to it. Any color, electroplating, even if it's of other grade, we can get it anodizing and get it done for you. And this particular one has no limitation. Either if it's of a big facade, even if external, only dead load plays a very vital role here. No forces acting on them. So moving on, cable, one of a very main cup of cake that we do within Kinlong is our cable system. I think everyone is familiar what Kinlong does. Facade is our main business of scope, what we do in India. I mean, overseas as well. So we have a patent production. I think I can proudly tell all over the globe, Kinlong is the only company where maximum cable rod we can go with is 220 mm, and maximum cable that we can go is 160 mm. And we have a workspace around 40,000 square meters where we have a dedicated workshop where we used to do, we manufacture the cables, we pre-tension it, again enclose it, again pre-tension it to the forces that we wanted. So adding to this one point, we have one more cable. This is one of a project that we have done in Beijing. This is a very, almost some 450 meters curvature bridge. So we used a smart cable. What is the smart cable? See, every cables that we propose and we have been installed, right? There is always a reaction process acting on horizontal as well as vertical. So every time whenever I want to service, if I've installed a cable system or a cable net system in any building, right? After 1 or 2 years, I have to service. After that, the 5th year, then 10th year, then the 20th year. So where this as a smart cable, right? I don't have any labors. I don't have to afford any scaffolding. I don't have to ask people like, I need a manpower to get it done. You have to shut down your mall or your infrastructure. This gives you a cloud data where you can access and know what is the reaction forces happening on day to day, every day. So this will be transferred and you can know whenever the reaction forces are going low, service team can go up and again pre-tension it. It doesn't require all the time. First 1 or 2 years once, after 5, 10, 20 is how we feel. So moving on, how, whenever me as a sales guy, when I was talking, whenever spider inquiry comes, I feel so boring, like I have to supply spiders. Whenever any spider inquiry comes, right, we try our best to propose to a consultant, like, why spiders? Can't we do cable? Can't we do some other things like similar to VS1 system or any vertical post without any horizontal mullions happening around? So Keylong has taken a very good initiative where we are going to come up. This is already launched in other seas. In India, still not yet launched. We're going to come across under 4 categories. One is process steel, aluminum profile, aluminum cladded sheet profiles, and ordinary where MS has been collided. As you can see at the bottom over there also, this is the exclusion what we have done exclusively. And there is no limitation for these kind of category also. Same as VS1 or a vertical post, what you're trying to do, where your work of scope will be like only supplying glass, where we'll be giving everything all together. So this is one of a project what we've done in Philippines and Israel. So these are the executed profiles that what we have been using around. And moreover, we don't have any standard product for these kind of system. Once you give the loads and structure, what kind of system it is, we give you a proposal of what can be done. So moving on, this is one more category of GTI smart windows. See, these are very good and smart innovative products where they have smoke detectors. Fire, whenever there's fire, automatically they open. And even for the places where we cannot go access over there, it can be easily done. Either it was of glass, either it was of aluminum profile, or even lower doors, it can be automated and with a single touch of button. So one of the most very commonly product, since this has been very good progress to us for the past 3 years, Topang hardware and openable and a parallel window hardwares. See, for the past 2 to 3 years, all the consultants has been approving us because they've been proving that our quality of a product and the forces, especially Typhoon system is what you're trying to propose. It has come out very good. Whereas comparing with the other competitors, we have more than we have 30 inches friction stay where it can last till 200 kg capacity for that openable hardwares, and the parallel window of 42 inches which can take the load of at least 160. Few places where the panels of more than 3.2 meter, we kindly make it as a non-standard, providing you a proper solution on it. So next, cast-in channel, one of our facade hardwares. Yes, it's quite different when you talk about only Keylong as spiders and clamps. We even have all these structural hardwares as well, and we have been certified with the ETA for all the welded and reverted cast-in channels. Okay, 2 minutes. And we have 3D brackets and 2D brackets adjustables, and we have ETA approval for all the chemical anchors, wedge anchors, and mechanical anchors. And we have stone cladding, either it is of granite of 19 mm or even if it's of clay of 19 to 30 mm, we still have solution. We have undercut bolts where we can propose to all our fabricators and installation process. And society, I'll just finish it up. Keylong doesn't only aim to make revenue out of any that whatever we do, okay, we always try our best to give back. As always, our Keylong president, Mr. Bai, always said, whatever we make profit of it, let's give it out to people. So I can still proudly tell that in India alone, we have opened free schools. We have opened around 4 schools till now. Our aim for this year, particularly like 10 free schools for all the uneducated people in Tier 2 cities. So thank you once again.
Thank you, Aditya. Ladies and gentlemen, it's time for a coffee break. We'll be back again over here in 20 minutes. You can all go out and have your coffee break. Start our last session of the day. It's been a great day today and with amazing turnout, and I think everybody's ready for the last session. We have Akshara Verma, who's from ACE and is going to deliver a presentation on the transformation of facades in educational architecture, is what I understand. Akshara.
Thank you very much. This is the first time I'm ever on a mic which doesn't have a stick, so I'm a bit nervous. But yes, I'm Akshara. I'm a partner at ACE Group. For those of you who don't know, ACE is been a legacy company. It's founded in Bangalore in 1984. Founded by 3 partners, an architect, a consultant, and an engineer, ACE. The CNE retired a couple of years ago. The architects, of course, never retire. And so we're now here and kind of have built a name predominantly for designing spaces for education of all kinds, across scales, across budgets, across land parcels, across syllabi, and predominantly in India at the moment, hopefully. And today we're here really to talk about breaking the mold. We see that the education segment is something that's really going to kind of disrupt in many ways, more than one. And we feel like facade fenestration is going to really play a massive part in it. To start off, thought we'd just speak a little bit about a personal kind of transformative tale in education. And I'm not the only one here. I met a fellow alumni of TU Delft in the Netherlands. And I think this was the first time that I really felt like an educated space transformed me in many ways. What you're looking at is the School of Architecture. It's a 1920s building that was repurposed to be an architecture school. You can see, of course, the repurposing. There's a large kind of, where do we see that? All right, spotlight here. So there's a lot of kind of plug-ins that we see, which is also an interesting kind of dialogue between facades of old and new. Many of you might know this building from this iconic photograph. It's, again, an interesting kind of tale of an old 1920s building and a sort of 2012 glass facade that kind of interconnect at that point. But what I wanted to actually talk about today was, here we have TU Delft. We have a 1920 building. This is a 2013 photograph of it. And the 2023 sort of latest inclusion in the Delft University is that building. It's almost a non-facade in that sense. It's completely transparent. And of course, the idea of the facade, what you maybe don't see are very, very slim cables. And what you will eventually see is this kind of facade growing over time when it really kind of grows over itself. Interestingly, it's also a building that produces more energy than it consumes. And it's also finally a building that doesn't say architecture or one kind of faculty, but it's a space for all kinds of learning. Closer home, I thought this is also an interesting kind of comparison of old and new. This is the Nalanda University, 3rd to 6th century BC, prolific in its time. And that's Vastu Shilp's kind of resurrection in some sense, I would say, of Nalanda University again. So 2023, and you're sort of seeing this kind of stark comparison and almost evocative image of facade in these two images. But what I want to really kind of get your attention to is what education and facade and architecture is really about. Ben van Berkel, the UN studio, is the architects who did the latest building at TU Delft. They really talk about flexibility and kind of the idea of education moving towards something more generalist and more non-specific. And there's everything that B.V. Doshi has ever said, is kind of spills wisdom. And here too, he says it as simply as ever. He says real education comes from real life, and there will be no barriers in this particular university. But life in itself and that kind of evolution is something that we're going to constantly see in the way education architecture also evolves. And with that kind of larger belief, we could maybe kind of start today. This is an illustration by George Bates. I'm very fond of his work. And it's a sort of typology and typographic and graphic illustration of what, all the factors that kind of influence education today. All of it is kind of pointing back to that larger idea of society. So where do we start? So we can maybe roll back to 19th century. Here's a one-room schoolhouse. It's very, very typical of what schooling was at that time. It was one house, one room in the middle of a large field. And surprisingly, a lot of things about school today is still kind of dating back to this idea of agrarian agrarian evolution. Summer holidays was because kids needed a break because that's when they were kind of working also on the fields. And I'm glad schools still have it. I think we should also have it in offices sometimes. But from this idea of this one-room schoolhouse, various age groups, all children in one place with one teacher, there's also this idea then of this house, right? And I'm not sure if some of you all in Bangalore might be familiar with this. It still exists. It's off of Church Street. And this was the first school that I went to. It was a primary school, one room, all of us there, noisy kids, I suppose. It's also kind of going back to the idea of what school drawings really are, right? This whole idea of this one house. And so the facade of a school kind of grew from this idea of one room and one room alone. And it was this kind of facade as an expression of the one-room house that we have recently kind of tried to explore in this particular project. It's in India, but the facade here is really not the face, but if I open the drawing, it moves beyond the face and it really talks about the roof and how the roof becomes the facade of these kind of multiple layers of play where children are going to kind of gather in different ways. They're going to interact with the landscape and they also begin to interact with this sloped roof that you kind of see all the way across. And that becomes the facade. So the facade actually here gives us a chance to really explore something graphically. It also, of course, is this idea of a shelter. This is a picture taken from a while ago from an apartment across the project. It's still under construction, of course. And what you do see, though, is this idea of a facade not just kind of being a canvas, but also shelter, but also kind of encourages something to kind of play. I also thought it was kind of interesting to talk about today because the image that we kind of drew in the office and then have represented with various artists on this image is also kind of agrarian in a way. With that idea of play, just one quick example, it's Chinese. I feel like I had to mention that after the previous presentation. But this particular project is also so interesting because the facade is really about play. And I think with education, and especially primary education, there is so much that we can kind of do to really look at the idea of imagination, the idea of discovery, the idea of adventure, the idea of risk even, to actually come up and express itself in the form of architecture. Metal used as a slide as opposed to any kind of conventional structure or facade is, it gives you kind of phenomenal potential in the way that we could kind of look at it going forward. So what is facade, what is playscape is really quite interesting in the way that this particular project has been done. This is in Beijing by WAA Architects. If you kind of step up a little bit, move beyond agrarian to the idea of industrialization, I just maybe would read that little note here. And it says, with the industrial era, this is in the 20th century, more people moved into cities, school buildings started to get denser. So they started to kind of grow, or the idea of growth and compaction became extremely important. And this kind of phenomenon is really not very different from where we are today. At the office, we've been working on education like institutions right from the late 80s. And we would, going back to the archives, you see international schools spread across 60 acres. And today we do international schools on 2.5 acres of land, but it's still kind of pumped with the same amount of infrastructure. Not really the same amount, but it still tries to kind of be as packed as possible. So here we are with this new kind of idea of facade evolution and a facade that evolves from the idea of arithmetic. This particular project is one that we had done in Sarjapur, in Bangalore again. The idea of arithmetic is almost kind of simply seen in this facade. It's because there was a very clear brief. These are the number of students. They will be in these many sections across these many grades. So we're automatically starting that kind of arithmetic. So you can see here that the idea behind this was that every floor really, they have 4 grades and they come together in some sort of a common area or a court within their space. And what you really see here is that kind of simple idea of facade arithmetic that you see kind of going up and of course stretching across the kind of sprawling campus that it is. Today, and this I think was a project that is now about 10 years old. today we see that the math is getting a bit more complex. Nobody comes to us with a clear idea of how many classrooms there will be. It's just as many as we can. Right? So as many as we can, because the nature of demand of certain kind of education facilities are such. And there seems to be this kind of magic number of 160,000 square feet, which we kind of constantly see in the way that we even approach architecture today. So this is, you can see that the idea of building facade in architecture is kind of also expanded. This is a dense vertical school, still kind of trying to get as many voids and as many open spaces as possible, so that we can kind of begin to express ourselves within the building, but also while positively being outside. So the idea of density here becomes quite interesting, while constantly looking at the idea of numbers and crunching numbers, because that's really ultimately it seems to be a sort of economic deal behind everything. This is a photograph actually from yesterday. We're all looking very puzzled. We need to finish the school in the next 3 months. Classes start in June. And that's another kind of idea of economics, right? It needs to be that quick. So all of these also begin to kind of dictate the way that we think of school facade buildings. But having said that, I wanted to just kind of pan beyond to look at this is a particular project that I think won the World Architecture Festival event earlier this year. And it was like a school. And I think what is kind of phenomenon about this particular project, it's in Ningbo, China again, is that they've managed to kind of break the idea of this mathematics, at least on one part of the building. So if you see, there is this idea of play, there is this idea of interconnectivity, there's this idea of facade within a void, which is very, very interesting. And it kind of begins to be a beautiful contrast with the other sort of gridded side of it, where, you see the repetitive modules, you see the kind of idea of the classrooms building up. The other really interesting thing that I think will be a major disruption going ahead in education spaces in India is this need for growth. This is a very, very typical scene that you will see while you drive, especially if you're used to driving in rural India, and even in urban India, actually. But the idea of the need to expand. We constantly design our buildings. They're 5 floors today, but the structure is designed for 2 additional floors later, right? So this idea of facade will also kind of continuously grow. Here, of course, you see the top story of that building kind of unplastered. They're probably just occupying it already. But this need for growth and this need for adaptability is a massive factor in educational spaces. So here's one. This is a picture from the 90s. It's kind of blurry on the scale, but this is National Junior School. This is a picture from the inauguration, very similar to the photograph that we saw on the previous slide. Only the ground floor is plastered, but it's inaugurated anyway. And here it is, the first floor still under construction. Soon, of course, it will grow, it will fill up. That's in 1990. 10 years later, this is exactly the same school. I just black and whited it for some nostalgia. But the idea here is that this building is grown. It's grown, the school's grown. You see that the auditorium was probably added much later. And this project now sits on our table again, because we're looking at this complete idea of revamping this particular project. The windows that we see are much smaller due to the kind of technology at that time. Today, we're talking about opening facades up from column to column, really re-looking at the idea of dynamism, making the school feel more contemporary, also kind of giving it the kind of aspiration that people want to kind of hold on to today. And it's an aspiration, I think, more of parents sometimes than children themselves. But this is the kind of, potential that we see a large amount of projects that are, that have been built really kind of begin to fit now in this retrofit model, where we need to kind of really put on our thinking caps to see how we can, with the footprints that we have, work on kind of redeveloping them into making them more relevant for times today. I wanted to just go back to that idea of the same 20th century school. And also talk about this idea of association and facade. So the associative facade is the next kind of segment. And I've blown that picture up so everybody can see it nice and clear. It's an image from of a school in London. And that in the little thumbnail there is a Google snapshot of the Harrow School. If for those of you who frequent the airport, you see massive hoardings of the Harrow International School coming up, and it's strikingly similar. It's actually done by C.P. Kukreja. But the idea that I wanted to kind of drive here is that there is a notion of the image of a school building, and that notion of the image of the school building comes from a facade, and that facade is something that kind of sticks to us still. And how do we maybe make that a little bit more relevant? The idea of kind of robustness, the idea of strength, the idea of a structure that's imposing is something that has been a kind of brief for many schools that we do. This is an image from 2001. It's Indus International School. They now have, of course, campuses across the country. From that in Bangalore to this, which was done in 2019 amidst the pandemic, this is in Belgaum. But the idea of that imposing sort of structure, almost colonial, actually, a kind of reflection of that, is something that we still see in a lot of the work that we do. Here, of course, we contextualize the idea of stone to laterite, given the conditions that we had. But in that kind of associative facade as well, I think the real crux of how we develop the facade is to look at that idea of material, hold on to that idea of material, and see how we can kind of explore that material in every possible way. So this is an image of the facade at Reva University, but trying to just kind of illustrate here that the idea of stone was used right from kind of elements in the facade to the cladding itself, to even the way that these elements are sort of exposed within plaster as kind of freestanding columns at the end. So the idea here will always be about the exploration with material. With the same three materials, so we're talking about stone, glass, and mortar, and plaster. We had that impression, let me go back, the impression of a university standing with kind of stoicness. And here in this particular project, it's on our drawing board again, is the same three materials, but used in a very different context. And this is in Jaipur. It's coming up in Jaipur, and the idea here is kind of to really be clever about the use of glass, considering the kind of climate that we're in, and also to kind of break that with as much kind of solid facades as we can, looking at the idea of climate and temperatures extremely kind of carefully, and then sort of still using the idea of contemporary modernness to kind of give the image of something being very contemporary and new. I'm just kind of moving into projects that are sort of larger in scale, and projects that I think are currently very exciting for us. This particular project, again, it's for a university here in Bangalore, and I'm just going to bring your attention to this big fish that you see very close to this water. So this is possibly one of our largest projects, at least at the moment, where we're looking at a span of 2 basketball courts and a gallery that fits about 1,500 people. So at a time, we will be looking at the population of people in this fish alone to be almost about 3,000 people. So this becomes a large gym and auditorium facility. So it's a gymnatorium. And so there was this idea of how can we make that as dynamic as possible in terms of a facade. I've only sort of had one image of it here, but the idea here has been to use segmented fins, lightweight as possible, to kind of wrap around the entire facade in a way that as you move across the building, the static facade itself begins to become dynamic. So this is also just our kind of idea of how do we use or build a kinetic facade, but in the most kind of static way, given the kind of constraints, again, that we had on timelines and budgets. Another one, just to kind of sort of open up everyone's minds here to the way that architecture and the idea of education is also transforming. Another big master plan project at our desk. But the idea here is really evolving from what a campus should be like itself. So here we are kind of exploring the idea of living and studying, but within the same building. So conventionally, what we'd always do is in the master plan, you have the learning zone, and then you have the residential zone, and then it would be further bifurcated. So you have the men and the women. So here we are kind of looking at a new typology where we say, hey, can we study in the first 30 meters of our building, and can we just live above it? So it kind of really relooks at this idea of density within an urban educational campus. So we have a podium. The purple blocks that you see here are all largely scholastic. And then we have the blue towers of residences kind of sitting on the top. And that really kind of opens up massive amounts of potential that we can rethink the idea of what facade and conventional idea of, the educational facade can really be, move away from this idea of sort of cookie cutter windows, brick and mortar, into something that's really more unique and really more kind of 21st century. So with that, just leaving you with two big questions. What will our education environments be like even 10 years, even 20 years, even 30 years from now? There is this kind of constant need to learn. The way we learn is diversely changing, right from virtual environments to night schools to all kinds of things. So I think the format of the way we learn itself is a big kind of trigger to the way that we will also sort of build and imagine education spaces in the future. But having said that, and I think I'm an eternal optimist, it is the most fascinating time to be. And there is this kind of constant need for us to reinvent ourselves. I think there are people in power, the ones who kind of fund such projects. And of course, everyone here in this audience who really has the creative minds behind it to make kind of the kind of big change happen in a sector as important as education. So that's it from me, and here's to the future. Thank you.
Very fascinating presentation, and your passion for the subject, the passion for educational buildings, could really be felt with the manner in which you spoke and you delivered the presentation. Thank you so much. Right, we're approaching the last session of the last panel discussion of the day, and we have Mr. Shyam Raghunandan, Managing Director of our presenting sponsor Shuko, who is going to moderate this session. And I'll allow him to come up over here with a very interesting panel consisting of architects, consisting of PMCs, owners, and investors. Shyam, if you can introduce the panel, that'd be wonderful. Over to you, Shyam.
Thanks. Everybody can hear me? So just a warning. We had a pre-panel meeting outside. So the doors are now closed, and we will be recreating the scenes from Mirzapur season 1 until everybody signs a digitalization contract. So this is just FYI. So that's the agreement we made. But I have the great honor to introduce a very distinguished panel. Architect Vishnu Mohan. I'll just go in the sequence in which it is mentioned. From Architecture Dialogue, he will be joining us. Followed by the Director of Design and Projects from ADM, Sandeep Rajendran. Let me just get my glasses. Somebody told me, Zakir Bhai told me, Shyam, you have crossed 45, it's time, right? So, Rajat Bhattacharjee, Director from Turner and Townsend. Nitin Bansal, Assistant Vice President from Brookfield Properties. And Rudresh KV, Vice President at Maya Estates. This topic, we keep it at the end of the session, but I am of the firm belief that, our industry has a lot of inefficiency, a lot of potential. Projects typically take 3 months to finish, but the projects we do run for 30 to 50 years. Now, the question is, how do we unlock this efficiency? How do we gain productivity and make the building successful? So we have, I think, investors, cost and project perspectives, architects. So I'm sure we'll have a great discussion. We look forward to this. So to start with, what I'd like to do is just ask the panelists, what they mean by digitization. Maybe we go in sequence just to warm it up, because that's a big word. Just a free-flowing, couple of minutes. What does that mean for you from your perspective? Anybody want to start? The mics are in front of you, so maybe we can start. Vishnu, yeah.
Okay, everybody is alert.
don't know, doors are locked or not. Okay, digitization means for me is everything stored in binary bits, whether it's our mobile phone, laptop, even in our brain also it gets stored like that. Whatever is getting stored outside our brain in the form of binary is digitization. There are various medias and instruments available to store it now. And as human beings, we are already evolved to do digitization on personal front. Its only challenge is when it comes to official one. Who's fitting the bill is the question. I'd like to be slightly more specific to the building industry, and I think I'll just keep it simple. I think from my perspective, whatever information the building has or an asset has, if it is held in a digital format at one place and be made available and accessible to all the stakeholders, that to me will be a true digitization of a certain project. And when I mean this should be right from the inception to the entire life cycle of a project, not just at the moment. We look at digitization very specifically to a certain task or certain time frame. I think if the entire history or the entire life cycle of a certain thing gets captured in a certain form, I think to me that will lead to a true digitization.
Yeah, so good evening everyone. I would first like to thank Zak and the eminent panelists here. Sorry about that. So when you say digitization, my personal journey with building information modeling sort of began almost more than 15 years ago. And I can say that at least as an architect and part of the architecture industry, that it has really transformed or rather revolutionized the way architects or architecture industry and construction industry is sort of working. And there are various advantages or key things that come with the technology called BIM or building information modeling. And as the panel discussion goes forward, I'll be talking about two key factors which I feel are the most essential or the most fundamental thing that has really affected our industry. And that would be, one is timely completion of projects, and secondly would be the quality assurance that comes with the technology. So,
anybody else?
Hi, hello, good afternoon, everyone. Thanks, Shyam. Digitization for me is much about how or what is the acceptance of digitization that an individual is ready to take over and then take it forward for the next generation especially in the year of 2024, we should be very well aware of what things are happening in the world of BIM and artificial intelligence also. So yeah, it's much more about acceptance and moving forward.
So I think did everybody, I think you had the...
Is it okay now? Okay. Yeah. So digitalization from our perspective is to kind of do more with less. That is what we should look at. Whereas the moment it is digitalized and things are available for everybody to collaborate and work, it becomes much easier for the group of people or group of stakeholders to deliver the project to come together and then deliver it in a much faster, quicker and efficient way.
Cool. I think so. From the first round, I think there were a couple of key takeaways. You mentioned mindset. I think maybe a lot of digitization is about mindset. We are personally digital, but at work, the Indian industry is a difficult beast to handle. And you mentioned productivity is a key output. Do more with less. You mentioned, I think, the concept of the building is an asset over the lifetime, and how do you get information not just across stakeholders but across time.
right? And then from the architectural perspective, how do you get quality into the game and timelines? And how do you get the latest technologies in? So I think, as you can see, there's a whole spectrum of activities. So we've decided there's 38 minutes, but we'll take the next 2 hours and dive into this topic much more. Dinner, Zakir Bhai is providing dinner for all of us for free. No problem. Yeah? So it's all digital. So I think jumping into the topic now to gain the benefit, let's start with the investor's perspective. From the operations, installation, maintenance of a building, what are the challenges you see by not being digital? What is getting in the way? And what do you think from that perspective, that lens, operations and maintenance, what can be gained by going digital? So I'd ask the investor side to maybe shed some light and then add-ons from the other stakeholders.
So it's not really, so my point of view is from an architect who works in a firm who is in the business of development, acquisition, and operating assets. So I think, as I said earlier, that at the moment the BIM industry is mainly focused or geared towards a new build and new construction. Most of the consultants, most of the vendors or the technology is just focused on even the things which are coming out is okay, that you will get a timely completion, you will get good quality, but that's just focus on not even the 10% of the lifetime of a building, which is the initial 3 to 5 years of the building construction. There's a whole new, the whole 50 years of the lifetime of a building, and you need to do interventions across the lifetime of a building. For example, if you see, if you want to go and acquire an asset, right? What is the best possible way of accessing the information of that particular asset? If let us say there is a model, there's a BIM model which contains all the information. So if there's a BIM model, let us say, which holds the entire, like digitally holds the entire information, which is required for an assessment of a certain kind of building, it becomes much more easier, efficient for somebody like us, or even for a developer to market his or her building to a prospective client or a prospective investor. Right? Similarly, when you go down the line, let's say the building, so let's say it is an old building, legacy building of 15 years, 20 years old. Very less amount of data is available of how that building was built, what changes that building has gone through in its entire life cycle over the last 15, 20 years, on what it takes or what it will take for a building to become robust, or how that building will be upgraded so that the building can last for another 15, 20 years. So at the moment, we see there's a gap that very few people in the industry are actually trying to address the existing building lot. Most of the industry is geared towards addressing the new build. And there is a lot of potential, and even if you look at, so I'm talking from the perspective of large commercial real estate office buildings, which are mainly, which have decent budgets in terms of how they're maintained. So if there is a simple model through which this entire information is captured, and then that information keeps on getting updated every now and then, whatever intervention is being made, I think that will be a complete different use, or that will be a perpetual use of
the data.
That idea, yeah.
Great. What about your views?
I'll engage with the audience. Please raise your hands. Whoever thinks a building is a living element. It's a living element. Raise your hands. I would say it's only 40%. The truth is that a building is a living element because it requires many energies to be bought in every day for you to live. If electricity doesn't come to your house, how will you live? If water stops coming to your house, how will you live? And everything which comes into the building and make it live, like whether the lift is operating, DG is working, all of them are electromechanical equipment which has to work every day. Now these electromechanical elements have life. They will end at a particular year. Pumps will last 5-6 years, you have to change Reji after 12 years. Chillers you have to replace, AHU pumps motors you have to replace. Everything has a life. If you don't take care of that life, your building will come to an halt. Isn't it? So how do you take care of it? You have to maintain it. To maintain it, you have to have data. Till now, we used to maintain data on paper, but paper used to get disappeared because over 10 years, that paper changes hand, and 12th year, you want to know what needs to be changed as OPEX and CAPEX, you don't have the data. So going forward, it's very eminent that all the information about the building, to keep it alive, you need to have the data of things which make it alive. And it should be accurate. It should be able to remind you when you have to change it. Fortunately, that technology is available. It's just that we are slow in adopting it. Again, coming back to the same thing, who's going to fit the bill? Residential projects, I think those who have occupied it, they should fit the bill. Is it right? Do you agree or no? Because end of the day, if they want to make their apartment appreciable, well-maintained, accident-free, everything comes, the association has to take action. So they have to fit the bill, make everything digitized, keep it ready, available, make the maintenance team can see it, even over mobile phone. Same thing happens to commercial building also. So, in simple words, my last sentence, first 10 years of the building will give the return back on investment. Next 40 years will give the profit. How much profit or how much loss depends on how you maintain it. I've seen buildings which have deteriorated very fast. They did not appreciate value-wise. It brought negative to the occupiers. And I've seen buildings which are amazingly well maintained, and they have exponentially the price and value of that property and asset has grown substantially. Do you agree?
Extremely important aspect, and I think from the industry's perspective, you can hear me, yeah. From the industry's perspective, I think what you're pointing to is a great service offering, a service opportunity where if we can provide that data, maintain that data about the assets of the building, whether it be HVAC system, electrical systems, even a facade system, windows, whatever, if that data is available, the value of the building can be assessed, sold properly, or even the profits can come back. And that home perspective is rather unique because if I want to sell my house, if I have great data, I can value it correctly. So I think that's the opportunity that you're pointing to if the data of a building is maintained well. Any of the other panelists would like to add on this topic perspectives?
Yeah, so and this is quite, so as an architect, we always think of a BIM model or a BIM process starting from concept, schematic design and documentation, construction, and up to the point of as-built drawings. So this perspective that operations and maintenance, so how that data can also be linked to the same model is quite new, and it's quite interesting, and we should all be thinking of that. So yeah, exactly. Right. So that part is definitely valid.
And you wanted to?
Yeah. So I think most of us spoke the same thing, and I'll agree to that. A building is a lively element, and we need to keep pumping the blood in different ways to make sure that it runs. And unless and until we have the data available of the building, there is no way that you can do. We have seen the building retrofit being done, and that is when everybody start running from one kind of, I would say, pillar to post to just to understand that where the data is, what it is. And another day you end up spending much more amount than what it would have taken to digitalize the data. So going forward, I think it's only going to be more important to have those data digitalized, and
I would say it has to be a top-down approach where the investors, like Nitin and Ritesh that we have, they have to impose it as a must-to-have, so that everybody gets kind of what falls in the.
And if I heard correctly, I think you raised a valid point. You're saying who should be responsible for that data? Clearly the investor, because they are the ones getting the return. So if I'm hearing you correctly, whether it's Brookfield or Maya or the homeowner, they should be the ones responsible to maintain it.
See, one maintenance of data is not a problem. The problem is for most of the stock, the data is not available, right? So to the point, so when the project gets finished and you say that it's as-built drawings, so in most cases we're seeing those as-built drawings are just a formality to submit to the authorities for a OC purpose. Nobody has actually, very few people will actually go and calibrate the BIM model to actually what has been actually built. The reason is how the engineering is being done in the country and what the engineering is being done to what the vendors are making on the site is, there is significant gap there. Because our engineering is not to a point where we go and work till the end of shop drawings. The shop drawings, so engineering teams give the scheme or give a design, and eventually the execution happens through shop drawings, which are based out, which are being made by the vendor. Very few vendors have the capability actually to do shop drawings in 3D BIM format. And let us say if there are 100 trades in which are responsible for a building, I think less than half of them will actually have the capability or even want to take up that job, that they will use the actual BIM model and plug in the shop drawings. So I think first and foremost, the exercise of calibration of the final as-built BIM model should be done with the actual building. Because that's where then the real part of maintenance will start, like maintaining of that model will start. And then and everybody who has used BIM would agree it's at the moment is quite resource intensive. So you can maintain that resource intensity while the project is under construction or just finishing. You can put in that money. But how do you ensure that during the life cycle of, let's say, next 40, 50 years, how do you ensure that you can continue to have that same intensity where the data gets built in that model? Even you do any small change on large projects on a daily basis, you will keep on upgrading, you will keep on changing pipes, you will keep on changing wires. So I think there needs to be a service. As you said, it needs to become almost like a service, like a property management service. Of course, at the end of the day, the bill is not being footed by anyone. The bill actually is being footed by the end user. So it will be built to the common area maintenance. Like he said that, like in the case of an apartment, the bill will be paid by the residents either through a maintenance. Similarly, the bill will actually be fitted by the end users. They will just not know how it is being, right? But the first point is the availability of the accurate data, and the second point is how do you maintain it?
While we were outside, we had this great discussion, at the architectural level, everybody understands BIM digitization, but the big challenge is getting to BIM 300 is okay. After that, it's a big black hole, right? So what is stopping the industry from taking, what the architects do and taking that 300 to 350 to 400 to 500? What needs to change from, starting from the source?
Okay, so I think that is a hesitation which is happening because of the fact that people are being comfortable, too much comfortable the way they have been practicing for years. And they are a little bit skeptical to move and try out new things, implement new practices. Maybe you might have to sit down and understand the real numbers, what is required for that. At the end of the day, you should ensure that right numbers are flowing through an investor. And maybe you will have to strategize with, specialized hiring is required with respect to the new technology. You might even have to, don't be surprised if at all to cater to the new needs. You might even have to hire a data analyst or machine language coder, because that involves a little bit technical stuff, and people who need to understand, people who are capable to understand and process that are required for this sort of a change to happen. So you can't just avoid that fact. You might even have to sit along with, first you should put a trust in the younger generation who are able to manipulate or maneuver that technology, and sit with them. It cannot be always like a veteran mentoring or feeding a junior, or because they have immense potential with respect to today's technology, right? So it can be a two-way mentorship sort of a thing which needs to be taken up, I feel. That we should try to bridge that gap, what is happening, and I'm sure that outcomes are going to be much beautiful.
So once the level 300, sorry, you were saying?
I would like to add to him. I'm sure those who are my peers in the industry, how many of you learned AutoCAD on your own? Raise your hands. Quite a substantial number. We all learned AutoCAD on our own without even getting training. We just sat in front of computers, saw somebody operating, how the command worked, etc. because it was the need of the hour for us to upskill ourselves. We need to create an ecosystem by providing a desktop, a single license. Maybe take the lowest cost BIM model. Don't buy the expensive one. Keep it in your office. Make your 2D fellows try that one. Let him boast that I also learnt it. There is, in today's world, you don't need somebody to come and teach you. There is enough YouTube videos, enough online training videos are available. Those who are interested will do it. Yes, you will spend some 50,000-60,000 rupees in putting that application, but you are enabling your team to become multitask, which will enable you to go and tell in the market, yes, my team can work in BIM. That the gap is there. It's a small investment. Everyone has to gear up. Pretty soon, I am very sure. I've been working across the world. It's only in India we don't do it in BIM. Rest of the world has already moved. They don't do it anymore in 2Ds. In fact, we are in backward state. So entire ecosystem, just how we jumped into AutoCAD 2D, where we learned, same thing is to be enabled now to move into 3D. Otherwise, we will be left behind. Or we will stay where we are.
To add to a point there, see, there is definitely challenges when it comes to BIM. There is a challenge of cost. There is a challenge of resources, a challenge of knowledge base and all that thing. And you're asking why up to LOD 300 we do very well in BIM, and then the vendors are not able to catch up to that, and they just prefer doing AutoCAD or 2D drawings. So there is one factor that also adds up there is, see, I spoke about timely completion of projects. So that aspect is mostly to do with, you can do construction faster at site, provided that the pre-construction stages of design documentation, you have spent enough effort and time on that. So that one thing usually gets overlooked or misread by the clients and the industry in general, thinking that BIM means everything is fast. But there is a challenge there also. So with respect to that, that's when even the vendors take a call that, okay, no, I can do the AutoCAD faster. So I just do that off. BIM would take me more time to do those final level of detailing. So that challenge is there. And on an earlier panel, I heard an interesting phrase which I want to just repeat here, which is very relevant to this, that, the more you sweat in peacetime, the less you bleed in war. So you should take that attitude and try to get more effort done during your design documentation, initial stages, even the vendors doing the BIM model. That's really great.
So I think what we say is, from the architect side, from the drawing side, the concept side, we're able to get to a certain point. Then when the tender is released, it's in paper, it reaches the shop floor, it is in 2D or lost. By the time it reaches the site, it has vanished. And then maintenance begins and everybody is running helter-skelter. So I think one of the things is there is a huge service opportunity to run 50 years of a building, I think that's a clean entrepreneurial opportunity. But if you don't bridge the gap, and at handover, if you don't have a digital running twin, which is close to real life, all that means nothing. So I think that's the effort that has to be put in, the mindset shift, the education, the small investment, the little nudges, I think you mentioned. Everybody has to push together, all vendors, all stakeholders, to get that done. What do you think from your...
Yeah, just one point, I think what Ritesh has said, apart from probably the South Asian countries, most of the other countries have moved to BIM. And that's actually a right statement. And we like or we don't like unless and until something is imposed on us. Even if the traffic police is not putting a fine, we don't love to wear a helmet. So I think that has to get into. So as a I would say end user, the developer or the corporate end user or whoever it is, whoever is basically paying the money, if they impose it saying that you have to, like how shop drawing was not a mandatory thing probably 15 years back. Okay, so it came in saying that unless and until you keep the shop drawing, your 10% is stuck with the developer. So the same thing if we implement saying that unless and until you do the shop drawing in say LOD 350 and give me the as-built drawing in LOD 500, and unless and until my digital twin is up, I'm not going to release your.
So I don't pay you for shop drawings. I pay you for L500.
Yeah. So relate it to the amount that needs to be released, and that is when probably we understand the fine, and then we'll probably start working towards that.
That's a dangerous statement with two investors sitting. They're already running through the numbers.
I think what will work very well, and I think what has worked in some of the Western world is at a policy level, right? At a policy level, see, everybody is very serious about submission, about their basic submission drawings, sanction drawings, OC drawings. I think it should be mandatory moving forward that the submission drawings, building submission drawings will be submitted in 3D, right? That's what I remember while I was working in the UK, I think somewhere in 2012, they made it mandatory, all in London at least, that all the building planning approvals will be submitted in 3D BIM. And that was at a policy level, right? If you make that like beyond a certain scale, you should say, or let's say all commercial projects beyond 100,000 square feet or 100,000 square meter needs to make submission in a 3D BIM with integration of all services and how those services are getting connected to the government lines, right? And parallelly, I think also at a government infrastructure level, the government should invest in making the larger 3D BIM models of the infrastructure of the city. And then while people are submitting their plots or specific projects into BIM, that should get plugged into the model of the city. So that's how you will achieve true digitization. And that's what you have seen successfully being done in most large cities in the world. I think that along with the end users and people like us pushing, I think that will help in gaining more momentum.
I think that was a really interesting discussion because I think if I can summarize, you wanted to say something, sir? Yeah.
See, progressive real estate developers who have understood the value of 3D model, they are mandating it now to all design consulting that you have to do it in BIM. Otherwise, we will not take you on board. Second level step is now happening is that the tender documents which are going to all the bidders also says, in some cases we even specify there is a line item against which you have to quote and that money is released to you when you do that. The rest of the ecosystem will catch up soon. There's some organization which are leading it. For example, where I am working, it is by default who wants to work with us have to be BIM enabled. Otherwise, we don't consider that.
So I think summarizing, yes, of course, there are challenges, but the message I think here is change will come from the top, starting maybe at the policy level in certain sectors, maybe government projects. And I'm aware of some of the government projects we have the chance to work on. It is 100% BIM from day one. Maybe they already think, but pushing. And I think when we work on BIS committees, we work on our committees, we should push for this. Maybe that's a topic coming top down. The second, what you're saying is push from the investors level. The investor is thinking 50 years, not 5 years. So make it mandatory to get clean data at handover.
and link it to fines or payments, so that from what you have conceptualized at the architectural level, people make the bridge and bring it closer to reality before getting paid. And outside, I think you said something really interesting. Yes, people will get paid, but you get an extra X for finishing, but Y for making it L500. So that there is a positive incentive or a fine. I think either a carrot or a stick in that sense, with the goal that the investor pushes top down, right? And makes that happen so that the ecosystem flows in. And the last was, I think, from a residential perspective, or the investor perspective, the value of that data to sell the building or to realize the profit. So I think there's a lot to take away, but change looks like starts from the top, and all of us have a chance to push the pedal and otherwise get left behind.
I wanted to add here. See, for example, Nitin's portfolio and my previous organization's portfolio runs in million square feet. And every year when financial budgeting is required, where OPEX is calculated and CAPEX required to run the facility, it unfortunately run on Excel sheets and papers. And most of them are approximation either on a higher side or a lower side. Both are harmful to the facility. So more and more organizations are realizing that having this digital data about how to run and maintain a facility is becoming critical, because cost of a unknown shutdown is quite an expensive affair. It is 10 times costlier, and it's a loss of face and loss of revenue to developers. So there's a cost to lose this. Hence, we are all going to make it happen mandatory very soon.
And since we are approaching the end, I wanted to just go around and I think look for one little lamp or a light at the end of the tunnel or in the middle of the tunnel. Maybe a best practice example from your vast experiences of a project or a use case or an application in the value chain where you say, hey, this project went well and it captured the essence of what we are discussing. The investor data was there, the investor pushed, the ecosystem pushed along, incentives worked, the design intent reflected into reality. So maybe if we could each take a minute and just say, hey, this project, this worked, and this is how we should do things. That would be enlightening.
So I would like to answer this point with the question that you raised slightly earlier. You said that, okay, BIM model is there, but in tender drawings, you have to send hard copies to site. Then it gets missed. Whatever happens to it happens. But I know of industries where they've completely replaced paper. They are only having the BIM model or the BIM data, and they're using iPads or tablets at site, and that is how they're getting the entire thing done. So you imagine the amount of paper that is being saved. And as architects, when we make changes, I sort of feel bad that you have 7 copies of prints to be sent. You make a slight change, you have to again send them. So you are actually wasting a lot of paper, and that is not very sustainable. So that aspect also is there in BIM, where you can actually completely avoid paper. You can use technology, you can use displays, and you can get things done at site. There are lasers, robotic systems that can mark things right at site, and there's a lot of potential there. So I just want to answer that.
I would like to come to the point which you were just saying about a project which would have been rightly executed. For some reason, luck you can call it. It's a very rare situation in India, I would say. I mean, it was way back in, 5 years back, it would be. We got a chance to design an intensely complicated pharma project. So it is complex in terms of how many gases that is flowing into the labs, how many types of liquids that is. So without the usage of a BIM, it's difficult for a person to understand the complexity of it. So here the investor wanted, which is in turn the client, focused, and they wanted exactly every detail to be shown to them, also discussed with them. So in turn, we had to adopt to 100% BIM, not 100% I would say, but to an extent, it was a very good example, I would say.
And it was matched to the site conditions finally?
Yeah, exactly. So it is, I'll say for an example, we architects were able to produce a model in BIM. We discussed with the structural consultants, they were also able to submit the design in BIM. Even the more complex stuff stays with the consultants who are going to plan for the services. They were also able to provide it in the BIM language. So we did an intense clash test to understand. In real time, even we were convinced, even the client was convinced that it is going to work exactly. And we did even get a recognition for that, for being the fastest precast construction by Indian Concrete Institute. We were able to finish down the whole of the project, the superstructure, including interiors, in 12 months. So we had to take up a precast construction strategy for that. But apart from it, too, I cannot convey that it will not be. I mean, it was not rightly followed on the site in terms of how each and every day-to-day progress was made, updated back to the BIM software. But even the site team had a control. They were able to check on the model as to if they are rightly executing things.
Cool. Any other examples that shed light on?
I'll not say 100%, but in my previous role at Morphogenesis, I was working on the Surya Diamond Boost project. I think that was one of the examples of large-scale application. We didn't do it 100%, but at least the structure and the services, and on this massive scale, I think that was quite helpful. And the speed at which that project got finished and the scale of that project is a testament to how we can use BIM at scale to get that to work with a large team and also multiple vendors at site. I think that was one of the most successful example I would imagine in my career.
And this was driven by the investor down?
So Surya Diamond Boards is not really a investor-focused project. It's like a cooperative where people, 4,500 diamond traders, came together and decided that they will do the building. So it was a joint decision between the committee and the architects and the PMC that we should do it. And I think, but we understood the limitations and let's do it for structure MEP, which is the most complex part of the project. I think for the scope which it was designed, I think it delivered great results.
If you asked previous example whether it's really worth investing money in digitization, in 2020, I led a design for a 1.1 million square feet commercial building, A+ grade, in a very prime location in Bengaluru. And initially it was decided that all the reputed design consultants are engaged, they let everybody do 2D. It was done, schematic signed off. Then I said, wait a minute, let's engage a third party to do the BIM model only on critical floors, basement 2, basement 1, ground floor and podium level. That's where a lot of problem comes. So when we run that BIM model, we discovered 82 clashes. Now these 82 clashes, you don't get it in the beginning because construction will happen on an RCC seamless. You will start finding the clashes only when you start putting your MEP services. Then suddenly says, sir, this beam is coming in between. Our column is here, I don't know, shall we chip this, core cut this? And it comes, you discover those clashes where you are under tremendous time pressure to deliver. And too many laborers, and you will have some 20 agencies working at site simultaneously. You are squeezed to get the OC. Even if somebody says there is a problem, you do not have mind space to address those. So it's very, very important that as soon as you hit the schematic 50, have your BIM model. When you say you are going to close schematic 100, including every consultant. Don't leave anybody. Don't even leave landscape, even though it's outside building. Get it done, find the clash detection, lock everybody in a room till they solve that problem. Then you can let them go.
Great.
Agreed?
Any other?
So I think we've been fortunate to work with few corporate clients where, as a part of their corporate mandate, we have to do the digital twin, beam the whole phase and the digital twin. So one of the first project what we did a couple of years back, when we completed the complete project, including BIM LOD 500 and digital twin completed and handed over to the facilities team, they actually were fascinated, the facilities team. And as Ritesh has told some time back, unless and until you show them what is the benefit that they're going to get, so they know that in one system, every kind of component of the project, be it facade, be it your services, be it anything, okay, everywhere they know that how even the smallest of the cable has gone, what are the chances and all those things. And then they made it mandatory that whatever project they're doing in India, digital twin is a mandatory thing. So yes, it's important, and I think that push is required for us to get to the next level.
Great. So,
yeah, 3 minutes more. I want to give a new point to everybody. When you do in BIM, after schematic design, please engage with whoever is involved. Ask them from the time it comes in trucks, gets unloaded, and reaches where it is supposed to reach. That material, that product, whether it is AHU, chiller, DG, HSD, facade, unitized system, make a simulation and run it first. Second simulation, you have to run it after 10 years down the lane. How will you remove the chiller from there? That simulation also has to be done. Recently in Chennai, I have to remove 4 chillers because they are outdated. They are energy guzzlers. I want to install new scroll or magnetic chiller. It was a Herculean task. I have to break open walls. Nobody thought of it, but the chiller has only that much of life. You have to replace them, if not today or tomorrow. Similarly, everything has to be replaced. You have to have an imaginary simulation done for the building maybe at the initial time or at the later stage, how it will be removed and how new one will be done. Remember that 10 years down the line, it's a live office. I cannot take the luxury of months together. I will do it aram se. You have to do it in hours. It's a live office.
Great. So, in the spirit of being digital, we are well on time. So I'm going to just quickly summarize. I think a big learning here is building takes 5 years to build. It's operated for 50 years. The opportunity is in the 50 years for the investor. The second, I think, is top-down change management, policy level, investor level. Bring the ecosystem along, either with a carrot or a stick, so that everybody moves. And there are positive case studies of everybody here having lived through it. And I'm fortunate, we did a couple of projects now, doing with Brookfield, with Maya Estates, with each of you. I think the industry is moving investor down. And I think third, both from a time, quality, and profit perspective, this is a must do, or we get left way behind. Right? So on that happy note, I'd like to thank each of the panelists and for the audience for being patient through this. And with the ridiculous time of 28 seconds left on the clock, we are finishing on time.
Thank you.
Thank you very much, Shyam, and thank you all the panelists and all the other speakers today. We've had a wonderful day. Thank you, Shyam. Thank you all the panelists.
I'll do that. Before that, as I mentioned this morning, we've recorded today's event. We'll share a YouTube link with you, which you can access a week from now. And I hope you enjoyed today's edition until we return next time around. And we hope to bring new stories, new speakers at the next edition. And just before we end, a round of applause for our event host, Rohan Keswani from Aluplex. Did a fabulous job. Our event sponsors for sponsoring this event year in, year out. And we look forward to hosting you all next time very soon. Thank you so much.